1, 2.
3, 4.
We'll start a little late, but just before we start, some speaker left some buggy here yesterday. I don't know. I think it was in the morning, so if somebody is missing.
Wait, 1, 2, 3, 4. Great, thank you. No rush. Everything great. Yeah.
Se ongelma on tavallaan just siis siinä, että sen sijaan, että jengi toisenkaan niin täysin järsyttävää uutta, niin siellä on enemmänkin niin joko samat virheet tai samat kysymykset tai semmoiset. Niin kuin, että... Osa pyörittää sitä samaa tahkoa, se johtuu siitä koko prosessista, mitä filosofia nyt on tehnyt. Kyllä. Sitten ne unohtuu tänne peruskäsitteet ja sitten ne ongelmat tulee sieltä kaupan ja
Good morning, everyone. Welcome to the final day of the conference. We'll pick up from where we were left yesterday, pretty much. So on the topic of free will and more specifically neuroscience. I'm very pleased to welcome our first speaker for the day, Professor Liad Mudrik from Tel Aviv at the School of Psychological Sciences, and also I think a leader of a lab on high-level cognition. Topic you can see on the slides there.
Thank you very much, and I'm very, very happy to be here. Sorry to have missed the first day due to some commitment I had in Israel, but was very glad to join you yesterday and enjoyed the talks very much. So thank you for inviting me. I was particularly excited about this conference because it's a an opportunity to engage in a collaboration and collaborative discussion between philosophers and neuroscientists, and also people from other disciplines like physics and so on and so forth. And I think that in the type of questions that we are dealing with, such interdisciplinary dialogue is extremely important. And I'm going to try and show or demonstrate how we try to engage in such a dialogue and collaborative research and interdisciplinary approach when dealing with questions of free will and consciousness. So the talk today will first highlight the challenge of trying to build bridges between these disciplines, and then try to show how we did that or tried to do that with respect to questions about brain-mind relations, phenomenal versus access consciousness, and the question of free will. So let's start with the challenge. Since I started my studies at the university, I've always been fascinated by this inscription by Socrates, "Know thyself." And we are trying to understand ourselves as human beings, as subjects, as thinkers for centuries, and even thousands of years now. And typically, knowing ourselves, or for hundreds of years, has been done from the philosophical armchair. So philosophers trying to engage in conceptual thinking, trying to solve long-lasting questions that have accompanied us since the beginning of humanity, more or less. But in recent decades, it seems as if the neuroscientists are also kind of aiming at the very same questions that for years have been considered even outside the reach of neuroscientific research. So, for example, you could have studies about the basis of love, or the basis of rationality, or consciousness, or free will, as we're going to talk now. And I find it extremely interesting to see how empirical sciences are now trying to answer these questions, applying their own tools, some of them even saying sentences which I don't really like, such as, philosophers tried to solve it for hundreds of years, they failed miserably, now comes neuroscience, and we will solve the problem. I think that it's a way more complicated topic than what these people sometimes say, and it poses specific challenges. So the first challenge is to define the theoretical construct. So how can we translate the philosophical construct, which is complicated and multifaceted, into a psychological, empirical one? The second challenge is to find the right operational definition. So once we already defined our psychological construct and we know what is the psychological phenomenon that we want to study, how can that be translated into a testable empirical definition or question? And finally, interpreting the results. So at the end of the day, we conducted our research, we found our results, and then we want to translate them back into the philosophical domain and understand how they might be able to inform philosophical discussions, and that also presents some difficulties of its own. So these are the three challenges that I'm going to try and address throughout this talk. And I'll start doing so with the question of brain and mind relations, or testing theories of consciousness. So we've already heard yesterday, and I imagine you probably also discussed it over the first day, about the hard problem of consciousness, famously put forth by David Chalmers, who wrote, why is it that when our cognitive systems engage in visual and auditory information processing, we have visual or auditory experience? The quality of deep blue, the sensation of middle C. How can we explain why there is something it is like to entertain a mental image or to experience an emotion? It is widely agreed that experience arises from physical bases, but we have no good explanation of why and how it so arises. And this famously framed a discussion about consciousness since the 90s. And in fact, there have been several theories of consciousness that tried to answer this question. Some of them even explicitly say that they are trying to tackle the hard problem. Some of them say we focus on the easier problems of consciousness, but all of them are trying to explain how conscious experiences arise from neural activity. And I don't have time to go into these theories, but I will mention four of them and very briefly give the defining principle of each one. So the first is the global neuronal workspace, suggested by Stanislas Dehaene and Lionel Nakash, following Bernard Barr's work about the global workspace. And there the idea is that unconscious information is being processed by specified, specialized modules, but it's encapsulated. So each one of these modules operates in isolation, and it is only when the information crosses some threshold and is amplified by attention, when it enters this global neuronal workspace, it is broadcasted throughout the brain, and that's when we are conscious of that information as opposed to unconsciously processing it. The second theory, the integrated information theory, you've heard about it from Larissa, I believe, in the first day. So you already know what the theory is all about, but in a nutshell, it starts from 5 axioms that are supposed to characterize conscious experiences as they appear in nature, and then tries to ask what are the requirements of a physical system that would indeed be able to implement or to have those axioms. And then the 5 postulates are drawn, and they make different conclusions about also the physical substrate in the brain that is supposed to be the seat of consciousness. One of the predictions relates to the grid structure, which, according to them, suggests that it should be posterior rather than frontal. We have the theory of higher order thought, interestingly enough, first developed by a philosopher, David Rosenthal, but then translated into neuroscience by people like Hak-Wan Lau and others. And what this theory basically claims is that if you have a first order representation of the sensory experience, it will not be conscious unless there is a higher order state, supposedly mediated by frontal areas, that kind of points at it and say, this is what I am conscious of now. And that is what enables this information to become consciously experienced and not only unconsciously processed. And finally, recurrent processing theory, suggested by Victor Lame, is the idea that what is needed for consciousness to unfold is only recurrent processing within primary sensory areas. So here, the idea is that we can differentiate between consciousness and attention. And although attention is needed for report and for cognitive manipulations over the conscious information, it is enough to have recurrent processing within the sensory areas for a piece of information to become conscious. So you have these 4 different theories of consciousness. I should say 4 out of many. In our field, there are many theories of consciousness, but I dare to say that these are the leading 4 theories that have been discussed mostly and studied mostly. And what we tried to do in a project that was led by Itai Yaron, a PhD student in my lab, together with Michael Pitts and Lucia Meloni, was to ask, was to observe that each theory seems to support itself. So if you read review papers by the leaders of these theories, what you'll find is that you get very different worldviews about what is the neural basis of consciousness. And it's even sometimes somewhat confusing. And our field indeed is highly fractionated. So we have these camps, each one supporting their own theory, with very, very little crosstalk between the theories. So you don't see many collaborative efforts to test the theories in one project, and you don't see many influences from one theory to the other. And another thing that that characterizes our field is that it is very heterogeneous with respect to the methods that people use. So when we thought about this state of affairs, we wanted to ask, let's try to characterize how these 4 theories have been empirically studied in order to understand why we fail to converge onto one agreed upon theory or concept of consciousness and the neural basis of this phenomena. So what Itai did basically was to collect all empirical studies, neuroscientific studies, so not behavioral ones, so all behavioral studies that mentioned these 4 theories. And we had different selection criteria, started with about 7,000 papers. He actually read 884 of them, excluded 500, a bit more over than 500, and we were left with 365 papers that reported 412 experiments. And then we wanted to characterize how these experiments handle these 4 theories. So the first thing we wanted to see is which theories have been studied by which papers, and we found that GNW, Global Neuronal Workspace, has been studied most widely. But that's maybe something, and by the way, I should say about higher order thought, there are many philosophical papers about it, but relatively few empirical papers that try to actually tackle it experimentally. But one thing you can already see is that almost for all theories, you have way more supporting papers than challenging papers. And this to us is a demonstration of a confirmatory bias. So much like many other fields in science, we see that we have more papers that interpret their findings as supporting the theory rather than challenging it. So then we said maybe this is because our field is relatively new. Maybe if we inspect this over time, we'll see that with time, we have more and more challenging papers and fewer supporting papers. But that's actually not what we find. When we inspect the trends over time, we see that all 4 theories have been gaining support with time, and there is an increase. Okay, so I see that my titles are missing. I apologize for that. So this is just the papers that mention the theories. These are papers that support the theories, and these are papers that challenge the theories. And you also don't see a situation where one theory thrives and the other theories, fail to continue gaining support. No, they just all seem to be supported more and more with time, which suggests limited crosstalk. But then one thing we wanted to ask was, what do we see when we collapse all these studies together? What do we find with respect to the neural basis of consciousness? And I should say this is not a meta-analysis. We did not conduct any statistical analysis of the results. We simply counted the number of times a certain brain area was mentioned as a neural correlate of consciousness, differentiated between conscious and unconscious processing. And what we found when we collapsed all these papers together was that almost the entire brain lit up as a neural correlate of consciousness, perhaps besides the cerebellum, as you can see, which is good, but still. But strikingly, when you divide these papers into the theories they ended up supporting, you find 4 very different pictures. So when you look at papers that supported recurrent processing theory, you find mostly posterior activations. When you look at papers that supported global neuronal workspace, you find frontal activations, which is very much in line with the theory's prediction. So this raises the concern that there is some bias in the way people interpret their findings, and possibly also in the way they conduct their studies to begin with. In order to test if this might be indeed the case, what Itai did was to say, okay, we know that there are many, many different methods used in the field. Maybe the methods or the methodological choices that people make when they design their experiments are already biasing the experiments towards a certain result or towards a certain conclusion supporting one theory or another. So what Itai did was to use a random forest classifier, and it fed what the classifier only received the methodological aspects of the studies. So for example, was it conducted on healthy subjects or on patients? Did it use report in the experiment? What method did it use? fMRI, MEG, EEG, and so on and so forth. Having no information about the actual result, just the methodological choices of the researchers. And the question was, could we still predict which theory is about to be supported even without knowing the results? And lo and behold, we can. And we can to a degree of 80%. So I should say the baseline is already pretty high because, as you've seen before, the division to theories is not equal. So even if the classifier always said GNW, it had a high chance of succeeding because GNW was the theory that was studied most. So that's why we already had our baseline way higher than 50%. But still, you can see that we can predict way beyond that for all theories together, but also for each theory separately. And we also identified the important factors that drove this classification. Did the study involve report or not? Did it study state consciousness, so sleep, coma, locked-in syndrome as opposed to wakefulness and so on, or content consciousness, where I take a stimulus and I render it invisible using some psychophysical manipulation, what types of consciousness measures were used, and if connectivity measures were used. So when we found this result, we found it to be pretty alarming and thought that the field, to the very least, needs to reconsider the way it has been conducting itself. And what Itai also did, and I welcome you all to go online and connect to this contrast data set. I'm happy to later on also give the link if you want, is we have this now online website where people can just log in and they can conduct their own queries on our data set. So you can, for example, find all the studies that studied faces with fMRI. You can download the CSV with all of that. You can explore how different parameters are differently divided for the different theories and find trends yourself if you're interested. And there are also other stuff you can do here. I won't bore you with the details, but you can look at the methodologies and how they divide to theories. And you can even at the end look at how the different theories are supported in different countries. So here, by the way, you could look at effects over time. And I think that at the end of this video, I also show which countries support with which theories. That's just for fun. So we hope that this resource will be valuable for people in the community, newcomers and experts alike, that want to just know how these theories have been tested. But it also highlights this problem of taking a very complicated philosophical question, translating that into a theoretical construct, and then finding the right operational definition. And you can see here that with the different operational definitions, we also reach different conclusions and interpret our results differently. So that's one example I wanted to focus on. And the second one relates to the differentiation between phenomenal consciousness and access consciousness. So this is a famous distinction made by the philosopher Ned Block, who would try to claim that actually when we talk about consciousness, we should differentiate between two different phenomena or constructs. One is phenomenal consciousness, which is, if you want, what it is like to feel something, the qualitative aspect of experience, the subjective nature of it. What makes a state phenomenally conscious is that there is something it is like to be in that state. While on the other hand, you have access consciousness. And access consciousness refers to our ability to report this content of experience, to perform cognitive functions on it. So this refers to the system or the organism having access to that piece of information. It doesn't necessarily have to have qualitative aspect to it. So kind of what Block tries to tease apart is the qualitative nature of conscious experiences and their cognitive access to the system, the cognitive availability. So the fact that I am able to say, I am now tasting chocolate, that means that the system has access to that. The taste of chocolate is the phenomenal aspect of it. And I know that you discussed AI on the first day. I think most of us won't have problems with AI having access consciousness, so being able to report that they have access to that piece of information, but the problem really lies in phenomenal consciousness, where we would be interested to see if they have such a thing. Now, this distinction has been widely discussed and debated, and by no means is it consensual that we should just tease these two aspects of consciousness apart. And there have been some studies that try to test it experimentally. And again, I think that consciousness is one of the fields where you can see very interesting dialogues between philosophers and scientists. But the problem is that phenomenal consciousness is very hard to study in isolation. Because how would I know what is the phenomenal aspect of your experience without asking you? And typically, indeed, phenomenal consciousness and access consciousness go hand in hand. So there are some experiments, for example, this one from Marius Uscher's group, where they tried to show that we have that basically consciousness, or the phenomenal aspect of consciousness, is richer than what we can report. So our access consciousness in a way is narrower than, sorry, excuse my poor accent, than the phenomenal aspect of consciousness. But this is only indirectly testing the question. We wanted to ask, can we empirically tease apart phenomenal and access consciousness and actually show that that there are cases where they don't go together? And Bloch typically gives this example of constructions, or you can think about your refrigerator at home. So you're now working at home, and someone asks you, do you hear any noise? And you say, no, I don't. Everything is super quiet. But then the refrigerator stops making its annoying noise. And in retrospect, you actually realize that you've been hearing this refrigerator all the time. In real time, when I asked you, you had no access to that piece of information, but now that it stops, not only do you know that you heard it, you also have access to the qualitative aspect of it. So you know not only that there was a noise, but you also have a representation of the type of noise, or of the qualitative nature of that noise. You know how it sounded like, right? So we were trying to think, can we mimic this in the lab and create a situation where subjects will indeed have no access in real time to a piece of information, but then when we stop it, they will have retroactive access and also have information about the phenomenal aspect of it. And this was led by Yoni Amir, a student of mine, in collaboration with Yossi Yovel and Yaniv Asaf in Tel Aviv University. And Yoni is a very, very creative student. So when I kind of threw this problem at him, he came up with one of the craziest experiments I've ever conducted. I'll demonstrate in a second. But basically what happened is that we presented subjects with a mixture of noises, and each time we asked them, do you hear cats? Do you hear sheep? Do you hear... And each time when they said yes or no, we removed one of the sounds. So gradually you hear less and less sounds, until at the end we ask you, do you hear something? And then we leave in the background this pink noise, very quiet pink noise that stays there throughout. And after all these weird sounds are turned off, we ask you, do you hear something? And sometimes you do, sometimes you don't. Then we stop it, much like the refrigerator example, and we ask them, did you hear a change? And if so, what was presented? So let me show you how it goes on. As I said, it's going to be a bit funny. So, I forgot that So you hear all these sounds, and we ask you, do you hear cats? Do you hear dogs? Do you hear a baby laughing? At some point, we just ask you if you hear something. And if you're sure, and there is this white noise, and then we stop it, and we ask if something has just changed. And if it has, we present 3 different noises, or 2, I think in this case, and ask which one was it. So what we are basically trying to achieve here is to get to this state where there is an ongoing noise, you adapt to it, because at the beginning you hear all these different noises at the beginning, different sounds, and then sometimes you just won't hear it. But when it stops, you hear that it stopped. The point here was that we wanted to reach a unique situation where 3 conditions will be met. First is that in real time, while the noise is playing, subjects will deny hearing it. So they will have no online access to the experience. Second is that they will have retrospective qualia. So after the noise stops and you notice the change, you don't only know that something has changed, you also have access to the qualitative aspect of it. And the most challenging part was to say, okay, but we also need to show that this is not simply unconscious processing. Because if this is unconscious processing, then we can't really say much about this being a phenomenal experience on its own. So to do that, we basically defined 3 types of trials. A trial, or a consciousness trial, is a trial where subjects actually heard the background pink noise while it was playing. So they heard the noise, So the background noise was playing, that's true for all trials, but they also heard it when we asked them, and of course they also heard the change. The critical trial is a peak consciousness trial, where the noise was playing, they did not hear it in real time, but they heard the change afterwards. And no consciousness trial, the pink noise is still playing, they didn't hear the noise in real time, and they also didn't hear the change, which also happened. So how did the data look like? So as you can see, the vast majority of trials were A trials, where they actually heard the noise. And the more they experienced, so this is, we just binned the trials into 8 different bins. So this is basically time. And this is the number of trials for each one of these types. So the more the experience progressed, the more they heard this noise, which makes sense because they practice. But you can also see that even in the 8th bin, they still had very few, but had these, every once in a while, they had this no consciousness trial where they didn't hear anything, including the change, and they had a P trial where they heard something only after the change. Now, importantly, we only included subjects, this is rare. So most subjects just hear it. So we only included subjects who had more than 4 P trials throughout the experiment, and you can see that the vast majority of subjects actually didn't have those. So just to be very, very clear about it, separating P consciousness and A consciousness is a great challenge, and typically it just doesn't happen because we have access and we have phenomenal experience to the information that we access. But what we basically try to show here is that there are some situations where these two constructs can be separated. And that's what we found. So there is no online access, and now the next question is, do they have retrospective qualia? So it's not enough for us that they hear the change, can they also tell us what was presented in this trial? So in order to do that, we had this objective task. We asked them to report which one of 2 noises it was. In A trials, they are very high in doing so, so above 75%. But interestingly, also in peak consciousness trials, they're about 60% correct in determining which sound it actually was. So it seems like there is retrospective qualia. But then we can ask, could it just be unconscious processing? So are they just now pulling the information they already have? For that, we can look at no consciousness trials, where they didn't hear the change, but they still had the stimulus presented all the time. So then this on its own, if this is only unconscious processing, should have been enough. But you don't find that. So for unconscious trials, we don't get above chance performance in determining which of the 2 sounds it was. So it's not unconscious processing. We still tested if this might be just the offset. So you just hear the offset of the sound. Maybe the offset on its own allows you to extract the information that is needed in order to answer the question. So we conducted another experiment where these sounds were not, the pink noise was not presented throughout, only at the end for a very short duration. We manipulated these durations, and we asked if they could show above chance performance. And in some cases, they do, when it's 60 milliseconds, but in all other cases, they don't, suggesting that, that the offset itself is not enough, or at least probably not enough to explain these results. So this work, as far as I'm concerned, is just an attempt to take a complicated philosophical question and try to translate that into an empirical study, and hopefully show that there are instances in real life where this distinction actually holds. Now, you know, it's not as if I have tons of problems with a P versus A distinction. And I think the most critical one is what does it mean to have a phenomenal experience to which you don't even have access? And how is that different from unconscious processing? So I started this project very, very skeptical. And I'm still skeptical of the theory on its own, but at least I know that it's not a void dissociation, because there is some, I think, empirical evidence showing that in some conditions, this dissociation actually holds. Now, I will end with the question of free will. And free will, as many of you know much better than me, I guess, has multiple definitions. So you can think about free will as lack of external constraints. You can think about it as indeterminism, which relates to the keynote talk we've all heard yesterday. You can think about it as an emergent property, as a conscious process. So if the decision is made unconsciously, it's not free. Again, you can think about it through the lenses of higher order thought, or a reason responsiveness. I am going to focus on definitions of free will as a conscious decision. Why? Because this has been the major endeavor in science when trying to tackle this question, starting from the very famous work by Benjamin Libet, which I guess needs no introduction in this crowd, where subjects were asked to move flex their wrist when they felt the conscious urge to do so, and report when they felt that urge. And famously, Libet found the readiness potential starting about half a second before subjects reported their conscious will to move their finger or their arm, depending on which experiment it was. Now, this, as you know, has been taken as evidence against free will, with multiple books written on it. One of the most well-known is by Wegener, about the illusion of conscious will, because the idea was that if the brain already initiates the action before we have the conscious urge to move, and so our consciousness does not play a causal role in decision-making, and at least for this type of decision, then the decision cannot be free, because consciousness here is equated with free will. So this is already a matter of interpreting the results of an operational definition, and so on. But then one thing that I, together with Uri Maoz, a very close collaborator of mine, thought about at the time, and I think it was actually Uri who thought about it first, was to say, okay, but all these studies, so on the face of it, it seems as if, people like Hamlet asking if they want to be or not to be, they shouldn't worry or shouldn't spend their time in all this conscious deliberation, because at the end of the day, the decision is not made consciously. So we should maybe forego all these conscious deliberations. But then what Uri and I noticed was that all these studies actually focused on decisions that in philosophy are called picking decisions. So this is a distinction made by Ulan Margalit and Morgenbesser. And together with the philosopher Gidon Yaffe and our mentor at the time, Christoph Koch, both Uri and I were postdocs in his lab, we said, wait, maybe it's not such a big surprise that consciousness does not play a causal role in picking decisions. Picking decisions are basically where you go to the supermarket, this is just an example, and you already know which type of milk you want to get, and there are now 10 identical milk bottles of the very same expiration date, the very same brand, and you just randomly pick one. This is very different, and here you might see the difference in color between the lids here. This is very different from a situation where you don't know which brand you want. Do you want whole milk? Do you want skim milk? Do you want the expensive or the cheap one? So now you have to weigh different reasons in your decision and make a choosing decision which has consequences and is deliberate. So we have very different types of decisions, and all our findings about free will are focused on picking decisions. So if we go back to this, to be or not to be question, all the studies in neuroscience studying this question did not have subjects decide if they want to be or not to be. Subjects basically decided if they want to move or not to move. And Uri and I thought that this is actually not the question, because when these findings are later interpreted as the illusion of free will and lack of moral responsibility, the discussion is always framed around choosing decisions and not about picking decisions. So even if we don't have free will for which milk bottle we're going to pick, when it comes to moral decisions, maybe we do. Maybe consciousness there is more involved in the decision making. So what we wanted to do, and this is again a question of how to interpret the empirical results. This is a clear case where neuroscientific results have been taken as bases for philosophical accounts and psychological ones. So we kind of went back to the drawing board and tried to come up with an experiment where we could compare picking and choosing decisions and examine the role of consciousness in those. So to do so, what we did was to present subjects with different non-profit organizations, and we had them rate which organizations they favor. And as you can see, there were some that are more consensual and other that are less. So we had a variety of, we wanted to have a variety of opinions. And then for each and every subject, we tailor-made a specific experiment based on their own choices. So what we did was to present easy and hard decisions. So in each trial, there were two causes that were pitted one against each other. And in the choosing condition, subjects knew that every decision that they make could translate into a potential $1,000 donation in their behalf to that organization that they chose. And I was actually very nervous that one of the bad organizations would get the money, but at the end of the day, because we actually donated them, but I think it went to Bill Gates and so on, so, like the Bill Gates, Melinda Gates Foundation. So we had these decisions, and that was the choosing or the deliberate condition. And we had hard decisions where the difference between the organizations was only 1 point. And we also had easy decisions where the difference was more than 4 points in one's own ratings. And then in the arbitrary block, the very same organizations were presented on screen, but at the end of the day, if this trial was selected, both organizations would get $500. So whatever you press, whether you press right or left, there is no consequence. And we actually told subjects, try to ignore the value here and just press right or left based on your random kind of preferences. So what we had here was a situation where the visual input is identical. The motor output is also identical because you're always pressing right or left, but the meaning of the decision is utterly different because here you're making a deliberate decision and here you're making an arbitrary one. And we ask them, this is how it looked like, we ask them to press the button, like to make the decision as soon as they have the conscious decision. So try to do it as quickly as possible. So they are presented with these organizations and then they make their decision. And this is the choosing condition. And in the picking condition, which comes here, you get the very same thing. Now, there is a concern, of course, that they won't even read the names in the picking condition. So in order to avoid that, every once in a while, we presented them with a memory test, referring to which one of 4 organizations appeared, and you could gain personal money for that. So that kind of reassured us that here is the memory test, that they are still reading the information and paying attention to it. So behavior indeed confirmed that they were doing the task, so decisions were way shorter for picking, and they didn't take account the value. So we see that they weren't prone, or they were just a little bit prone to choose based on their preferences, while in the choosing deliberative condition, they were very strongly affected by the preferences. And the big question was, what about the readiness potential? Will we find Libet's readiness potential also for deliberate decisions? So first, we find it for the arbitrary one. So you can see here, I always like to show individual subjects first, because I think it's very revealing. So you can see readiness potential for most subjects in the picking condition. This is just a replication of Libet. What happens in the choosing condition? Almost nothing. So now I can show you the average results. You see a very nice readiness potential with the expected, somewhat lateralized, but still the expected distribution for arbitrary decisions, and you don't get anything for the choosing decisions. And I won't get into that because I also don't have time, but Uri also added a computational model that was able to predict the findings that we actually got based on the assumption that everything that we are recording in this experiment in CZ is actually noise. So there is a very interesting paper by Aaron Sugar from 2012. If you haven't read it, I highly recommend it, suggesting that the readiness potential might actually be just an artificial accumulation of fluctuations that in random decisions drive your decision, because there is no other factor that would cause you to move now. So it's basically driven by the brain's random fluctuations. And this does support also what we find here. When we make an informed decision and we have to weigh values, then this noise will average out and we won't find the readiness potential. So it doesn't mean that deliberate decisions are not brain-based or cannot be predicted. Of course they are, but the only claim that we are making in this study is that the strongest evidence that neuroscience seems to have suggested against free will, or that has been interpreted as an evidence against free will, is only limited to picking decisions, does not generalize to choosing, to deliberate decisions, which we think are more interesting and more relevant for the free will debate. And to the very least, the claim should be revised or rethought of. So again, this shows you how the translation from a philosophical construct to a psychological one, the choice of Liad to focus on picking decisions, is a critical junction in this process. And if he had already then have subjects perform deliberate decisions, then maybe we wouldn't have been talking about the lack of free will based on neuroscience for 40 years. So it's the translation to a psychological construct, then into an empirical definition, and at the end, the way we go back from these factors to the philosophical domain. And I know that I have to finish. I just want to say two things. So just this work actually then led to Uri leading a global effort where philosophers and neuroscientists work together to study free will. So now every experiment that I conduct, Hans is also a part of this consortium, so you'll hear from him just now. So when I now conduct an experiment, I send it to a bunch of philosophers. They give me their view on the methods before I even conduct it. And then when we have the results, we discuss it again with them. And they give me feedback. So this interdisciplinary collaboration, I find, is highly helpful. And the same goes for another project that I am co-leading together with Lucia Meloni and Michael Pitts, where we try to arbitrate between theories of consciousness. So this is an adversarial collaboration with Giulio Tononi and Stanislas Dehaene, trying to test GNW and IIT. And we have David Chalmers and we have Francis Fallon, philosophers in the group, and their contribution to us being able to find opposing predictions of these theories have been extremely important. So I just want to kind of take this stage and raise a call or a voice for interdisciplinary studies. I wanted to say one word about another thing that came up from this group, which is a recent paper that was just actually this last week, I think, published in TICS, about unconscious effects on decision-making and how they might relate to free will. I won't go into that here because I don't have time, but I'm going to be very happy. I will be very happy to discuss that over lunch or dinner or what have you. So I just want to thank my group in Tel Aviv and my collaborators, and of course to you all for listening. So thank you very much.
Thank you very much indeed. We can probably fit in a question or two, Ron.
I think one.
Right there.
Thanks. Excellent talk. And I really love the picking versus choosing readiness potential results. But the study before that,
Yeah.
I was confused at how as you might imagine, I was really keen to see how you were going to exclude or perform the last operation, that is, exclude that it might be unconscious processing.
Yeah.
And so it seems there's a live hypothesis here that the processing about the qualitative content, the character of the sound, is done unconsciously, and there's only a P content during the access, during the after retrospectively. So you tried to rule it, well, okay, you say you rule it out because the performance is better than on the non-conscious trials. But I don't see how that works, because it could be that during the P trials, it's just a case where the unconscious processing is better than the unconscious processing in the non-conscious trials. And that's why you actually are able to retrospectively report the qualitative experience. So just because you found other non-conscious trials where the performance is lower doesn't mean that there isn't unconscious processing going on in the P trials.
So first of all, thank you. It's an excellent question, and I agree. We can ask why would that be the case. So the physical stimulation is identical in both of them. So at least there isn't anything in the manipulation itself that would lead to better unconscious processing in the P trials as opposed to the no consciousness trials. Now it could be that there is some internal process that makes you more focused on the unconscious information for the P trials, and that's why you hear the stimulus. That's why you have the retrospective access to begin with, which I think this is what you're trying to suggest. I wonder if there's any way to experimentally test that. And I think this is, in a way, one of the problems when trying to test this distinction is that it's very strongly rooted in the conceptual level. And then when you try to operationalize that, as you've seen here, there are many, many difficulties into it. So I'm very happy to try and think with you together on how one thing you could, for example, do, I guess, is to stop these trials and then see if there is an unconscious, like any indirect effect on a visible stimulus or an audible stimulus later on. If you're correct, then you should have a stronger representation on P trials than non-consciousness trials. But if you stop the trial anyway, you don't know if it should be P or no consciousness.
Right, so I guess one thing in your favor is that, as far as I understand it, you didn't choose the auditory stimuli to be near the borderline of subliminality, right? So if you did, where you set it so that it's 50%, yeah, then I think my story would be, my worry would be stronger. But you're right, since you're way above it's supraliminal or whatever you would say, because it's way above threshold.
Yeah.
Then it seems pretty unlikely that there would be, it would be hard to explain why there would be unconscious processing in one case, but not unconscious processing. So
yeah, that was our rationale.
I think you're in a stronger position than I thought. Yeah, thank you.
Okay, thank you.
We're rather running over time, but there was a question. I'll take a quick question from back there. We'll run a little bit over.
This was really a fantastic talk. Thanks.
Thank you. Thank you.
Two questions, if I'm allowed to pose them. The first is to the readiness potential. If I understood you correctly, the more deliberate the free will decision is, the more negative is the readiness potential, according to what you found. Is this correct?
Yeah, we just didn't find the readiness potential for deliberate decisions. We didn't gradually manipulate them. So
but you had
yes.
more negativity. Are you aware of a study from Freiburg, Germany, where they found, if you look in single trials, that 70% of the single trials have a negative slope, but 30% have a positive slope of the of the readiness potential?
Yeah.
Are you aware of that?
No.
No? I send you.
Please do.
Okay. Second question. You presented 4 theories of consciousness. What is your favorite?
So because I'm involved in this adversarial collaboration, I take a strong stand of being Switzerland, so being neutral between GNW and IIT, but also irrespective of my role as an arbitrator, so to speak. I think, so my personal view is that none of them seems to be working in full. So at the end of the day, I think also for our collaborative effort, what would happen was that we would probably find evidence against different predictions of one theory and other predictions of another, so it wouldn't be like all or none for GNW or IIT. And I think the challenge of our field is to take the good parts of all these theories and come up with a new one that integrates them all, and let's see if we manage to do that. Thank you very much.
We'll go straight on to Professor Hans Liljenström, Director for Agora for Biosystems and Professor in Biometry at Uppsala.
Thank you very much. Thank you, Liad, for a good presentation, which I will allude to later. And thank you, Paavo, and the other organizers for inviting me. And I also would like to congratulate the University of Helsinki for such a brave program and exciting program of mind and matter. I don't think that would pass in Sweden, but hopefully in the future. You're always ahead of us in Finland. So I will talk a little bit about, I've changed my title a little bit. I have a question first. What determines our behavior? because I think that is what we are actually asking ourselves. So I will talk about a little bit about that, and then I will talk about something called the Freeman neurodynamics and intentionality related to free will. And this project that Liad talked about, neurophilosophy of free will. So I don't want to talk too much about that since she already has introduced that. And decision making is where I will focus on, where we use neurocomputational modeling to trying to figure out what's going on in our brains when we make decisions. So typical choice, here we have a deliberate choice, I would say, if it comes to what to eat, for example. What should I buy for dinner? To the left, you have a lot of meat. To the right, you have fruits and vegetables. So there are many sort of differences in our thinking with regard to these choices. It's not just picking. So, for example, also where and how should I travel for vacation? If I'm concerned with climate change, maybe I shouldn't take the airplane, maybe I take the train instead, for example. Who should I vote for? All these questions are related to the deliberate choices that Liad was talking about. So what determines our choices? Are there deterministic natural laws? Is it chance? Other people? My genes? My brain? My consciousness? Or myself? Or is it all? This is some people have different views on this. And I would just mention a few of those views that are sort of dominating in science. Jacques Monod, the Nobel laureate, said that the first scientific postulate is the objectivity of nature. Nature does not have any intention or goal. The universe is not pregnant with life. I won't read everything here, but the idea here is that we are here because of chance. Chance is determining most things in nature. And this is what he wrote about chance and necessity. So necessity is for the natural laws that are supposed to be deterministic. These are the only two choices in natural science to explain that something happens, either by chance or by deterministic natural laws. This has been the view for hundreds of years. Richard Dawkins is another representative of the general view, saying that we and all our other animals are machines created by our genes. So all our behavior are determined by our genes. Francis Crick, he also he was working with Christoph Koch, of course, for many years, trying to find the neural correlates of consciousness. But he says that you are nothing but a pack of neurons. Everything about us, even including our free will, is due to our neurons. So this is an astonishing hypothesis, according to Francis Crick. Even my mentor at my postdoc mentor at Caltech, a little more than 30 years ago, I agreed with a lot of what he was saying and doing, of course. I was working with him, but I didn't agree with his conclusion, saying that it is a myth that we have a free will, since every action is determined by various conditions, physical and psychological. And then later down, free, choice, and decide do not seem to be a part of the equations or symbols of physics at all, but instead a matter of the ambiguous language which we use to describe that physics to ourselves and to others. I think these are the common views in science. So to go sort of to challenge that is tough sometimes. But there are alternative views, of course. So, for example, George Ellis, mathematician and physicist, says that all scientific experiments are based on purposeful activity and free will, enabling decisions based in abstract analysis that lies beyond the explanatory scope of physical science. Bottom-up, same level, and top-down causation all occur at the same time in concert, enabling the emergence of genuine complexity based in modular hierarchical systems. And he wrote this in a book called Downward Causation and the Neurobiology of Free Will. Another great philosopher, thinker, and neuroscientist is Walter Freeman. He claims that, or his view is that the brain is not primarily an information processing organ, but a system for creating meaning through amplitude modulated spatial patterns. I will come back to that later on because I think he is onto something very interesting here. And meaning implies context, but also intention, which is a creation and projection by the brain of alternative future states, desired or feared. This is sort of central to my presentation here also. The intentionality that precedes free will and precedes consciousness, actually. And also the use of attractor dynamics, which I will explain a little bit more, to control choices and directions of actions in the present. The operations of predicting, planning, acting, detecting, and learning comprise the process of intentionality. Intentionality precedes consciousness. And consciousness in the neurodynamic view is a global internal state variable composed of a sequence of momentary states of awareness. I don't have to read everything here, but intentionality is, again, an important concept here. Voluntary acts may be considered acts of free will. And we cannot not make choices from the very nature of the neurodynamics, which must be resolved. No decision is ever totally free or determined, but it depends on you as a subject. And that's where it's challenging science. We have all talked about the science being about objects. We try to objectify the world with our natural science, but the subject is not there in science. Maybe it comes into quantum physics and into theory of relativity, but it hasn't really penetrated the science of today, that the subject is important. So intentionality cannot be explained by the common understanding of linear causality. Instead, circular causality could better explain it in the terms of action perception cycles, and I will come back also to that. There are three properties of intentionality according to Freeman and also others: directedness, unity, and wholeness, which all could be associated with three stages of intentional behavior. In the first stage, the stimulus is categorized in primary sensory cortex, usually accompanied by an experience of emotion and value. In the second stage, different sensory modalities are integrated into gestalts, which are assigned time and place in the life history of the individual. And this alludes to Janan's talk yesterday, actually. In the third stage, there is a global coherence over the entire cerebral cortex, resulting in a decision to act or not to act. And this, I guess, is most relating to the global workspace theory. I think so. I'm not sure if Walter, but I think that Walter would have said the same thing. So Walter Freeman was working primarily with animal studies, and he was looking at intentionality in different animal behaviors. And in this case, it's an amphibian, but he was mostly working with rodents and cats. So there is an interaction, there's an action perception cycle, as he called it, where intentionality is an important aspect of this circular causality between reaching out and reaching into our nervous systems. Another interesting person to think about in this context is Max Delbruck. He's the father of molecular biology, it's often called. And he had the idea that not only other animals are conscious in some sense, similar to us, but of course also different. But he actually said that perception, that is the reception and interpretation of signals from the environment, must be of high evolutionary antiquity, being a common attribute of all contemporary forms of life. So consciousness, according to Max Delbruck, originates at least in the first single-cell organism on Earth. And this is a view that I share. So I think that the complexity increases with evolution. So with simple organisms, we have sensation, action, and response. And as we move up the evolutionary ladder, if you like, increasing complexity, we get more and more sophisticated and complex behaviors, interaction between the internal world and the external world. And this is the action perception cycle, if you like, also. And the humans, of course, have self-consciousness. Maybe other animals have it as well, but this is typical for humans, we can say. And of course, it's related to language. So I think to talk about, as we have been discussing in this conference before, that consciousness is neither nor, it's not a either or thing, but it comes in degrees. It increases. The consciousness comes in degrees, and I will also argue later that free will comes in degrees. But if we look at the nervous system, we have, in principle, two hierarchical systems in our nervous system, the sensory hierarchy and the motor hierarchy. And there's an interaction between the different systems within the nervous system, but you have, again, the interaction with the environment, which is so important. And there was a talk about yesterday about from Spot to HAL. The HAL, I don't think she actually talked about the HAL computer, which appears in the movie 2001, A Space Odyssey. It's a computer that is just like a box with no interaction with the environment except for the input from the keyboards and so forth. Or you could actually talk, I think, to that. But I think the interaction is very important also in AI systems. I mean, when you develop, try to develop artificial intelligence systems, you need the interaction of various sorts with the environment. So this is crucial also for the development and evolution of consciousness, to increase the complexity of our interaction with others and with our environment. And the brain-mind is a complex system, of course. There are lots of feedback loops within and without itself. So it's difficult and almost impossible, perhaps, to determine any causal chains. So instead of looking for causal chains, perhaps we look for these networks of causation. But to take the view of Freeman again, the perception-action cycle or action-perception cycle, you can talk about this at different levels, micro, meso, macro. And of course, it's since due to the complexity, it's very difficult to actually determine the prima causa to any event or any action, which is what we are looking for. But we are trying to do that. We are trying to find in our studies, trying to understand what comes first, or where is the first signal for an action or a decision. So again, this is a sketchy view of how I view the dual aspect of consciousness. Most of the time, people talk about the attentional aspect or perceptual aspect of consciousness, the experience. But I think it's equally important to look at the intentional aspect, which is related to free will, where we actually have a sense of going out, reaching outwards, not only just inwards. So in the exploration, in the interaction with the environment, we have this action perception cycle where we should not forget this aspect of consciousness. And in particular, if we're talking about consciousness as having any role in evolution, the role is through our actions in the environment and the feedback, of course, from the environment. So there are various ways of studying brain activity and trying to find out what's going on in our brains at the same time as we feel or have a sense of agency. And we have talked about that in the conference so far, so about different methods. I will primarily focus on the EEG, which has a bad spatial resolution, but a good temporal resolution when we measure brain activity. We have other kinds of method, which is also very common, fMRI, for example, which has a better spatial resolution, but not so good temporal resolution. So if you are interested in processes that are quick or with a short time scale, the EEG and MEG, magnetic encephalogram, this is electric encephalograms, that we can use for studying shorter or higher frequencies of your neural activity, the neurodynamics. So if we look at the micro-mesoscale neurodynamics, we can look at the spikes from action potentials, that neurons that are firing. These are action potentials, electrical pulses in our nervous system. And this is a famous picture actually from the Gray and Singer paper from 1988, where a couple of German groups at that time found a correlation between the neural activity in terms of 40 hertz oscillations correlated with conscious experience of cats. And so these 40 hertz oscillations actually is something that also opened up the neuroscience for the study of consciousness. This was in the late 80s, and then Crick and Koch opened up with a couple of papers in the around 1990 towards the neuroscience of consciousness. So these experiments where you could actually correlate something going on in the brain with consciousness. It was sort of an eye-opener, and also something that has been continued ever since. And I'm still working on these 40 hertz oscillation, or at least it's called the gamma frequency in the EEG measurements. I will come back to that later. But this is also something that Walter Freeman again studied in the olfactory system. So they have a spatial-temporal patterns appearing in the cortex of, this is a square part of the cortex, with the EEG channels give different amplitudes and frequencies for different sets of neurons, populations of neurons. And then the mesoscopic neurodynamics with the EEG, you can have different types of EEG patterns for, as we also heard yesterday, with different types of sleep REM sleep, non-REM sleep, and so forth, different types. And also, if we are highly awake and attentive, we have primarily these gamma frequency oscillations, while we have slower oscillations, lower frequencies, while we are asleep or drowsy or meditating or something like that. So again, the macroscopic neurodynamics is what you see with the PET, positron emission tomography is not so much used nowadays, but it's primarily been replaced by functional magnetic resonance imaging, fMRI. And you can have a combination of, for example, EEG, which is has a high temporal resolution, with a fMRI, which has a higher spatial resolution. And you try to combine that and get a better view of what's going on in our brains when we do something. And now we come to these kind of experiments that also Liad was talking about. There are a set of experiments that was made by Libet and his Benjamin Libet and his colleagues in the 80s and 90s, which are all based on this idea that you can measure some kind of neural activity in relation to an action, or actually it was picking, not a choice, not a deliberate choice, but moving a finger when you like. So that's a very primitive experiment, but it's sort of a clean experiment that you can do in a laboratory, because with as little as possible of external influences. Because if you measure the brain activity during normal everyday life, we have lots of frequencies, lots of signals going on, so it's very difficult to distinguish certain signals related to a certain thing happening. But in this very primitive case, this was done. And people have also been measuring or stimulating different brain areas. But this typical Libet, it's called the readiness potential that he explored, is primarily from this area, the supplementary motor area, or the pre-supplementary motor area. So this area is quite interesting to study, as well as the prefrontal cortex. Of course, you can study different areas and stimulate and measure the activity and so forth, but these are in focus. Interestingly enough, for those of you familiar with Descartes' ideas on the seat of the soul, was in the pineal gland, centered in the middle of the brain as a single gland. And a modern version of that was actually by John Eccles, the Nobel laureate, that pointed at this area as a seat of the soul, with the interaction between the soul and the brain. So, but anyway, so it's an interesting area. This is where the actions are being, the first signals before you have an action. So it's easy to see that something is going on here, and then there is an action. And this is what we, actually this, before Libet, this was studied in 1960s by Kornhuber and Decke, and also this is called the Bereitschaftspotential, and that's the readiness potential in English. So this is a typical shape that you also saw in Liad's slides, that is associated with about half a second before you actually experience that you want to do something, like moving a finger. And all of these, that we can see these signals in the brain before we experience that we want to do something, has been taken as a proof, or at least an evidence, for that free will does not exist. It's an illusion that we have a free will. It's a brain that decides, not we as subjects. And this, I think this is the same books that, almost the same books as as Liad showed. So there's a number. This has been the dominating view for a long time. And this is, again, why we wanted to challenge this view. We thought that the experiments that had been made before by Liad and others were not bad in themselves, but it was an interpretation that they had anything to do with free will that we challenged, that we questioned, because it was so simple, the experiments. So the kind of deliberate choices that Liad was talking about is something different, and that's where free will comes in. And here you see, of course, it's the same picture, I think, yes. That's me, oops. And actually we had, last year we had on our annual conference, we had Janan speaking at that conference as well. So what is this project about? Well, we want to I think Liad said that we have 17 neuroscientists and philosophers, about 50-50 of each, 50% each. And we want to investigate whether the human intention are causally efficacious for our decisions and behavior. What is the specific role of consciousness when intentions guide behavior? And what, if any, is the difference between conscious control in deliberate versus arbitrary decisions? And that we also Liad was talking about. So we think that this is a good way to study consciousness with the interaction between neuroscientists and philosophers. So we have experimental work done with the brain involved. We have philosophers thinking, but we also have computational modeling as part of this. So we have 3 legs, actually. And I will talk about the computational part because that's what I'm working with, using experimental data and, of course, interacting with philosophers as well. But the main issues, as this is John Dillon Haynes. Many of you know this paper, Soon et al. From 2008, which showed that it was sort of a follow-up from Libet's experiments, but this was with fMRI. And this group, I mean, John Dillon Haynes was a group leader, Zoon was a collaborator. But they found that there is a signal even up to 10 seconds before we experience that we want to do something. So 10 seconds before, that's a really long time before we want to do something. Our brain knows in some sense, or that's what it was interpreted as. So the question is, does consciousness precede what's going on in the brain and before we act? Or is it the brain that comes first and then gives rise to conscious experience and then we move? That is sort of the main question to investigate. And we can investigate that with many different kinds of methods, fMRI, EEG, measuring the brain and such, etc. But also trying to find out with computational models of the different brain areas how the signal can transfer from one area to another, trying to track the signals that are eventually coming up to the supplementary motor area before it goes into an action. So decision making is what I will focus most of the time now on because that's most important of our cognitive processes related to behavior, and it's crucial for survival of all higher animals, and of course linked to the sense of free will. So if our willful acts should have any evolutionary effects, our physical body must be under the influence of our consciousness, which is an example of downward causation. Most of the time in science we talk about upward or bottom-up causation. Physics determines chemistry, chemistry determines biology, biology determines psychology, psychology determines sociology, etc. But we very seldom look at the other way, the causation from the other levels. I would say all the way down we can look at the same. And it's not that they are exclusive, they are complementary, these views. I mean, the causation, that's why we talk, or Freeman and others are talking about circular causality. It's not so easy to say that it's just in one direction. But you can try to identify the different brain areas in decision making, and people have done that for some time, trying to look at the areas involved. And also in the temporal process, what comes first, where does a signal start and how does it travel? And this is what we are trying to do with our computational models, trying to figure out, because this signal in the supplementary motor area, this readiness potential, doesn't just arise from nowhere. There seems to be some signals before that give rise to this readiness potential. Of course, John Eccles would say that that's where the soul comes in and makes that happening. He actually talked about psychons interacting with neurons. But that was heresy in modern science to talk about that in a dualistic fashion. But if we simplify our minds, we can talk about emotion or affection and cognition. That is part of our decision making and also eventually our behaviors. So we try to identify the areas involved in cognition and in emotion. And with that, we also base part of our work on the work by Kahneman and colleagues. He wrote a popular book on thinking fast and slow some years ago. And where we have two systems involved, the system one, which is intuition, or a better word would be emotion or affection. Actually, this is what we use for that. And then reasoning, or system two for cognition. So these different concepts are somewhat blurred in the literature. So the decision to adapt or innovate may be determined by both internal and external factors, where emotion as well as cognition come into play. And mostly they may be due to subconscious activity. I mean, our brains are working in parallel while our minds are working in series. So we can only have one object or one thought at a time being conscious of it. But our brains are all the time keeping a lot of things going on. And that, again, is something that I think alludes to Liad's talk about this noise, that we can be aware or not be aware of the noise in the surrounding. We can sort of, we focus on something, someone saying something important, then we focus on that person. That was also talked about yesterday. So we have a possibility to determine what to be to attend to have in our conscious mind. And also, as I said, with attention, you also have the intention as the other dual aspect. So the attention is about how the world is now and is necessary for an appropriate adaptation, while intention is about what the world could be in the future, which is the basis for innovation. I'll skip through some of this, but we try to locate this system one and system two of Kahneman's ideas, or the emotional / intuition with the cognitive / rational thinking. And we found some areas. This work is primarily with my colleague Hassaneh Nasir. She's also at the Karolinska Institute, doing her PhD there. And we use attractor neural network models on the neurodynamics of the three cortical areas, the lateral prefrontal cortex, the ACC, and the pre-SMA, and their interaction. And we look at the interplay between the different neural oscillations on the early readiness potential. We try to figure out where does it start, how does it come about. So these are the areas that seem to be involved in decision making that we are focusing on. Most of the time, most measurements with EEG in particular is from the cortical, neocortical areas. So because the deeper parts of the brain are difficult to measure any electrical activity from. So we have to infer some of the ideas that we have, how the pathways are going around. MEG, that magnetic encephalograms, can be used for measuring activity deep down in our brains. But if we use only EEG, we can only reach this. And as I said, with fMRI, we can reach deeper down, but then we don't have the temporal resolution. So we modeled this as mesoscopic neurodynamics. This is the kind of dynamics that has about 40 hertz oscillation that we can see. Also other frequencies, of course. But I mean, again, in our models, we use the 40 hertz oscillation as a marker for consciousness. So when the brain dynamics has this frequency, we say that then the system is conscious of something. This is just because we lack any other good ideas on how to represent consciousness in our computational models. And we use attractor neural networks with excitatory and inhibitory layers, and this is approximately the type of cortical structures we have in the brain. Although the neocortex has 6 layers, but we can lump 3 of the layers, so we have only 3 layers, one with excitatory neurons and 2 types of inhibitory interneurons. And this equation is actually similar to the Hopfield equations, but we have more biologically realistic connectivity, and the input-output relation is also more biologically determined. I think I have a few more minutes, but not too many. So this was actually determined experimentally by Walter Freeman. This is the input-output relation. It's a sigmoid function relating the input to the output of the neurons. And these are not single neurons. These are populations of neurons. Each node in our networks corresponds to maybe 10,000 neurons. So that's why we don't have spiking neurons in our models. We have the neurons, the output from our nodes is more EEG-like. So I'll try to see the dynamics when there is a signal coming in, and this corresponds to the spatial temporal patterns that Walter Freeman had found experimentally in his rabbits when they were smelling or sniffing at a carrot, for example. He saw something similar to this kind of dynamics that we now simulate it's for 200 milliseconds. So it's a one sniff cycle. So that kind of spatial temporal pattern corresponds to one, in this case, a percept of some sort. It could be one of the options that we have to choose between. And this is what we have. We have a spatial temporal pattern or an attractor that corresponds to something of our options. Again, this is a sketchy picture of our model where we have system 1 and system 2. This is the amygdala and orbitofrontal cortex. corresponding to the system 1 with the emotional part, and the cognitive rational part, the lateral prefrontal cortex. And then there's an integration of the activity in these two systems that gives rise to some decision eventually, and then an action. And then the action into the environment or the society, and then there's a feedback from our actions or from the environment to our system. And then we learn that way. We learn how to behave in the future if we have misbehaved now. So where does free will come in here? Well, it could be acting in the free will, in the lateral prefrontal cortex, or it could be part of the, just before the integration. And we don't really know where we would say that this is sort of the heart of the free will signal. But we are looking for where can we stop an intention to act, for example. So again, this is a case where system 1, in this case, we should choose how to travel from home to work. We have bike, we have public transport, or we have a car, and what decides which to choose to travel from home to work. And if we just go by intuition or emotion, we may take the car, but if we think a little bit more, for example, thinking of the climate effects, we would take the bike, maybe, or at least the public. So depending on how long time we have for our decision, we may make different decisions. And this is also what Kahneman found out, by the way. So the time of the decision is crucial for the outcome of the actual action. Okay, so in our model, we think that this is represented by attractors, these different options, as I said. So we have different optional attractors. These are chaotic attractors initially, and there's a competition between them primarily in the lateral prefrontal cortex, and then it eventually converges to limit cycle attractor, which is a decision. Now we have decided what to do, which to choose. Maybe we take the bicycle instead of the car. Maybe here we have both the car and the bicycle, and we don't really know initially, but we eventually take the decision to take the bike. Finally, I will talk about a little bit other type of work that is being done by one of my colleagues, David Silverstein. He is actually interested in the subcortical parts of the brain. Yeah, okay, thanks. So I will just skip through very quickly. He's looking for trying to make the temporal match what's going on in the brain when we make these experiments, when we actually act, and when we have a chance to stop our actions. So this is ongoing work, but the idea here is that the readiness potential is exactly what it sounds like. It's ready, we are ready to act, but we inhibit that until the decision comes on. And this is simulations where we prepare an action, but we don't act. And this is where we prepare the action and we inhibit until the release of the response. And that's when a motor action occurs. Okay, and what we are going to do now is to implement this into social interaction. And so we have interaction also with other people going on. So conclusions are that intentionality is best explained by circular causality in the action perception cycle. And the decision making is the neural basis for that is what we are looking for. And we can learn also this, we can experience with the learning. And the effects of consciousness are mostly linked to intention, and deliberate decisions are value-driven, which is typical for free will choices. Okay, so implications are that our decisions and actions can affect the world much more than we think. To be aware of it determines our decisions may be crucial for our existence. So thank you for attention.
Thank you. I'll take one quick question while Aku sets up. We'll get a microphone.
I have a question about the phenomenology of free will, perhaps. So let's say you stand in line, it's lunch. At the end of the line, you have either chicken or fish. Your phenomenology of free will is not something that is instantiated at the end of the line when you actually make the decision. It has more to do with a certain knowing that you know, a fringe consciousness state, perhaps, of knowing that you can change your mind, or knowing how much time you have to change your mind, which is a very important ability to have. And this is really what the sense of free will has more to do with, this knowledge that you can change your mind, and not so much with the actual decision itself at the end of the line.
Well, I mean, the change of the mind is before we make the decision, I would say. Of course, we can make a decision and then go back and make another decision. But the intention is preceding the decision. And during the intentional part, that's a long period, could be a long period, when we are intending to do something. But then when we really decide to do it, then at least at some point, we have no return. There is a point of no return, that we actually have more or less have started the whole the process, that the motor cortex will give a signal to our muscles. So before that, we can change our minds, but not after.
Sounds reasonable to me. Thanks very much. Sorry, we have to push on. I want to leave you sometime. So let's start. While we set this up, I'm pleased to welcome our own Aku Visala, Academic Research Fellow from the Faculty of Theology. When you're ready to go, Aku, you have your laptop there.
Thank you. It's great to be here. I want to thank the organizers for a great conference so far. I might mess the whole thing up, so it might not be as good as it was before, but we'll see. It's actually quite practical for me now to give this talk after Hans and Liad, because I'm addressing these same kinds of issues, but from a more philosophical perspective. So here you can see the difference between a neuroscientist approach and perhaps a more philosophical approach. And a lot has been said already about this free will skepticism. So I'm going to look at that a bit more carefully in what follows. So we can start from kind of formulating a kind of basic skeptical argument. And in what follows, I will talk about moral responsibility. So my focus is more on moral responsibility, and free will is a part of that conversation. So I'll explain how the reasoning works. But the basic idea, this is one way to form the skeptical argument, is something like this. First, in order to be deserving of negative moral responsibility attributions for their actions, human persons must first exercise a high degree of conscious control over their actions. Second, have high degree of conscious access of the moral features of their actions. This includes reasons that people have for their actions, or the consequences of those, or the kinds of factors that involve or influence their decisions. So this is premise number one. Number two, there is significant scientific evidence that shows that human persons seldom exercise high degree of conscious control over their actions and have a high degree of high degree of conscious access to the moral features of their actions. Therefore, human persons deserve no negative moral responsibility attributions for their actions. So this would be the basic argument. And I'm going to look at this argument a bit more carefully and try to explain what these different bits mean, and then assess some of the evidence made for this claim, so for this argument. So you'll notice an important thing. First, the first premise is a more philosophical premise rather than an empirical one. So I don't think there's an empirical experiment that can find out something like this. So this is the philosophical assumption here, on which the whole thing rests. But there's the second premise is a more empirical one, or more experimental one. And this has to do with the things that we've already talked about here. So what I'm going to do is I'm going to look at this second premise, and then I'm going to see what kinds of moves we can make here as well, if we want to block the argument. First, we have to explain some of these basic concepts. So there's this idea of basic desert responsibility. This is crucial for the debate, so it's quite important to understand what's going on here. The idea, described here by Dirk Pereboom, is that for an agent to be morally responsible for an action in this sense is for it to be hers in such a way that she would deserve to be blamed if she understood that it was morally wrong, and she would deserve to be praised if she understood that it was morally exemplary. The desert at issue here is basic in the sense that the agent would deserve to be blamed or praised just because she has performed the action, given an understanding of its moral status, and not, for example, merely by virtue of consequentialist or contractualist considerations. So, this is what's at stake here. So, whether these responses that we have towards each other, you do something wrong, I respond to that by blaming you. Okay, you did a bad thing. Whether that blaming is an appropriate thing just because the other person did it. This kind of basic desert responsibility is the target of the skeptic's attack. And the basic idea is that the core of the skeptical argument is to say, no one's deserving that kind of treatment because they aren't properly related to the actions that they have done. So the person itself is not somehow standing behind those actions that I use to judge you, and then on the basis of which I blame you for those bad things, they don't have a proper connection between the person. They are not properly connected to the person. And as a consequence, I can't blame you on the basis of your deserving it. I can blame you for some other reason, like by blaming you, I make you a better person. But you don't deserve to be treated like that, just because you did the action. So there are many versions of this kind of skeptical challenge. The best one that invokes consciousness, as far as I can see, is Greg Caruso's case. So basically what Caruso is saying, that we have a folk view of free will, which is that there is such a thing as conscious self, and that initiates and orchestrates the actions that comes out of it. So there's this very simple picture of the self, and the self has consciousness somehow, and then all these actions come out of the self. So there's this decision-making process which is conscious and so on. Caruso is working with a higher order theory of consciousness, and the core argument, as I said, is that, first of all, the conscious self is not, or it's mostly disconnected from action generation. And two things follow. So first, there seems to be no control, no conscious control over action, or if there is, it's not significant. And second, there seems to be there's not enough access to the moral features of the person's actions. And of course, Caruso and others amass a lot of evidence for this, and they invoke a lot of the kind of evidence that we've already talked about here. The neuroscience of conscious volitions, that's a big thing, so they talk about that a lot. Then there's this general idea of cognition being modular in nature. And there's a lot of work and a lot of interpretation of cognition being largely automatic. So there's all this automatic activity going on. So the skeptic is very impressed by that activity. And then basically saying that what consciousness adds to this activity is very, very small in terms of action production. Then they look at studies about the limits of self-awareness. There are a lot of work on that. So to what extent we are able to form a reliable picture of our motivations for our reasons and so on. There is a bunch of research on unconscious biases and unconscious influence in decision making. We've already heard a little bit about that, and I'll come back to that. And also, there are a lot of work in social psychology on the unconscious situational influences. So the influence on decision making that comes through this very specific, highly local environment. So they come up with all this. They use all this evidence to point to the more general conclusion that the mental content that is consciously accessible to us is not closely connected to action generation, and two things follow from this. First, there's a low degree of control over action, and then there's a lack of access to those morally relevant features of the action and the agent. And as a consequence, the conclusion is that because we human beings are in a situation like that, we shouldn't be blamed for what we do on the basis of desert. We don't deserve to be treated badly, because in order for us to deserve something like that, we need to have a high degree of control and we need to have a high degree of access. And this is what the folk view tells us. So in order to have this folk idea of free will, we need high level of conscious control and we need high level of access. So I'm going to skip that. So how to respond to this kind of argument? Well, here's one easy way out. Why bother about consciousness anyway? So why do we have to think that moral responsibility depends on conscious access or conscious control in any way? If we just put that aside, perhaps we get a kind of skeptic proof version of moral responsibility. And this has been attempted a number of times. So there's a view on moral responsibility, sometimes called attributivism. There are many names for this view, sometimes called expressivism or attribution theory. But in any case, such an account exists. And the idea is that a person's actions can express her true self, the kind of agent that the agent is, without the person really having any kind of conscious control or conscious access to this information. So responsibility attribution, so when I attribute certain responsibility to you, moral responsibility, they are really grounded in the fact that the agent's actions are expressed, in those actions, the agent's what the kind of thing that the agent is being expressed in those actions. But the agent doesn't have to be conscious of that in any way. And oftentimes the idea is that the self itself is a kind of bundle or pattern of evaluative judgments, attitudes, and all these are mostly unconscious anyway. So it doesn't really matter in terms of responsibility. So you deserve to be treated in a negative way, for instance, in terms of blaming, if your actions represent your, let's say, character failures, of which you don't control, or you don't even know of. So you can be ignorant of your character failures, but you're still responsible for those because those are the ones that come through in the way that you act. You see here a person who's like a fictional person, Vincent Vega from Pulp Fiction, who in the situation, if you're actually seeing the film, what happens afterwards, there's a person sitting at the back backseat of the car, and Vincent Vega accidentally blows the guy's brains out. And they get into all sorts of trouble because of this. So the attributionist is going to say, well, I mean, Vincent didn't really mean to do it. He didn't intend to do it. Also, it's not like Vincent was conscious of his reckless abandon and his recklessness and ignorance that he had actually loaded the gun. And all of this happens outside Vincent's consciousness. So why would we hold him responsible if consciousness is necessary for moral responsibility? Because Vincent doesn't seem to be controlling the situation, nor does he seem to be in any way having access to those morally relevant features of the situation, like his own ignorance or recklessness. But at the same time, the action represents and kind of flows out from the kind of person that Vincent is. So this would be the basic idea of the attributionist theory. Okay, I'm not too convinced about it myself, and I don't have here enough time to argue against it, so I'm going to put it aside for the most part. But this is, if you really buy into the idea that consciousness that there's very little conscious control and there's very little conscious access, and you're convinced by that, then this might be an option for you if you really want to hold on to basic desert moral responsibility, if you don't want to go full skeptic. So this attributionist route is available if you want to defend it. But one of the problems, I think, is that it might need consciousness after all, and also it's quite unintuitive, I think. So we have a lot of arguments that try to unearth this counterintuitiveness of the view. One book, perhaps the best one that I've read on this, I would recommend, is George Scher's Who Knew? Responsibility Without Awareness. So, but another way of responding to the challenge is to say, yes, we do need consciousness, we do need conscious control, and we do need conscious access in order to have moral responsibility in this basic desert sense, and we might actually have it. So this is another way of responding to it. And one response along these lines comes from Neil Levy, and especially it's developed in his book Consciousness and Moral Responsibility. He basically says that, well, he says that I will argue that consciousness makes information available for the rational control of behavior by making it available for use in deliberation or reflection, where these are understood as effortful and controlled processes. However, I want to claim more than that. I want to claim that consciousness by itself makes a difference to our behavior. So Levy is basically saying that although we have a lot of evidence for automaticity in cognition, it seems to him that non-conscious mechanisms are just too inflexible to explain the bulk of human moral action. So it's not that all moral action is automated. A lot of it is, but consciousness has a central role in regulating it. Also, he points out that it's very likely to be false that we are always or even often conscious of the precise moment at which a decision is made. But there's little reason to think that this fact threatens moral responsibility. So what he's basically saying that this focus, which we've had because of the Libet experiments for a long time, has been on the very moment of decision. And somehow everything rests on that, and people focus on whether consciousness is involved in this in the couple of seconds that precede some decision. But that might actually be not a very useful way of looking at the situation. So, often most of our actions, they proceed without any kind of conscious input in the decision-making process. But why should this be a problem for moral responsibility if certain other conditions are being fulfilled? So Levy is basically working with the global workspace theory. And in terms of access, he thinks that what we need to have is we have to have access to those features that give the action its moral valence. With those aspects of the action that make it morally relevant. And of course, in many cases, it's clear that we have very little access to some of those causes that influence our behavior and our decisions. And we are often even ignorant about our own motivations to some extent. But that doesn't mean that we are always ignorant about the moral nature of our choices or the moral aspects of those actions. And also the kind of idea that we can work with in terms of responsibility is the theory that has already been mentioned called reasons responsiveness theory of moral responsibility. And here the idea is that a person can be responsible for those kinds of actions that are products of a system that is responsive to relevant moral information in various counterfactual conditions. There's a long story behind that. I won't go into it to any extent here. But the basic idea is that this reason responsiveness is something that is quite resistant to the skeptical challenge, I think. And our cognitive system can be responsible to reasons in different situations, even if it's not constantly even if the actions are not constantly produced by some sort of conscious decision making. So we can have a reason-responsive system without kind of direct conscious influence. So to conclude, I'm going to say a few words about how we could make progress with these issues. One is that I think we need a more substantial theory of control. And people use this term control a lot in these discussions, especially because it seems quite intuitive to link it with moral responsibility. So we need to control our actions. But what is control really? The best theory of control that I've found so far is from Joshua Shepard's The Shape of Agency that just came out last year, where he develops an intricate theory of control, which works both for for incompatibilists and compatibilists. But the basic idea that control is the agent's ability to succeed in implementing her intentions via actions, and success in this sense control is a success term. So I can succeed less. I can succeed well or not so well. But it comes in degrees. So consider our friend Sniper here. So he's sniping away. There are a lot of things that go into a successful shot. Hitting the target. Many of those features the sniper doesn't control. But at the same time, the more skilled the sniper is, the more he's able to control or exercise the control over the success of the outcome. So you can have a sniper who hits only once in 10 or once in 50 times, something like that, and that's still quite a lot of control because most shots people miss. So control comes in degrees, and there are all sorts of things that are, control itself is compatible with a lot of influence, a lot of factors that the person doesn't control. Also, control is spread across time. So this gets us out of the idea that we are focused on the very moment of the decision all the time. Because we have to look at conscious control in a diachronic sense also, not just synchronic sense, but we are learning something now, and consciousness has a role to play for us, has a role to play in modifying our behavior in the future. So this is a kind of control as well. So we can control the way that we develop and the kinds of systems that drive our actions in the future. So there is, I think, a decent amount of evidence that this kind of conscious control is something that we do have, or at least are capable of in many situations. In a large paper from years back, Baumeister and others review a lot of evidence They say that the evidence for conscious causation of behavior is profound, extensive, adaptive, multifaceted, and empirically strong. Recent criticisms have questioned the efficacy of conscious thought for direct control of action, but these criticisms are largely irrelevant to the possibility of offline and indirect effects on later behavior, which constituted the bulk of the present findings. Also, a paper that was already mentioned earlier by Mudrik and others. This is a really good paper. I loved reading this stuff. So they go through more than 60 studies on implicit influence on decision making, implicit biases, various other kinds of experiments, and they look at the different ways in which people are conscious of the different factors in these situations, in these studies. And what they basically conclude is that the studies that they reviewed, they cannot refute the existence of free will conceived of as dependent upon reason, responsiveness, or control. To refute the general existence of free will, thus understood, one would need to show that agents are never able to respond to reasons or that they lack control over their behavior completely. And Manuel Vargas, I think, has usefully pointed out that these kinds of studies are actually useful for us because the more we know about the kinds of biases that we have and the influences that we have on our behavior, they increase our degree of control. So the more we learn about this stuff, the more control we can exercise over our behavior. Okay, to conclude. So I think everyone agrees, regardless of their view on free will and moral responsibility, everyone agrees on a couple of things. One is that control over action is pretty fragile. There are many unconscious influences on our behavior, and control depends on situations. Sometimes control is higher, sometimes it's lower. It goes up and down depending on all these influences that we have in our environment, in our bodies, in our brains, and all that. But that's not really the problem yet. That's no worry. Second, everyone agrees that conscious awareness of decisions to act is often missing, and our conscious access to some of the moral features of our moral situations are quite spotty. So everyone agrees on that. The next question is whether this general ability to exercise modest or mid-level control and have some modest or mid-level access to relevant information is compatible with current scientific evidence, and I think it pretty much is, or at least a good argument can be made to this effect. But the disagreement, and now we come back to the skeptical argument's first premise, and this is really what the disagreement actually is. So when the skeptics always kind of come in with the scientific results first. But actually, the business, the main thing is premise number one. So the disagreement is, are these what we, or even the skeptics, many of them admit, someone like Greg Caruso will say, no, consciousness is involved in action production, but not enough. There's not enough of it there. And they agree that we have at least a modest or mid-level degree of control and some sort of mid-level or modest access, but what we disagree on whether they are enough for this kind of basic desert responsibility. And this is a more philosophical question than an empirical one. So it seems to me that the skeptical argument really rests on the basic assumption that folk free will is necessary for desert responsibility. And this is, as I said, a philosophical claim. One way to get out of the bind would be basically to say, well, why should we think that folk view is necessary for desert responsibility? Why won't we just ditch the folk view and hold on, and then find a way to justify basic desert responsibility in some other way? And this would not be skepticism, but something that is nowadays in the field of free will called free will revisionism. So we admit that our everyday views on basic desert responsibility and free will need to be revised, that there's something wrong with them. But that doesn't mean that we have to give up basic desert moral responsibility. So that would be one option. Okay, that's it. Thanks.
Thank you very much. I'll try to fit in at least one quick question. We've got one right here. Thanks.
So we cannot control, like do what I say, but we can manage little bit influence, right? Our conscious, our actions.
Well, the basic idea that I was trying to say here is first of all, we need a better understanding of what we mean by control. And if we have a degreed way of understanding control, then we can say that, yes, I'm in control of many of the actions that I perform, but I'm not in perfect control. So there are degrees of control. As I said, like the sniper controls a lot of the factors that go into a successful shot. But there are many other factors that he doesn't control. But at the same time, we can still say, well, the sniper succeeded. The sniper, shot the target. And he has control over that, not just not perfect control. So when you change the situation, when you change the conditions, the degree of success goes lower. So I think our problem is that we tend to think of free will as a kind of on or on-off thing. Either we have control or we don't have. That's not a very useful way of thinking about it. The kind of view that I'm trying to push here is that there are degrees of control, and in some situations and with respect to some actions, we have a high degree of control. So I have a high degree of control whether I'm moving my arm like this. But whether I come to work in the morning, my degree of control is not that high, as kind of controlling my body. Whereas in a specific situation, I have a problem with my brain, for instance, my motor system is not functioning properly. All of a sudden, my degree of control over the movement of my arm is much lower.
Good, thanks very much. I'm afraid we'll have to wrap it up there, but let's thank Agora again.
Thanks.
I think so. And where is the clicker?
Let's see if this works. 1, 2, 3. 1, 2, 3. Oh. Okay, I think we can start. You get a back echo from my voice? I get it, but maybe you don't. Okay, anyway, so I'm very happy to introduce actually our final keynote speaker, Professor Hugh Price, and who is sort of I think he has also fairly long-term connection to Finland in various ways, and he even developed the Helsinki model. This was toy models of retrocausality, which were maybe developed, it might have been even at the airport, but if I remember correctly. But anyway, so of course, many of us know Hugh's work from work on the arrow of time and that area of work. But of course, he's worked much in philosophy and meaning and many other topics, pragmatism and things like that. And actually, when I was discussing with somebody about him being here, I was told that he's we could consider him as one of the greatest philosophers active in the UK at the moment. So anyway, but that's enough for an introduction, and we'll let Hugh get on with it. Yeah, great.
Thank you, Paavo. Thank you for the invitation. Thanks to you and your colleagues for the organization. It's wonderful to be here in Helsinki, both because this is such a fascinating meeting and because, as Paavo says, Helsinki is one of my favorite places. About 20 years ago, I discovered that a convenient way for an Australian, as I am, and as I was then based, an Australian to come to Europe is to take advantage of Finnair and land in Helsinki at 7 o'clock in the morning after an overnight flight across Asia, and spend a night or two here recovering from jet lag and taking advantage of all the wonderful things that Helsinki has to offer. So I'm delighted to be back, especially in summer and especially in this context. The talk I'm going to give you is based on a paper I wrote recently for a forthcoming OUP volume called, I think, simply Neo-Pragmatism. But what does neo-pragmatism mean in this context? I'll start off with some examples. One which I think will be familiar even to non-philosophers here is David Hume's famous view of causation. In particular, Hume thought that there was no causal necessity in the world connecting events. It was just that when we see events happening in succession, we see A regularly followed by B, we just come to expect that B will occur when we see another A. And it's the projection of that expectation, the projection of something mental, that we mistakenly think as some kind of necessity in the world. So that's an example of what I'm calling neo-pragmatism. I'm also going to talk about a little bit about Frank Ramsey's views on causality, which sort of update that picture to some extent. But in both cases, what we're offered is what Ramsey himself calls psychological analysis. So it's not metaphysics, it's not a story about how causal thinking It is a story about how causal thinking arises in creatures like us, not a story about what causation is in the world independently of us. And it's this shift from metaphysical analysis to psychological or linguistic explanation, which is the core of what I'm calling neo-pragmatism, and in other contexts I call it expressivism. So in particular, neo-pragmatism is always seeking to explain some aspect of how the world looks to us, what Wilfrid Sellers famously called the manifest image, in terms of some feature of us. In Ramsey's case, for example, explaining the causal character of the manifest image in terms of the epistemic viewpoint of a deliberating agent. Another metaphor that's helpful here is the metaphor that Kant gave us, the Copernican metaphor. So we can think of what the neo-pragmatist is doing as explaining apparent structure in the world as an artifact of some aspect of our particular human viewpoint. Well, if you're interested in neo-pragmatism, one obvious question is, how far do you go? Is it a local view applicable to some concepts, perhaps causation, but not to others? Or is it global? Is there a pragmatic human ingredient in all our concepts, as William James famously thought? There's this lovely quote from James, "The trail of the human serpent is thus over everything." So in James's view, for all our concepts, we need to find that human ingredient if we want to understand them fully. And my argument here is that thinking about the temporal aspects of language and thought supports James's global conclusion. So the paper is, the talk is in 6 steps. Originally, as you see, I wanted to do it in 5 steps, and there was a particular reason for that. An early version of this talk was for a meeting of philosophers and physicists and people interested in Buddhist philosophy at Berkeley. It was one of these meetings that was supposed to happen in 2020 and eventually happened earlier this year. But for that context, I wanted to take James's metaphor, the trail of the human serpent, and interpret it in a way which would be familiar to the other part of the audience. I thought these people are going to know all about 5-headed serpents, so if I can do it in 5 steps, that will make perfect sense to them. Unfortunately, the philosophy ran ahead of the metaphor, and I wanted to include the stuff which is in section 6 here, and I particularly want to include it for this audience. So I ended up with 6 steps to global pragmatism. And then fortunately, at some point when I was preparing the slides, I came across that rarest of beasts, a 6-headed serpent. See, this is a 6-headed serpent, which has become 6-headed rather than 7 by decapitation. And it's particularly appropriate in my view that the snake, the head that's missing is the one which would have best claim to a sort of God's eye point of view looking over the rest. And one of the lessons of James's global pragmatism is we have to dispense with that idea of a kind of God's eye point of view, even for science. Okay, so that's where we're going. And each of these steps, as you'll see, leads us in the direction of greater generality. So we'll start with a very narrow kind of focus in language, and then gradually, as we go through the steps, get to something much broader. So we'll start with temporal indexicals. What does that mean? Well, it means words like now and terms such as yesterday, today, and tomorrow, and tensed expressions in general. Tense is deeply embedded in probably all languages, but maybe there are some which don't have it. What these indexical expressions do, indexical as philosophers say, is they indicate the temporal location of something in relation to our own temporal location at the time of speaking or sometimes writing. Other kinds of indexicals do similar things with respect to spatial position, terms like here and there, or to personal identity, terms like I and you. Now, for the spatial and personal indexicals like here and I, almost everybody is a neo-pragmatist. Almost nobody thinks that in using these terms, we're talking about some distinctive aspects of the world, some objective here or an objective me. But in the temporal case, many philosophers and some physicists think that that case is different, that there is an objective now or present moment in the world, in a sense in which there isn't an objective here. And what a neo-pragmatist wants to say is, no, that's wrong. Now is just like here, and this pragmatic explanation of the tense language has the usual pragmatic advantage of explaining the way we talk without requiring a distinctive subject matter. I'm not going to give you the arguments for that view. As you'll see, for this talk as a whole, I'm describing a progression of thought without arguing for it, although we'll touch on the arguments at various points. In that case, we were focusing on a particular aspect of our conception of time, the idea that there's something distinctive about the present moment. But we can ask a more general question, a question I'm stealing here from the title of this lovely book by Craig Callender, a philosopher at San Diego. Here are 4 ways in which time seems to differ from space. That's what Craig means by the question, what makes time special? How does it differ from space? There's the apparent reality of the now that we just talked about. There's the sense that time passes or flows. There's the difference between the apparent fixity of the past and openness of the future, which has come up in various places, including in Janan's lovely talk yesterday. And there's the sense that time has a preferred direction. Now, many of these things may be linked in certain ways, but I think you can regard them as all more or less independent, in the sense that somebody could believe in more or less any combination of them. And my recommendation that I've argued for in several places is in effect pragmatism on all points. That is, we should regard all of these 4 aspects of the ordinary view of time as reflections of our own viewpoint, rather than something which is there in reality independently of us. I'm not going to argue for that view, but I'm going to give you a couple of quotes for some of the aspects so that you can see the viewpoint reflected in the views of some physicists and philosophers. So here are, first of all, Bertrand Russell, and then in the second quote, Frank Ramsey, on the difference between past and future. This is in a famous paper of Russell's from 1913, in which he's very dismissive of the idea of causality, saying that there's no place for it in modern physics. At one point in the paper, he comes across the question as to why we think of the past as fixed and the future as open. What he says is, we all regard the past as determined simply by the fact that it has happened. But for the accident that memory works backward and not forward, we should regard the future as equally determined by the fact that it will happen. So what Russell is proposing, I'm not claiming that he's right about this, but what he's proposing is that the apparent difference between past and future depends on this fact about us, that our memory works backward and not forward. And if he's right, then that's a neo-pragmatist explanation of this apparent difference between past and future. 16 years later, in one of the last things written by Frank Ramsey, Ramsey says, it seems, a fundamental fact that the future is due to the present, but the past is not. What does this mean? It's not clear, and if we try to make it clear, it turns into nonsense or a definition. And then Ramsey turns it into a psychological question, a matter of psychological analysis, as he puts it elsewhere in the same piece. What then do we believe about the future that we do not believe about the past? This seems to me to be the root of the matter, that I cannot affect the past is a way of saying something quite clearly true about my degrees of belief. So what I want to emphasize here is the way in which that view fits into this, what I'm calling neo-pragmatism. It's dealing with the psychological question about us, not trying to treat the difference between the past and the future as some aspect of physical reality. Recently, when I was writing a review of Cheryl Misak's wonderful new biography of Ramsey, I had what I think is a sort of historical discovery, which should have occurred to me much sooner. But I've often wondered where Ramsey got this question of the difference between the past and the future from. It doesn't show up in other places in his writings, and I wondered whether he got it from that piece of Russell's that in the first quote, because he presumably knew of that. But a much better hypothesis, I now realize, is that he got it from Eddington's famous book, The Nature of the Physical World, which had been published in 1928. And Eddington's book became a bestseller. It was reprinted several times by the summer of 1929. This piece of Ramsey's was written in September 1929, 4 months before his death. And it turns out, and I'm grateful to Cheryl Misak for telling me this, it turns out that we know that Ramsey read Eddington's book because there are a couple of pages of notes about it which survive in the Ramsey archives in Pittsburgh. And in one of the chapters of Eddington's book, Eddington specifically addresses this puzzle about the difference between the past and future and the direction of causation. He doesn't have any answer to propose, but he clearly sees the problem. And I think that what was happening here was that Ramsey was doing something that he did on many occasions, that is picking up a problem from the leading thinkers of the day, often the leading Cambridge thinkers of the day, and then just briskly solving it in the course of doing something else. Okay, that was those quotes were about the difference between past and future, but that's a slightly different issue from the issue of the direction of time. So here's a quote from Boltzmann, Ludwig Boltzmann, from 1825. And what's interesting about this quote is that, as far as I know, it's the first time that anyone, a physicist or a philosopher, explicitly puts on the table the possibility that time doesn't have an objective direction. So in the context of discussing a possible picture of where the low entropy character of our universe comes from, a very puzzling thing in the light of Boltzmann's own work, because Boltzmann has shown, in effect, that by far the most likely state for a universe to be in is a high entropy state, but our universe is not high entropy. It's sort of on the way to thermal equilibrium, but it's a very long way away from it, fortunately for us. And in the context of this proposal, which is a proposal that in different regions of the universe, the entropy gradient might run in different directions, Boltzmann notes that in this picture, the two directions of time are indistinguishable, just as, he says, just as in space, there's no up and down. So we're now very familiar with the idea that what we count as up is a different direction here in Helsinki than it is in my hometown in Sydney. And that, despite what some of us may think, there's no objective fact about the matter. And that's what Boltzmann is proposing about the direction of time. Now, in my view, and this is something, again, I've argued in other places, it's hard to make sense of what it would be for time to have an intrinsic direction, at least if we want to connect that fact to our ordinary dealings with time in physics and in ordinary life. But it's easy to explain why temporally oriented creatures such as us, all sharing the same orientation, should think of the direction of time as being an objective feature of our environment, just as our ancestors, our sort of spatially localized ancestors who didn't travel very much, did with up and down. And here the recognition of this perspectival or pragmatic element has the usual Copernican advantages. We avoid the need for structure in the world, avoid the need for an objective direction of time, by explaining the appearance of structure as an artifact of our viewpoint. Okay, that's two steps. So we've done indexicals, we've done various characteristics of time. Now to something more general, what I'll call the temporal modalities, the notions of causation and probability. For both of these things, I think, there are two big things that a philosophical account of these notions need to explain. One is the connection to rational decision. So in the case of probability, we want to make sense of the idea that probability is our guide to such things as choice of betting odds, gambles. How much should we bet at what odds on a particular horse winning the race? As Ramsey says, all our lives we are, in a sense, betting. And he has an example of deciding whether to go to the bus stop, thinking about the chances that the bus will actually come. And for causation, we want to make sense of the intuition that causation is our guide to how we can do one thing to achieve another. So it has that sort of practical connection again. And then they both have a temporal orientation, or seemingly. So we think that the past determines the chance of the future. Again, the sort of theme that was prominent in Janan's talk yesterday. And we think that effects, no, it should be the other way around, causes typically precede their effects. So we think of causation as having a temporal direction too. Now, in the case of probability, but not for causation, in the case of probability, this practical relevance issue is very well known. Ramsey himself objects to Keynes's theory of objective probability relations, that such relations would, quote, stand in such strange correspondence with degrees of belief, which for Ramsey are cashed out in terms of, in a behaviorist way, in terms of choice of betting odds. Keynes had published his book on probability sort of just at the time when Ramsey came to Cambridge as an undergraduate, and Ramsey read it and immediately sort of put his finger on the basic flaw at the heart of it. Much to Keynes's delight, it was one of the things which led Keynes to see what a brilliant person they had in Ramsey. 25 years later or so, we have William Neal saying that knowledge of probability relations is important chiefly for its bearing on actions. Another 25 years later or so, we have the Cambridge philosopher D.H. Mellor in his book, The Matter of Chance, and he explicitly takes this from Neal. He says it must follow from our account of chance that the greater the known chance of an event, the more reasonable it is to act as if it will occur. And finally, this is one that philosophers, it's probably the one that philosophers know best on this list. This is the great David Lewis saying in his paper, a famous paper of his from 1980, I wonder whether anyone but a subjectivist, which means, roughly speaking, a neo-pragmatist in my terms, is in a position to understand objective chance. And Lewis's point is that unless you put in that link with choice of betting odds right at the beginning of your account of probability, you're not going to be explaining it later on. Now, for causation, it's hard to find the corresponding point. There are many philosophers who think that we need objective causal relations to explain rational action. A famous case here is Nancy Cartwright, who argued in a very well-known paper from, I think, 1979, that in order to in order to make sense of a distinction between effective and ineffective strategies, for example, to explain why normally turning on a light switch is an effective way to turn on the lights, but moving the needle on your barometer is not an effective way to change the weather, even though there's a correlation in that case too. In order to explain that, Cartwright thinks we need a picture of the world which contains objective chances, as well as sort of patterns of correlation. But there's also a neo-pragmatist tradition in the causal case, which again dates from Ramsey. And this tradition explicates causal concepts in terms of the agent's perspective. As Ramsey puts it, and again, this is from this piece from September 1929, from the situation when we're deliberating seems to me to arise the general difference of cause and effect. One way to sort of encapsulate this view, I think, is to say that the difference between causation and correlation is that The causal correlations are the ones that agents like us can exploit in the interest of making things happen. And by exploit here, it means that, you know, if we've got a correlation between A and B, and we think of ourselves choosing whether to do A, is that an effective means of producing B? And again, in other work, I've argued that this approach provides the best explanation of both the issues that I distinguished on the previous slide. So both the connection with action, that's the practical relevance point, and the temporal direction of causation. Both of them come from, in effect, they come from us. Because as agents, we all share the same temporal direction, and that's why we think of causation as having a kind of temporal arrow. Okay. Again, we're covering a lot of ground, so I won't say any more about those arguments, but I just want to now move to another level of generality. At the previous step, we were talking about two particular kinds of concepts, that of causation and that of probability. Now we're talking about a much broader class of concepts, what philosophers call dispositions. What are dispositions? Well, here's a quote from John Mayer's article in the Stanford Encyclopedia of Philosophy. Mayer says, dispositions are those properties picked out by predicates like is fragile or is soluble, or alternatively by sentences of the form X is disposed to break when struck. Dispositions so understood have figured centrally in the metaphysics and philosophy of science of the last century, and also in influential accounts of the mind such as Ryle's. So when we ascribe a dispositional property to something, we commit ourselves to an expectation about how the object would behave in certain circumstances. So if I say that the water jug is fragile, I commit myself to an expectation that if I dropped it on the floor, it would probably break. But expectation is a psychological notion. So where should we look for an account of the psychological relevance of dispositional properties? Is there some feature of the properties themselves which gives them this ability to support expectations? Or are we, as Hume thought, projecting our expectations into the world when we ascribe a property of that kind? So the two possibilities there, the first of them was what we could call the metaphysical approach, which takes on board the task of explaining the psychological relevance in terms of the sort of intrinsic nature of dispositions out there in the world. And then there's the neo-pragmatist approach, which begins at the other end, saying that we develop these descriptions because they're what we need as epistemically limited creatures concerned about our future welfare. So in this view, the expectational character of the manifest image, our tendency to describe the world in terms of dispositional properties, is grounded in our own psychology and temporal character. In particular, the fact that we're creatures who have to make our way in a challenging world with very limited information about the challenges we'll encounter in the future. Now, in this case, the neo-pragmatist approach has a long history, and I'm going to mention some landmarks, some well-known, some not so well-known. I've already mentioned Hume on causal necessity, the idea that what we take to be causal necessity in the world is a projection of expectations acquired as the result of observed regularities. A less well-known case, this is from some lecture notes of Wittgenstein's in early 1930. Wittgenstein says, "When I say there is a chair over there, this sentence refers to a series of expectations." I chose this quote because this term expectation is explicit here. "I believe I could go there," Wittgenstein says, "perceive the chair and sit on it. I believe it is made of wood, and I expect it to have a certain hardness, inflammability, etc. And all of these are disposition notions. Third case, this is Ryle, who I mentioned a moment ago, as described by Alexander Bird. Ryle says, "The sentence, 'this lump of sugar would dissolve if placed in water,' does not assert some factual truth, such as the attribution of a property to a thing, Rather, along with law statements, such assertions must be understood as inference tickets. One is entitled to infer from this lump of sugar is in water to this lump of sugar is dissolving. So what Ryle is doing there, and this is very, very similar to the main point that Ramsey was making in the piece from 1929, is to say that sort of statements of general laws and of this conditional kind should be understood in this psychological way, in terms of the function they play in our systems of inference. And this inferentialist notion, as philosophers call it, is even more explicit in the picture that's particularly associated with the great contemporary American pragmatist, Bob Brandom. And in his picture, it's one that puts the dynamical character of dispositional concepts at the core of all empirical concepts whatsoever. So it's a view he takes to be inspired by Kant via Wilfrid Sellars. And the main difference with the ones I've just talked about is that it replaces the Humean habitual conception of the psychology involved. For Hume, it's just a matter of habit, with a normative one. So the point that Brandom takes from Kant and Sellars is that we're not just creatures of habit, we're normative creatures. And understanding our concepts in terms of the inferences they license and are licensed by has to be understood in this normative framework. So concepts are understood in terms of their role in the dynamic behavior of norm-governed inference engines, which is what on that picture we are once we become language users. So here are some neo-pragmatist conclusions about dispositions. At least a major part of the set of properties we ascribe to the world reflect the temporal character of human thought, in particular, our continual striving to prepare for an uncertain future. And in this way, our own temporal character is reflected in our image of the world that we inhabit, both in science and in everyday life. And again, these are pragmatist lessons. They require that we reflect on our own natures as physical entities of a particular kind, processes embodied in time in which each stage has an interest in later stages. So it's a very general kind of conclusion. As I said, someone like Brandom wants to take this Kantian, Salasian lesson to be applicable to all our empirical concepts whatsoever. But is it necessarily a global view? Or could there be some sort of residue of language which isn't in the business of ascribing these dispositional concepts, but is doing something more limited? The next step, I want to argue that that possibility is off the table for deeper reasons to do with the nature of language. I quoted Wittgenstein before. Every sentence we utter in everyday life appears to have the character of a hypothesis. Wittgenstein goes on, the representation loses all its value if the hypothetical element is dropped, because then the proposition does not point to the future anymore. Now, for scholars of Wittgenstein, one of the interesting things about this is that this is a place at which Wittgenstein is clearly in the process of giving up the kind of picture theory of meaning that he'd held in the Tractatus and moving to another period. And it's well known, particularly emphasized in Cheryl Missak's wonderful work, that he did this under the influence of Ramsey, and Ramsey got some of the ideas from Charles Peirce. So there's a pragmatist heritage here that we understand better thanks to Missak's work. But for my point, I think for my purposes, I think what Wittgenstein is thinking about here is not exactly the point I want to make. I think what Wittgenstein is thinking about is the way our descriptions build in expectations. But I think time is also relevant to language in a more basic way. When we use a sign, it's a gift to the future in some way, something that we put in place for later use by someone else or by our later selves. Think of a case in which you you write on the palm of your hand the things you need to pick up when you next go to the supermarket. The success of that activity depends on the fact that there's something in common in your dispositions when you write the milk on your hand and when you get to the supermarket. If you'd changed in various ways in the intervening time, the sign wouldn't work in the way that you want it to work. You might come home with chocolate or something else. Now, this is an idea which is picked up, at least in one manifestation of it, is picked up in the so-called rule-following considerations, which derive from Wittgenstein, but our sort of modern understanding of them owes a lot to a famous book by Saul Kripke from 1982. And those considerations turn on the observation that no finite amount of training can guarantee that two speakers won't diverge in their understanding of a term at some later point in time. So again, it's the point that our use of language depends on contingent features about us, features which in principle might vary between speaker and speaker. And so I think it reveals a sense in which all of language depends on, as I said, contingent features about us. And in other places, I'm one of several people who've argued that these rule-following considerations lead to a kind of global pragmatism. Okay, so thinking about the temporal character of language and how it depends on contingent facts about us gives us the kind of generality that I was looking for. I think we can't make sense of any language at all which doesn't have a pragmatic ingredient for that kind of reason. But here's the sixth step, which originally I wasn't going to put in because I wanted the five-headed snake. But I came across this work, and although I really don't know anything sort of deep about it, I'm relying entirely on other people, I think it's such a nice way of reinforcing the lessons that I've been trying to draw in the rest of the talk that I want to present it as well. And I'm going to do that just by a few carefully chosen quotes from some of the leading philosophers writing about it. So far, what I've argued is that at all three corners of the mind, language, manifest world triangle, so that is in concepts, in linguistic terms, and in properties, we found marks of the kind of temporal creatures that we ourselves are. And I've argued that these are deeply neo-pragmatist conclusions. To finish, I want to mention some recent developments in the science of the mind that seem to push this viewpoint even further, with further implications for pragmatism. This quote is from Jacob Howie, one of the leading philosophers writing about the so-called predictive processing framework. Howie says, "A new theory is taking hold in neuroscience. It's the theory that the brain is a sophisticated hypothesis testing mechanism which is constantly involved in minimizing the error of its predictions of the sensory input it receives from the world. This mechanism is meant to explain perception and action and everything mental in between. It has enormous unifying power, and yet it can explain in detail too." Now, I'm well aware that there may be, that there certainly are many people in this audience who know a lot about this, more about this stuff than I do, and some of you, of course, may disagree with these claims by Howie, and if so, I'd be very interested to hear about that. But here's another quote. This is from Andy Clark, another one of the philosophers writing about this material. Clark says, "Creatures deploying this kind of strategy learn to become knowledgeable consumers of their own sensory stimulations. They come to know about the world and about the kinds of entity and events that populate it. Creatures deploying this strategy, when they see the grass twitch in just that certain way, are already expecting to see the tasty prey emerge and already expecting to feel the sensations of their own muscles tensing to pounce. an animal that has that kind of grip on the world is already deep in the business of understanding that world. And if you can probably see, what I like about this thought is the way that it takes this notion of the dynamic temporal character of ourselves and of our reliance on expectations and builds it in very deeply into or claims to build it in very deeply into an understanding of, well, really of the kind of neuroscientific structure that we embody. Now, some people have thought that this picture supports a view of the mind, which in some ways is deeply in tension with pragmatism. One of pragmatist claims is that we shouldn't think of mental activity in an overly representational way. Famously, Richard Rorty dismissed the idea that the mind is a mirror of nature in a sort of simplistic representational way. There's this interesting paper by Dan Williams, a Cambridge philosopher, who wants to argue on the contrary that what's supported by the predictive processing framework is a deeply pragmatic view. So Williams says the initial appearance of a deep conflict between pragmatism and the predictive processing framework is illusory. Far from an image of minds as passive spectators on the world, predictive processing advances a fundamentally pragmatic brain, striving to maintain the viability of the organism under hostile conditions, and in so doing, actively generating an effective niche, an experienced world structured by the idiosyncratic practical interests of the organism. And then picking up on some of my work, Williams says, what emerges is something much closer to Price's metaphor of a holographic data projector than a passive reflection of an independently identifiable world. As Clark puts it, it's a vision of experience that is maximally distant from a passive mirrors of nature story. Okay, so that's the end. That's William James. There's my six-headed serpent again. Paavo, how much time do I have left?
I think you have actually quite a lot. You started a little bit late, and I don't think we're going to have a huge rush, so you got plenty of time, at least 15 minutes.
Okay, in that case, I'm going to give you a little postscript, which is more quoting from other people or an other person, but he's such an interesting writer who will be known, I think, to all of you. And what he's saying ties this story about the predictive processing framework so nicely back into these themes that we've had in the neo-pragmatist picture since Hume, that I'm going to give you this little postscript. And this is from a little piece in which Daniel Dennett writes about the predictive processing framework. It's from one of those brain and behavioral sciences symposia paper. I think the original one is by Andy Clark in this case, and Dennett is one of the commentators. Dennett says, one of the things in our world is causation, and we think we see causation because the causation in the world directly causes us to see it. The same way tigers in moonlight cause us to see tigers. When we see the thrown ball causing the window to break, the causation is somehow perceptible out there. That's what we naively think. Not so, says Hume. This is a special case of the mind's great propensity to spread itself on external objects. In fact, Hume insisted, what we do is to misinterpret an inner feeling and anticipation as an external property. The customary transition in our minds is the source of our sense of causation, a quality of perceptions and not of objects. But we misattribute it to the objects, a sort of benign user illusion, to speak anachronistically. So that's Dennett describing this Humean picture that I started with at the beginning of the talk. If we use the shorthand term projection to try to talk metaphorically about the mismatch between manifest and scientific image here, what is the true long story? What's literally going on in the scientific image? A large part of the answer emerges, I propose, says Dennett, from the predictive coding perspective. Think of the cuteness of babies. It is not, of course, an intrinsic property of babies, though it seems to be. What you project out onto the baby is, in fact, your manifold of felt dispositions to cuddle, protect, nurture, kiss, coo over that little cutie pie. It's not just that when your cuteness detector, based on facial proportions, etc., fires, you have urges to nurture and protect. You expect to have those very urges, and that manifold of expectations just is the projection onto the baby of the property of cuteness. When we expect to see a baby in the crib, we also expect to find it cute. That is, we expect to feel the urge to cuddle it and so forth. When our expectations are fulfilled, the absence of prediction error signals is interpreted as confirmation that indeed the thing in the world we're interacting with has the properties we expect it to have. Cuteness as a property passes the Bayesian test for being an objective structural property of the world we live in, and that's all that needs to happen. Any further projection process would be redundant. What's special about properties like sweetness and cuteness is that their perception depends on the particularities of the nervous systems we've evolved to make much of them. The same is, of course, also true of colors. That's what's left of Locke's and Boyle's distinction between primary and secondary qualities. So that's Dennett's very lovely application of the predictive processing framework to understanding this basic distinction, which is, of course, at the core of the neo-pragmatist project. If there's anything I wanted to add to Dennett, it's the sense that, as Hilary Putnam once said, referring to Kant's views, it's the sense that it's secondary qualities all the way down, because there's no core from which we can strip out the pragmatic ingredients. Okay, so that's really the end. Thank you. And
So we have time for questions, and we got Ron over there, please.
Thank you. Wonderful picture. I wonder, I'm persuaded by it. I like the approach of neo-pragmatism. I didn't know that until now, but I wonder if we could be even more ambitious and take the seventh step, which is, and I think that's a way to view what some of us have been doing in the area of consciousness studies, is moving beyond the mind of the predator and beyond the mind of the person looking at the baby and seeing cuteness, but trying to move to the mind of the consciousness studies person looking at consciousness and finding qualia there, and finding that supposedly there are these things that are private and intrinsic and ineffable and structureless, or whatever you want to call it. And instead find that, like Hume did with causation, that those are not in the qualia themselves, but rather are a consequence of our abilities, of how we try to understand the mind. And so locating those properties not in the world, only in as a consequence of our attempt to understand the world, our attempts to understand our own conscious experiences. Would you accept that that's the final, move?
That's very interesting. I mean, I find that approach very appealing, and I like the idea that it sort of adds an element of globality that I've missed. But even if I missed it, then Dennett certainly didn't, because it sounds to me very synergistic with Dennett's famous move of, as he puts it, quining qualia.
Right. So that might be where you and I would part ways. Then is if you do that analysis, and find those properties of qualia to be mainly located in us rather than in anything out there. Would that mean you have to eliminate qualia, or do we just find out that we revise our conception of qualia and now it's revealed to be what it actually is, and all those other properties are seen to be the consequence of our attempts to understand it? I think that it doesn't imply eliminativism directly, that we find most of qualia's features are revealed to be neo-pragmatic feature, the result of neo-pragmatic. So I think it's actually an empirical issue whether it turns out that qualia will be saved like gold or whether it will eventually be discarded like phlogiston. It's not, we can't actually know right now, but eventually empirically when we do this work that you're pointing the way towards, and Dennett's preempting the issue. He thinks that because we're wrong about qualia, therefore they must be eliminated. But we know in the history of science we've been wrong about things, but we didn't eliminate them. We just revised our theories.
Yes. So again, I'm very sympathetic to that thought, and I think the general, what I'm calling the global pragmatism program, provides a nice way of reinforcing that, and one which Dennett himself misses. Because as you can see here, Dennett is in effect taking for granted that there is a real distinction between the primary and the secondary case. And one of the reasons that he worries so much about how to interpret his own view about the intentional stance and whether it's instrumentalism, whether that matters, is because he's hung up on this old view that there's a division there. And he doesn't want, in some problematic sense, to end up on the wrong side of it for something as important as the intentional stance. But if you just stop worrying about that, because you can't worry about it, because it all depends on the fallacy of thinking that there's some non-pragmatic scientific language that creatures like us could possibly use. Once you've got rid of that picture, then it becomes a much more interesting question as to where things sort of get located as everything shakes up and we come to understand more about the sort of pragmatic sources of particular concepts. Perhaps one thing I'd like to add, just going back to the first point about qualia, is that one of the things I've always thought, but never kind of been able to develop the thought very much, is that the kind of contrast between the people make when they're talking about qualia, between this sort of first-person perspective, and Nagel talks about it in his famous paper, and the third-person perspective. It's as if there are these two realms, but they're both being thought of in some sense as third-personal, and you see this very much in the views of the people who call themselves panpsychists, and who think of the subjective things as being an extra ingredient in the world. What they're missing is what it means for something to be subjective, and that's where you need the kind of story that you were proposing.
Thank you. Let's see, we have a question over there. I think, is it Cameron? Yeah.
Hi, thanks, very interesting talk. So you gave a very nice psychological explanation of causation in terms of expectation, in particular exploitable expectations, right?
Could you speak up a bit, please?
Yeah, in terms of exploitable expectations, right? And one thing I was curious about is if you might want to add also to get the sense of necessitation that, for example, you might associate with a more causal powers type view, the kind of like making happen or bringing about. Some people maybe interpreting or elaborating on Hume have suggested that also part of what we paint on to the world is a projection from our own experience as being an agent that can will things to happen and, for example, make our body move and so on, that we sort of also paint that onto the external causal relations, right? And that explains why people who favor a causal powers metaphysic think there's a kind of thing out there. And so I was just curious, is that something you see as compatible with your neo-pragmatist view of causation and might want to add, or did you have a principled reason for going for kind of a slimmer expectation only?
No, I think it's completely compatible. But the thing I want to stress in a fuller picture is that I think the Humean picture, as we usually understand it, in terms of this notion of expectation and habit, is missing a crucial piece of the picture, and this is the one that Ramsey got onto so explicitly. So what Ramsey does in that piece is to characterize the distinctive epistemic viewpoint of an agent. That is, and this is the crucial thing, and the thing that's related to Jinan's talk yesterday, a creature that takes itself to have the ability just to make certain things true in the world. And then Ramsey sort of sketches this understanding of causation in terms of probabilities for conditionals with the special property that one of the elements in the conditional is something that we take ourselves just to have the capacity to make true or false as we want. And as far as I know, Hume doesn't really get that element of the picture, although I think he's right that what we're doing when we talk of causal powers is, in a sense, projecting our this feature originating in our sense of agency out into things in the world.
Thank you.
Yeah, so, and did we have another? There's one there on the left back.
Hi, thank you. I would like to press on the anti-representationalism question. So one consequence of anti-representationalism that many have emphasized seems to be that it renders kind of meaningless the whole distinction between the world and a representation of the world, if it's run to its logical conclusion. Something like that distinction still seems to be relied on a lot in these arguments that are of the form some property is not a property of the world, but comes from us. The word world in that argument still seems to be a residue of something like the world of the world representation distinction, something like primary qualities or a residue of Newman or something like that. So this is something that always kind of makes my brain kind of tilt with neo-pragmatism, because first, it makes sense within the representationalist picture to say this comes from a representation, not from the world. That makes sense. Then, when that's run to the conclusion of therefore there is no representationalism, that implodes on itself. It renders the argument incomprehensible to me. So can you help me with making that clear?
It's a very good question. And it's one that deserves to be pressed against anyone who claims to be doing what I'm doing and presenting this kind of global pragmatist picture in which there's nothing of the kind that Sellers had in mind when he talked about the scientific image, no residue of language which doesn't have pragmatic ingredients. My view about that, sort of briefly, is that, and the case of causation is a very good illustration here, is that there's no real vicious circularity in using causal notions in thinking about the pragmatic origins of causal thinking. If we want to think about the pragmatic origins of causal thinking, one way to do it is to ask the question, well, how would things be different if we didn't have these concepts? But there, of course, you're thinking about a counterfactual question, which is very closely related to a causal question. But is that vicious? Not at all. We are creatures, and even as scientists, we're creatures who have these conceptual tools. But that shouldn't prevent us from asking questions about the origins of those tools. Gee, I think one of the most interesting sort of contemporary possible sort of manifestations of this point is in quantum theory. And we heard the other day from Chris Fuchs about this sort of cubist, this very pragmatist view of quantum theory. But one of the disagreements that Chris and I have been having over the years is to what extent this is compatible with the idea that we might want to ask the question, well, what kind of world would look like this, look as quantum mechanics does, from the point of view of creatures in our situation? I think we can always go on asking that question, even though whenever we answer it, whenever we propose a model, we haven't stepped outside of the pragmatic framework. So the terms in that model will themselves have pragmatic grounding. But nevertheless, if we could come up with a good answer to that question in the case of quantum mechanics, we would have learned something fascinating. So I think that there's really no alternative. We have to face up to the fact that even when we're doing science, we're doing it as contingent human creatures with a psychology of a certain kind. This is what I meant by the fact that it was the snake at the top who'd been decapitated in that lovely image of the Buddha. What we have to reject is the idea that science gives us a kind of God's eye viewpoint on the world, which is free of these pragmatic factors.
Great, thanks. Let me also ask one question, or perhaps first like a comment and then a question. So it's of course it's of course very important in philosophy to take into account the human perspective, and perhaps in some sense a certain kind of philosophy begins there with humankind and all that. We realize that as human beings we can't ignore our perspective and the way what we bring to experience. But then again, of course, it is a coherent possibility that there exists a real world with objective properties, and then we may or may not be able to represent them. And when it comes to time, I mean, it seems to me that time also has those properties that look very objective, and for example, aging. So, I mean, I can say, yeah, well, aging is nothing but some sort of perspectival thing, or somehow it's. But then again, of course, as a human being, we're aging, and we know we're probably going to die, and so on. So, and in some sense, what would you make of that? I mean, how do you feel yourself? Are there aspects of time that are more difficult to just see as perspectival, aspects of time that feel more like objective, that they are not up to us? We're aging, and that's it.
Well, I do think on my slide with a picture of Craig Callender's book, I had 4 different aspects of time: the distinguished present, the sense of flow or passage, the difference between past and future, the sort of openness of the future, and the idea that there's some sort of underlying intrinsic direction to time. Now, I do think that those 4 already illustrate the point you want to make, that it's easier in some cases to think of those as not being fully objective than it is in other cases. So in the case of the distinguished present, I think it's a minority view among philosophers and among physicists that there's something objective there. Whereas in the case of the direction of time, some very distinguished philosophers of physics, and I think distinguished physicists, seem to find it hard to make sense of the idea that it's not something objective. Whereas my view is the opposite. I find it hard to make sense of what it would be for it to be objective. But what that illustrates is that this difference in intuitions of objectivity that you're talking about. The point I want to emphasize again is that if you're a global pragmatist of this kind, you have to see it all as a matter of degree. There's no stepping outside the pragmatic frame.
Thank you very much, and let's thank you once more. Thanks. Now, about lunch, as we mentioned already on Thursday, unfortunately, the Unicafe is closed today. We have lunch for speakers and the staff, and so. But anyway, there should be in the Cowley Center. There are places open, but this is sorry about that. I think they probably had some staff shortage like that, so they didn't keep it open, although we thought they would.
Yes, it is time to move on. Our next speaker is a local philosopher, Valtteri Arstila, who is interested in time consciousness and will be talking about temporal experiences after the fact. Please.
Thank you very much, and thank you very much for organizers for having me here and everybody who came to listen to me. Yes, so my talk is about temporal experiences, and that, of course, means very different things to various people depending on your background. So let me first start saying what I mean by that what I'm focusing on, and then what I'm going to do. So that really, temporal experience refer to several different things, but my talk relates to experience of succession, motion, change, and causality. I've not really properly talked about those, but the question how we explain our experiences of those four things. Why these four things? Well, they are kind of the subclass of temporal experiences, and they have four common features. First of all, they all concern temporally extended events, unlike simultaneity, for example. Second, they all occur within relatively short timescales, unlike persistence or experience of duration. Most philosophers also think that we do actually experience these things, that we experience that there's succession, motion. Even, well, philosophers are hesitant about causality, but I would say that in kind of empirical mind sciences, it's quite well established now that we do have experiences of causality. And again, whereas at least in philosophy, there's a big debate whether we actually experience passage of time or present as a temporal notion. But most importantly, I'm focusing on these four temporal experiences because they are at the heart of time-conscious theories. So theories that try to explain what is the kind of temporal structure of our consciousness so that we could have these experiences. And these questions are, like time-conscious theories have been discussed in philosophy at least since the mid-19th century. And of course, those of you who know Husserl said that addressing these kind of experiences are possibly the most important questions in a phenomenology. So the father of phenomenological tradition thought that given an explanation of these features is crucial for the phenomenological tradition. At this point in the philosophical debate, there's a lot of there's some kind of consensus that people who explain this use some kind of the term, they refer to notion of species present, which I will explain soon. And my objective or goal today is simply to argue or raise a problem for these theories and saying that you think that you can explain temporal experiences, you might actually do that, but you need to be more explicit about those explanations, that what you are doing at the moment is not enough. That's my goal. Quite modest in a way, but if it's true, then it might have, it has quite a substantial implications, I would say. Right, so in general, in a broader perspective, we have two approaches to temporal experiences. The first one is what I think most people usually, well, at least for me, it's kind of the intuitive position, what I call snapshot views, the idea that our experiences are objectively and subjectively confined to near instant. And here's a kind of picture of what that might mean in a subjective sense. So we hear a door, re, me, in the kind of stream of consciousness, and what we experience at one moment or within one episode of experiencing in a snapshot, is limited to one instant, for example, re. Now, what we have here is obviously the succession of experiences. What we don't have is succession of feelings or succession of so the succession of feelings in and of itself is not a feeling of succession. Point made by William James, Husserl, and dozens of others since then. Something in that, and if you think about this, when we hear re, we don't experience re anymore as succeeding do. We need to have some kind of additional explanation how we can come up with the experience of succession. and same thing for other temporally extended experience of temporally extended events. Some snapshot view theorists like Reid, Schwartz at the moment, have just rejected the idea that there are temporal experiences, and there are 3 others who have tried to come up with additional theories or explanations: Robin Lepet-Van, Simon Prosser, and I'm the 3rd one. But I'm not going to talk about our positions today. Instead, I want to go to this more maturity view and its problems. But before doing that, I do want to point out that when you look at the at least leading neurobiological theories of consciousness, I mean IIT, global neural workspace theory, high-order representational theory, recurrent processing theory, all of those conform with the snapshot views. And so if this criticism from James and others is correct, these theories are missing some fundamental element from our experiences. And of course, if you were really attentive on Thursday's lecture, you noticed that IIT is actually working on providing explanations on temporal experiences too in their version 4.0. But most philosophers don't take this as approach. Instead, they approach this by assuming some kind of species-present theory, which basically, there's different versions of that or different definitions, but basically, for our purpose here, the idea is that the contents of a single episode of experiencing, namely species present, appear to us as temporally extended. So when we hear, it's not what we experience in not single instant, but we temporal extension. When we hear re, we still somehow experientially, essentially, do is present in our experiences. This view was popularized in 1890s by William James. This is a picture of William James 20 years earlier, but it's my favorite picture of him, so that's why I'm always using that one. It is taken from him when he was in Brazil. But what he says is that practically cognized present is no knife edge, but a saddleback with a certain breadth of its own. It is only as parts of this duration block, namely species present, that the relation of succession of one end to the other is perceived. We seem to feel the interval of time as a whole, with its 2 ends embedded in it. So he's saying that what we experience, in a unified single experience, we experience an interval, and it also has some kind of temporal structure because we feel one end and another end, and obviously something in between. And when we have such an experience, we can also experience succession. And that's the basic idea behind the species-present theories. Now, of course, at least if you are like me, I would like to hear something more about what does this really actually mean for explaining temporal experiences. And luckily, species-present theories nowadays have said something towards more at least somewhat better explanation or been more explicit about this explanation. And I think, at least as far as I can tell, there are 2 different options how they can go forward. The first one, and first example, is from Barry Dayton from his paper, Ingress in Stanford Encyclopedia of Philosophy, where he argues that the species present can house continuous change, namely movement, in the manner shown in figure 6, which I have copied here on the right side. Here we see a ball falling, bouncing, and rising again, all within the confines of a single species present. So the basic idea that, at least as far as I understand him properly, is that when we have all this content in the species present, we have experience of ball at different places at different time, and we experience all of that within a unified single experience, namely species present, that the movement already manifests itself. It is there in the temporal structure of the species present. And the same idea we also find in Ian Phillips, briefly just put the previous reflection reveals that temporal properties are manifest throughout perceptual experience. So the way I understand what they are doing is basically that this is the basic argument. First, in order for them to make claim that we have single experience that is temporally extended, we must somehow account for that temporal structure within the species present. We must give an account why this pole here is experienced to have occurred before the location of the pole in this place and so forth. That is something that they need to do in order to describe what the species present basically is. There's a question whether they can do it or not, but I'm just allowing that for them at this point. But if we have that in place, then they argue that we don't need any further explanation. All the temporal features, motion in this case, or succession in other cases, for example, are already manifested in this temporal structure. So no further explanation is needed. Manifest properties are all there is. Now, I don't think that this option is good enough. And here's a reason. So if it really is that that temporal experience are direct consequences of the temporal structure, it means that every time when we have the same apparent temporal structure, same temporal structure within the species present, it follows that we should have the same temporal experience. And that doesn't appear to be the case. There are several different examples of this, but I wanted to show you the example related to perceptual causality. So here's a stimuli used by Strauss and Chatterier on their kind of quite basic experiment on the kind of thresholds regarding the perceptual causality. They have blue ball moving for a second or so, hitting a red ball, and red ball starts moving. And they had two variables. First, one of which they varied was the angle of the movement of red ball. Another one was a time delay between the kind of onset of the red ball after collision. And what they found in this is psychophysical study combined with fMRI data, which I'm not going to talk. But what they found was basically the results are this. If you look at the time delay, if the time delay is very short, most of the time people reported having perceived causality or experienced causality. With the longer time delays, the reports decreased. And same with the increased angle. So if you have a 60-degree angle, only 60% of people reported perceiving causality. Now, the reason why I think this is interesting study and what was kind of my takeaway message of this is simply that we have these cases with zero time delay, for example, or short time scale, where people report perceiving causality only about, let's say, half a time, or 40 to 60% of time. And which certain kind of assumptions, which we can go in later on in the details, it is most likely that when you show these kind of stimuli, what people experience kind of the stream of consciousness is also to some extent, or well, to extent enough, the same. So we can make an assumption that they have the stream of consciousness regarding the temporal structure remains quite the same. And still there are quite clear cut-off cases when people experience causality and when they don't. So there's a phenomenal contrast that we need to explain somehow. And if we assume that they have the same apparent temporal structure, but they have different experiences, it follows that the apparent temporal structure doesn't explain the temporal experiences. Now, you might think that this is just the case for perceptual causality, but that is actually not the case. We have the same thing also with let's say, perception of change, and also, for example, experiences of succession. So when we have this kind of stimuli, do, re, mi, if these are separated, say, by 50 milliseconds, we experience the succession. People say that I experience re succeeding do. If we change or replace one of the tones, re, with the visual stimuli, here kind of image of ball, people don't report experiencing simultaneity. They don't necessarily say that they experience necessarily say that they experience simultaneity. They don't necessarily say that they experience succession. So here we have an experience of succession. Here we have the same temporal structure. At least most likely we have roughly the same temporal structure, but people don't report experiencing succession. So again, what we have here is a case where we have the apparent temporal structure does not provide us the same temporal experiences. So we need something else. We need some kind of additional story here. And luckily, I would say that it's not that difficult to come up with a story, and it's also one story, kind of another option that people who are working with species-present theories have done. And on this view, which is what basically I would say, like most of you would have said, is that temporal experience results from perceptual processes. And so the basic idea is that if you have temporal experiences, they are outputs, products of kind of perceptual processes. We have motion process, we have change perception process, we have causality perception process. It's not clear whether we actually have that for succession, but at least for those three, we have robust evidence that there are separate kind of independent processes related to motion change and causality. And as with all perceptual processes, they operate within certain spatio-temporal limits and based on certain kind of input. And what we have in this kind of problematic case, or cases where we have sometimes absence and sometimes presence of, let's say, perceptual causality, is simply that that stimuli is done based on, like, is such, like the experimenters have devised those stimuli in a sense that they are at the limit of this threshold when the processes actually function and when they don't. And because every time when we process some kind of stimuli, there are slight variations due to attention, neural noise, and so forth. Sometimes kind of these processes get triggered and sometimes they don't. Or maybe they get triggered, but they are not finished. And all of this is kind of basically what you have in psychophysics in general from since Fechner. So there's nothing kind of novel in this claim, basically. But that does explain our experience of temporal, like that, well, the presence and absence of temporal phenomenology, if we put it that way. And again, as I said, we have people who, in species-present theorists, who have put this kind of ideas forward. You have Christopher Hurl saying that, well, the upper and lower limits of temporal experiences reflect empirical and empirically demonstrable limitations of our perceptual systems and are to be explained on the level of information processing psychology. We also have Barry Dayton, for example, arguing kind of one of the reasons why Barry Dayton argues that we, like the justification that he gives for us having experience of motion is that we have motion perception processes. So he also kind of still refers to motion perception processes. He endorses what he called moderate naturalism. We have Rick Russell, we have like most of the current philosophers working on these topics do subscribe this kind of idea, or they would if they would actually put it on paper. However, I think that even though I think this is kind of correct way of explaining this, I don't think that this is a viable option for species-present theories. And here's my kind of argument. I put it working in progress at the moment, kind of called the problem of delayed temporal phenomenology. And the idea is this. So first of all, it's most possible to think that all the perceptual processes can begin or commence only after having suitable input. So we don't start processing sounds or motion or color without having right sort of input. Now this begs the kind of question, what's the role for having species present? And I think the the most obvious answer would be that if the contents of species present are to play some kind of role in the relevant processes, these contents they constitute the kind of input for these processes. That's why we have species present. That's why we need to have temporally extended contents in our experiences, because they provide us kind of the data for this process that bring about temporal experiences. And I have to say, one could think that this is quite far-fetched, but at the same time, I don't think it's so necessarily implausible. For example, we had a discussion yesterday where Lena was discussing on McCurk effect, and even though that effect in itself is kind of, there's a question whether it really is what it has been said, like whether there is that kind of multisensory integration. If there is such thing, there's a good reasons to think that happens only when we constantly perceive both visual and auditory stimuli. So if you render visual stimuli unconscious, so we don't perceive visual stimuli, we don't have McCurk effect. So sometimes in order to have some kind of cross-modal influences, we need to have conscious perceptions. And this would be the same with temporal processes. Based on these two premises, we can conclude that the motion perception, for example, can commence only after we have experienced a ball at two places. Only after we see that in the second place, we have kind of enough input for the motion process to start. Now the perceptual process, of course, they don't just require suitable input, but they also require some time to occur. So when the perceptual processes begin, it takes some time for them to finish, and when they finish, we experience their outputs. And if you consider about these third and fourth together, we can conclude that the temporal phenomenology occurs after the experience that trigger them. So basically what we have, we have two balls. We have ball in this place and then next place. When we see the ball in the second place, we can start processing motion. But this processing can only happen after we see the second ball. And because that motion processing, what brings about kind of motion phenomenology, takes time, it might be the case that the ball has started moving already before the kind of temporal processes, perceptual processes related to motion processing ends. So what we have is that basically, that's why my talk is Temporal Phenomenology Experience After the Fact, that with this view, or what we get is temporal phenomenology after the events that triggered them. And now my claim is that this conclusion does not concur with our experiences. What we experience is things moving, like they didn't put it in a word. We see a ball falling, bouncing, and rising again. We don't first see ball at one place, another place, and third place, and then later on experience that as a moving. So there's definitely, I would say that within this story, or with this premise, there's a conflict between our phenomenology and the implications of the species present theory. And the question is how to solve this conflict. And well, that is actually my challenge to those who endorse species present theories. I'm not one of them, but at least I would say that it's not obvious how they could do that. Of these claims, you can basically reject, I think, two different premises. If you reject premise 2, you say that contents of species present don't play a role in the perceptual processes that bring about temporal phenomenology, temporal experiences, and that means that there's no motivation, at least like the primary motivation to endorse species present theories disappears. So I think they would not want to go that direction. So I think they would go to a direction of challenging the premise 6 and say, well, actually, no. Our experiences are such that there's a small delay. It's just that it's so small delay that we don't notice that. And I think that is possible. That's definitely an option that they could take. But given what we know about temporal resolution of our perceptual processes, I think that is also empirically quite implausible position. There are other options that they can do also. I didn't have time to go there, but my point is that at least like the most obvious responses to this problem don't appear to be, or at least in my view, successful. So what I've been saying, what is my take-home message here is that species-present theories have traditionally been thought to have an upper hand over snapshot views in explaining temporal experience. Their ability to explain temporal experiences is the main motivation for them, for these theories to, like primary motivation for these theories to exist, I would say. Not the only one, but primary motivation. Yet, as I've been arguing, if we consider this in detail, at least two most straightforward analyses of their explanations of these temporal experiences are unsatisfactory. And as a final conclusion, I don't think that the issues that I raise refute species-present theories. Instead, what they do, they put a pressure on those who endorse species-present theories to come up with a kind of better explanation, or finally actually give an explanation how they really think that we come about having temporal experiences. And if they cannot do that, the motivation to endorse these theories is lost. Thank you.
Thank you for this informative talk. And now we have some time for questions.
Hi, thank you for the lecture. Interesting and a very high speed run through. No, it's a common thing here when everybody has been doing their research for years and now they try to explain it in 30 minutes. That's a challenge. But I think that I just want you to give some kind of answer for a few questions that are related and that follow this kind of a basic research, and they are philosophical questions. So what kind of a process links these moments of now in sequence? So in other words, is it probable that there is general perception of time?
Is it probable that there's general perception of time?
Yes. What makes these now moments, so to speak, what links them together? You were talking about now, that it has it's an interval of experience.
Yeah.
Right. So we call it now moment. What makes them these now moments? Do they form a general sense of time or some kind of a linear time, or do we experience time that way, in your opinion? I know it's not straight to your research, but would you like to just speculate a bit?
Right. Thank you for the question. There's no simple answer to that, because what I describe here, like both within snapshot views and the species-present views, there are different ways how these either snapshots or species-presents link to each other, and it really depends on the theory. So some of they follow each other discretely, and the kind of experience of time is kind of secondary properties of those. In James's view, at least in one interpretation of James's view and Barry Denton's view, is that it is kind of moving window. In Husserl, they were separate acts of consciousness, so it really, how these now moments or subjective nows, how they relate to each other, like in a sequence, and form the kind of the stream of consciousness, it varies depending on the theory, and yeah.
If there would be a clear, like I'm just speculating a little bit further, but if there would be, like a clear sequence of experiencing a time, we would know in what sequence we would have done things. Did I do laundry before I met Harry, or these kind of things? So I think that our memory works in a maybe in different way, that there is no clear linear perception of time or history of ourselves.
So sorry, now I didn't follow.
I mean, like if we would sequence the moments of now in the linear form that they were in a tube or in a line, then we could recollect, did we first wash dishes or first met Harry, if they were in line, and we were just going back in our memories. So that would point to the fact that...
Are you kind of this time kind of alluding to Dennett and Ginzburn argument against Cartesian theater model? Because they basically are saying that when we look at the time, like our conscious, like what I call like subject mental time or stream of consciousness, it doesn't form a neat linear time, because within very short time scales, things get messy. And if you're doing that, yep, that's a fair objection. The problem for me with that is that actually all the empirical data that they consider in their paper that is now 30 years old this year, it became 92, all that empirical data is not sound anymore. So the arguments are based on empirical claims which were rejected later on. So, but it is still fair, as an idea, that's fair criticism.
Yes, thank you.
There is still one more question, just shortly.
Hi, thank you. I enjoyed the talk. There seems to be a model that is relevant to the species present that has to do with, I don't know if you know, Buzaki and Lisman temporal coding, that has to do with theta precession. And you actually get a moving, it's like a sliding window that moves with the edges kind of tapering off, just like you would expect. And there's also recent work on this by people that do predictive processing, where you can break it up into a series of predictions for what you're going to do, what you did, but predictions of what you're going to do, what you're going to do after that, what you're going to do after that. And each time the predictions are maybe, they kind of taper off. But you get a certain pretty nice model for a species present, which is not on the knife edge. And I think it works well and describes some of the neurological data.
Yeah, I kind of agree. I have a project on temporality in predictive processing framework, just started this year. And one motivation was that people are making these kind of claims, and I think there is something into it. But the problem is that whether it really actually fits with our experiences or some other levels on the generative models, or which there is plenty, it's not clear. So it could be also like nobody who claims that, well, at least me, who argue against species present theories, I'm not claiming that there wouldn't be temporal windows of integration or predictive processing within certain different levels, but it's not necessarily kind of conscious experiential level. So that's a kind of issue. But I think there is something that could fit, that would be a way of moving this way forward.
But I think Friston refers to it as temporal thickness, and for him it's important for this whole consciousness business. Meaning,
sure, but he also mentioned that within all the levels of the generative model, they operate with different temporal frameworks. And if we think that within visual, in their models within visual system, there is 9 different levels of in generative model. There's a question like, what is the level where what kind of would somehow correspond to species present? And I don't think that actually there is any. I think it's what we experience is kind of mixture of all of those, and then yeah.
Yes, thank you. Maybe you can continue later if needed, but let's thank Valtteri once more.
Thank you, everyone.
Next speaker will be Harald Atmanspacher, who comes from Zürich, and he approaches these mind and matter questions from the perspective of quantum theory and complex systems. And the title today is The Role of Meaning in Dual Aspect Monism.
Well, maybe I got off the glasses. Okay. Oops. It's okay, huh? Yes, and mouse is there. Perfect. Thank you. Thanks very much to the organizers. Can you all hear me in the back rows too? Is that okay? Yes. A little bit more volume, but only a little bit. We have this problem with the time lag, you know, when the volume is too much on, then the loudspeakers produce a time lag. Anyway, so thank you, Pavo. Thank you all the other organizers for inviting me to this wonderful meeting. I think it's a great hour for research on the mind-matter problem. And as we have seen in the last hours and days, this problem has a huge amount of different aspects. And I will just try to talk about one of them. I want to introduce you to a, let's say, conceptual, or you could also say philosophical framework to talk about the relationship between the mental and the physical, which is different from most traditional ways of looking at this problem. And the framework that I'm talking about is called dual aspect monism. I will tell you in more detail what this is, and I will also tell you, will also talk about some versions of dual aspect monism, which very curiously put meaning, something like meaning, into the very fabric of basic reality. So that's something very, very unusual, and I will tell you more about that. The second task I have been ordered to fulfill is setting the stage, to some extent at least, for the next talk by Basil Hiley, because Basil will talk about a specific form of dual aspect monism, which he has, over the last decades, developed with his collaborator, David Bohm. Now, dual aspect monism is a reaction, it's one of several reactions to Descartes' interactive dualism. And dual aspect monism avoids both physicalist and idealist leanings. So it's not a physicalist theory, it's not an idealist theory, and it's also not an interactive dualist theory. The philosophical pioneers were, most of all, Spinoza in his Ethics 1677, and then if you go further on, then you will find very basic ideas of dual aspect monism also in Schelling. Schelling is usually known as an idealist, but this only applies to the first period of his works. Already in the Freedom Essay in 1809, Schelling expresses ideas which are much more dual aspect monist than idealist. One version of dual aspect monism has been mentioned already by Chris the other day. That's neutral monism. It goes back to the triad, if you want, Ernst Mach, William James, Bertrand Russell. I'll tell you a little bit more about that. And the other class of dual aspect monist approaches is inspired by quantum mechanics, by quantum theory in the last century. And we have essentially three versions, or three lineages, I should say. The first one goes back to Wolfgang Pauli, a physicist, and Carl Jung, psychologist. The second one is Arthur Eddington and John Wheeler. And the third one is, as I mentioned before, David Bohm and Basil Hiley. We've just recently published a book on this, on these quantum-inspired versions with Dean Rickles. The title of the book is Dual Aspect Monism and the Deep Structure of Meaning, and that's essentially covering much more and in a much more comprehensive way what I will be able to talk about today in this remaining, I don't know, 25 minutes. Okay. So there are two modes of dual aspect thinking. One of them is compositional. So in dual aspect thinking, we have a psychophysically neutral domain, and these psychophysically neutral elements, which can be pure experiences, that's William James's notion, or Bertrand Russell's notion would be sensory data. Ernst Mach also would talk about sensations. But these are not to be misunderstood as psychological contents. They are psychophysically neutral. They are neither mental nor physical, at least they are conceived this way. And the composition of these elements can either yield mental or physical configurations, so configurations with mental properties or with physical properties. And of course, since it's a compositional model, all these configurations can be reduced to the elements. This is inspired by classical system theory. It's a kind of Lego model, if you want. And the opposite, of course, is the decompositional mode. There we do not have psychophysically neutral elements, but we have one psychophysically neutral whole, one undivided whole. This psychophysically neutral whole is also neither mental nor physical, and now, of course, you cannot compose anything because it is already the whole, but you can decompose it into the mental and the physical, and that's inspired by quantum theory, by quantum holism, which is the metaphor that I will explain to you in more detail. Now, a caveat or a note, dual aspect monism is not panpsychism and it's not cosmopsychism. Why? Because panpsychism and cosmopsychism are theories which do not have anything like a psychophysically neutral domain. So they are just having the mental and the physical, and the idea is just that nature is both mental and physical, either in each part of it, that would be panpsychism, or as a whole, that would be cosmopsychism. Philip Goff, for instance, defends such a kind of approach. So here are the 6 protagonists. You can see upper left, this is Wolfgang Pauli. Then we have below him, we have Carl Jung. Then in the middle, upper middle, who is that? Eddington. In the middle, in the lower middle, that's John Wheeler. And then we have, this is David Bohm, and who is this? Never seen before. Okay, so the picture now is the following. The mental and the physical domain are no longer considered as, and neither of the two is actually considered as something which is the basic stuff of the universe, but they are both only aspects through which, or perspectives from which, the really basic stuff of the universe can be seen, or in which the basic stuff manifests itself. So you see, under the horizontal line, you see this idea of the undivided whole that is neither mental nor physical. And now these 3 different lines in red here, they just indicate the notions, the terminology, which has been used by the people you saw in the last biograph to describe this. So in the picture by Bohm and Hiley, you have the notion of the implicate order, hollow movement. You also have the notion of pre-space-time. So this domain down here is void of space and time. There's no space and time. Time and space only are up here. Then Eddington and Wheeler have this notion of the smoky dragon. Actually is a picture that comes from Niels Bohr already. And it's to express that we actually do not really know. It expresses a kind of frustration that we don't really know what's going on down there in this domain. And of course, this is one of the points that we have to talk about. Pre-geometry is also expressing the idea that space and time are not defined at this level. And in the terminology of Pauli and Jung, we have the archetypes. This is a notion that Jung brought up. And in the limit, the unus mundus would be the undivided whole. There's only one world without any distinctions in it. And I want to show you a short quotation, which is from a letter that Pauli wrote to Markus Fierz in 1948. And that says this one: the ordering and regulating factors, that's the archetypes, must be placed beyond the distinction of physical and psychic mental, as Plato's ideas share the notion of a concept and of a force of nature. They create actions out of themselves. I am very much in favor of referring to the ordering and regulating factors in terms of archetypes. But then it would be inadmissible to define them as contents of the psyche. So the archetypes are not psychological contents. The mentioned inner images, dominant features of the collective unconscious after Jung, are rather psychic manifestations of the archetypes, which, however, would also have to put forth, create, condition anything law-like in the behavior of the corporeal world. The laws of this world would then be the physical manifestations of the archetypes. Each law of nature should then have an inner correspondence and vice versa, even though this is not always directly visible today. So the elements of this psychophysically neutral domain are neither mental nor physical, but they manifest themselves in the mental and in the physical domain. That's the idea here. Now, some key features, just to have a list to which you can refer when you want in the questions. The unus mundus, the one undivided world, is one fundamental psychophysically neutral domain without distinctions such as mental, physical, subject, object, self, world, or what have you. The mental and the physical emerge as dual epistemic aspects due to a partitioning of the holistic psychophysically neutral domain. Archetypal patterns or implicate orders or whatever provide a hierarchy of psychophysically neutral order elements between lowest level, the one world, and once you go into the distinction between mental and physical, the mental and the physical aspects. Now, the big benefit that you get from this picture is that you get psychophysical correlations between the mental and the physical in a very deflationary manner, just for free. Because whenever you break the symmetry of a whole and get parts, then necessarily the parts must be correlated, because the correlation reflects the broken holism of the situation before the symmetry breaking. So that's something that is not provided by any other conceptual framework, in any other conceptual framework trying to describe psychophysical correlations. They have to be put somewhat ad hoc. Here you have a kind of mechanism. Of course, it's not a mechanism in the mechanistic sense. It's a kind of mechanism that really gives you the psychophysical correlations for free. The price to be paid is, we don't know what the psychophysically neutral domain really is. So this is something that we have to really do research on and find out. Now, the next important point is the psychophysical correlations are neither causally substantiated, nor are they simply by chance, but rather by something that is, I mentioned that in the beginning, that all these three lineages of dual aspect thinkers consider to be meaning. So the psychophysical correlations are correlations between the mental and the physical, and of course they would not say that the mental is caused by the physical or the physical is caused by the mental, but the correlation itself is expressed by a meaning that is a relational concept, of course, so that this fits perfectly well. And of course, we have to talk about this more. And meaning is, of course, not to be understood in terms of information, syntactic information. It's really semantics. It's posed as a basic relational ingredient of the fabric of reality. Meaning is already there at the psychophysically neutral, but it's not unfolded yet. That's the idea. So, for instance, in the picture by Bohm and Hiley, this is called active information. This is the idea of the notion of active information. Now, how can we understand a little bit better what's going on here? And here I want to use a kind of metaphor. That's called a pullback metaphor, which has been, I forgot the name of this, it's a mathematician in Stanford who brought that up, this idea. And the pullback metaphor is something which you want to apply if a largely unknown situation is considered in structural analogy to a well-understood situation. And in this case here, we consider particular suitable features of quantum theory as a pullback metaphor for the mind-matter problem. I will show you how that works immediately. And particularly important for the decompositional version of dual aspect monism is quantum entanglement. That's where the notion of holism comes from in this dual aspect monist picture. Now, the first pullback option looks like this. This is the situation in bipartite entanglement. You have here an entangled state, and the entangled state is, of course, not a product state. So the entangled state does not present itself just as the sum of two states. This is just expressed by this inequality sign. Well, when you measure something on this entangled state, then you decompose it into these two separate states, psi1 and psi2. This is the example of a belt state. And of course, between psi1 and psi2, you have correlations that are not to be understood as causally imposed on the system from psi1 to psi2 or from psi2 to psi1. So there's no causal interaction between psi1 and psi2. That's what we call acausal. And of course, these correlations have been studied for 4 decades now. 4 decades now in many experimental situations, and they have been shown without, I would say, any reasonable doubt, and they can be really proven with the usual tools of statistics by violations of Bell inequalities. Now, so this would be the quantum situations, and this also shows you why quantum physicists have been essential in developing this kind of decompositional dual aspect monism. This is the unknown territory to which the pullback metaphor is pulled back. So we have something here, the psychophysically neutral. So we have states in this psychophysically neutral, which are neither mental nor physical. And if you do something on this situation here, on these states, then they decompose into a mental and a physical state. That's what I call the manifestation or the projection or whatever you want. Basil will have other notions for this in the coming talk. And of course, here also the idea is that the correlations are acausal. There's no causal interaction between the mental and the physical, right? But now, since we have a situation in which the physical domain is related to the mental domain, it becomes much more difficult to apply simple statistics. We have two completely different domains. In this situation, everything goes on in physics. Here, the physical is just one pole, and we have to correlate it with the mental. And the radical idea of all the thinkers that I mentioned before, Jung, Pauli, Eddington, Wheeler, Bohm, and Hiley, was that meaning is the currency which substantiates these correlations. Okay. So that's option 1 for the pullback. Here's another option for the pullback, a more complicated one. Now here we have now the mental, the physical, and the psychophysically neutral. And now this is a tripartite system, right? In a tripartite system, we have 2 decomposition classes. Not only the Bell state, we have the decomposition class of the Greenberger-Horn-Zeilinger state. And when you decompose the Greenberger-Horn-Zeilinger state, you get the mental, the physical, and the psychophysical neutral PPN just separated from one another. The second class is the, The second class is the W state. When you trace out one of the different states in a W state, like the physical, then you get the physical separate, but the psychophysically neutral and the mental remain entangled. Analogously, for when you trace out the mental, you would get out the physical and the PPN still entangled. And if you trace out the PPN, the psychophysically neutral, then you still get the mental and the physical entangled. That leads us back to pullback option 1, right? So we have a broader picture now, which we can narrow down to the one that we had before. Now, the correlations, if we now conceive the correlations really as meaning correlations, then we can come up, this is a little bit in the tradition of Frege in his famous paper on sense and reference, 1890. We can consider 2 different types of meaning, one of them as reference and one of them as sense. And I will tell you a little bit more about this. So the row that you see in this picture here, these are triple correlations in the composite system, M and P and PPN. Now we have sigma 1 correlations between the mental and the physical, and these sigma 1 correlations reflect the surface structure of this type of dual aspect monism. These can be conceived in the sense of Brentano's notion of intentionality or reference, and that's what Thomas Metzinger has exploited a lot in his work. Thomas Metzinger really talks about relations between the mental world and the physical world as relations between models, not relations between substances, right? So, and this is a kind of reference relation as it is used in Brentano's definition of intentionality. I should mention that Hans Liljenström today also had this notion of intentionality in a different way, though. This notion of intentionality is intended to refer to representational systems. Hans was talking about non-representational systems, where the notion of intentionality could also be, I mean, Walter Freeman calls it an intention rather than intentionality, just to make a difference. Now, these correlations, sigma 2 and sigma 3, are now the correlations that lead you into the psychophysically neutral. What does that mean? That means that we have a relation that offers us a kind of deep structure of meaning that makes contents of the psychophysically neutral accessible either in the mental world or in the physical world. And that is a kind of interpretation of meaning that goes back to Frege, I mentioned that already, and that has been extensively used by a German philosopher, Markus Gabriel, is now in Bonn, and this is a person with whom we are trying really to develop these things further. Now, these are the deep correlations. Sigma 2 are the deep correlations between the psychophysical neutral and the mental. And this is interesting when you are, for instance, looking into Jung's depth psychology. Then you see that Jung, for instance, in his final major opus, Mysterium Conjunctionis, he talks about a kind of unio mentalis, a first stage conjunctio, which connects the conscious mental images with their archetypal unconscious origin. So that would be really something that belongs to this domain, sigma 2, which expresses correlations between the psychophysically neutral, the archetypal patterns, if you want, and the mental. Now you can also consider the psychophysically neutral in a completely different way, like, for instance, Roger Penrose does. Roger Penrose is a mathematical Platonist, so he would say the mathematical structures that he discovers are elements of some psychophysically neutral domain. They are neither mental nor physical, of course. You can apply them in both, but they are not elements of those. So the connection between the psychophysically neutral and the physical, that would be something that expresses Pauli's insistence in the quote that I showed you before, that the laws of the physical world are physical manifestations of archetypes, and the archetypes would be the mathematical structures in this sense. And probably many of you know this famous paper by Eugene Wigner on the unreasonable effectiveness of mathematics in the natural sciences. Of course, when you take the sigma 3 correlations seriously and interpret them in the sense of Pauli in this quote, then the effectiveness of mathematics in the natural sciences is not unreasonable, but it's highly plausible. It's actually, it should be a consequence of these correlations. Okay, so 5 more minutes. Now I want to really briefly tell you something about the surface correlation sigma 1. I was talking about sigma 2 and sigma 3 in the last slide. Sigma 1, the surface correlations come in 2 different versions. They come as structural and persistent and stable psychophysical correlations, and they come in a second form as induced and occasional and evasive correlations. The structural correlations are robustly reproducible like psychosomatic correlations or neural correlates of consciousness. The induced correlations are evasive, they are not reproducible, they come in terms of something that psychologists often call exceptional experiences, like out-of-body experiences or sleep paralysis. This just happens spontaneously. You cannot put a person in a lab and say, please, sleep paralysis. It doesn't work. So the structural correlations, because they are robust and reproducible, can be considered to form a baseline from which induced psychophysical correlations deviate. And then you can have positive and negative deviations. So you can have more correlations than there are usually. This would be experiences of coincidence, like Jung's synchronicities or something like that. Or you can have deficit correlations where existing or normally existing correlations are just cut off. These would be examples would be out-of-body experiences where the correlation of mindness is missing. And both these deviations are experienced as meaningful because they deviate from the baseline. I mean, you don't experience an increasing heart rate because of stress as particularly meaningful. We are all used to that. But if the experiences deviate from the baseline, then they are experienced as meaningful. And Jung had this notion of numinous experiences for those experiences that have an extreme deviation, life-changing experiences with transformative power or something like that. And of course, in the ordinary case of the baseline, there is no deviation at all. Now, what I cannot do today is go into all the details of how we can empirically show that this taxonomy, which follows from what I just said, can be empirically supported. There's a lot of material that we have collected over the last more than 25 years. Different places at the Institute for Frontier Areas in Freiburg. Another study was done at the Psychiatric University Clinic in Zürich. Then there was one study or two studies in the University of Gießen. There's one study in the University of Western Georgia. And more recently, also Tanja Luhrmann at Stanford has become interested in this kind of research. And she studied this kind of taxonomy even in non-Western civilizations, non-Western cultures. Several ones in Africa and in the Far East. And all the material that has been collected so far, more than 3,000 cases, 3,000, it's not just 300 or 30, all fit this kind of taxonomy perfectly well. But as I said, I cannot go into that in detail here. You might have a look into the book that we published. There it's all described. Okay. This is the material. Here you see a contour plot which shows you a collection, a summarizing collection of all the empirical material. But I will not go into detail because I'm just close before the end. Summarizing, dual aspect monism considers the mental and the physical as dual aspects of an underlying psychophysically neutral whole, PPN. So the dual aspects would, in my view, be a very pragmatic move, but introducing the psychophysically neutral level as a fundamental level is, of course, extremely non-pragmatic because we don't actually know what's going on there. Meaning plays an essential role in the fabric of reality as sense. That's the deep structure involving the psychophysically neutral. You remember sigma 2 and sigma 3. And second, as reference, that's the surface structure which relates the mental and the physical. So mental representations represent something in the physical world. And the relation between them, that would be just the experience. So the experience that we are studying are fundamentally relational. You cannot project them into the mental or into the physical without losing the essence of them. They are strictly relational. We have two types of these mental-physical correlations. The persistent ones, which provide a baseline for the correlations, and the induced ones, evasive ones, which are located above and below the baseline. this leads us to a systematic taxonomy of psychophysical correlations, which has been empirically supported by what I mentioned to you before, phenomenological studies of exceptional experiences. And what I don't say here, but what I should add is that the notions, the terms that in the lineages that I mentioned before, which express the importance of meaning in this whole picture, are active information in the Bohm and Hiley approach, the meaning circuit in the Eddington-Wheeler approach, and synchronistic events in the Pauli and Jung approach. And as I said several times before, this is a nice quote, as you can see. This book, The Dual Aspect Monism and the Deep Structure of Meaning, that just came out a few weeks ago. That contains a lot of material, much more detailed material about what I just presented to you in a very rough overview. Thank you very much.
Thank you very much for this inspiring perspective. And we just take one short question. Unfortunately, no more time. Yes, please.
Thank you.
I'd like to ask about the precise difference between the physical world and the neutral world. Given that the physical world is topic neutral, it's defined just by its structure and dynamics, and the neutral world's also topic neutral, I assume. You mentioned that the neutral world doesn't have time and space.
For instance.
What other difference is there? And isn't the neutral world just a non-local extension of the familiar physical world?
Some people would say this is the way to go, but of course when you dig deep into it, into the psychophysically neutral, you also lose our usual types of logic, right? The logic will be very non-Boolean at some point. And of course, the non-physical, the psychophysically neutral is non-physical and non-mental in the sense that the physical world is not considered as a basic element of reality anymore. It's a model. I mean, all what we know about the physical world is, how can I say that without being too sarcastic? The physical world is not something that's out there anymore. It's a set of models. It's a world model. If Thomas Metzinger calls it a world model, and not the world itself.
But isn't the neutral world also just a model?
What?
Isn't the neutral world also just a model?
No, it's considered as the real world, the real reality. I mean, Philip K. Dick says, reality is that which doesn't go away, even if you don't believe in it. And the psychophysically neutral would be the real world in Philip Dick's notation. Of course, this is a writer, it's not a scientist, right? But just to give you a metaphor.
Okay,
That was it?
Thank you for this very much.
Put it on.
And our next speaker will be Basil Hiley, who comes from, who is a quantum physicist coming from the University College London, and he used to collaborate with David Bohm for a long time, and since after his death has continued this work, and now is going to speak on the title, on the notion of active information, an algebraic approach to quantum theory.
Yes, and thank you very much for introducing me. Thank you, Pavel, yet again, for inviting me here to do the work for you. And thank you, Harald, for that introduction. I have to live up to that now. Okay. First of all, you'll notice, I apologize to the chair lady, I've altered the order of my title. The reason being that I was originally going to talk a lot about active information, I got here, decided I'd change my mind and talk about the algebraic approach to quantum theory because it gives the background to some of the details that you were talking about, which fit in beautifully into the way you were structuring the set of ideas. So I'm going to be very technical. I apologize. No, I don't apologize for that because I think it's essential that we learn these new techniques. And rather interestingly, on my mobile this morning, I got a text which says, how to teach quaternions to the lay audience. Okay. It's a mathematical technique which robotic engineers use. So it's very up to date. So let me try and explain how I get to that position. Why won't this work? Oh, yes, it will. And the reason why I changed the order of it is because last summer I discovered this particular paper by Bryce DeWitt. And Bryce DeWitt is a very, very good cosmologist. I think, can I call him a cosmologist? I think he was more interested in cosmology than he was in quantum mechanics, although he did a lot of work in quantum mechanics as well. And the significance of it is, let me bring it to your notice, Physical Review, Volume 65, number 4. Bohm's hidden variable paper, which started the alternative description, interpretation of quantum mechanics, is Physrev 85, but volume 2. There are just 2 volumes between them. And I have never seen this paper, I've never read this paper, never seen the paper, never read the paper. For all the time I worked with David Bohm, was getting on for 30 years, this paper was never mentioned, and I don't understand why. Because it's actually a very, very good paper. And it introduces the idea of the quantum potential. The history behind that is that when I talk about the quantum potential to physicists, they think I've come from Mars or something. Even the Bohmian people who call themselves Bohmian mechanics have actually classified it as Hiley's nonsense. And I think very unfairly, I don't know what the problem is. I don't know. An undergraduate who knows a little bit of mathematics could get an expression for it and show that it appears in the equations, and yet it's denied to be there. Okay, so that's enough background. So what is DeWitt doing? First of all, he's noticing an isomorphism between classical physics and quantum physics for certain types of classical physics. So classical physics and quantum physics are not that different at this level. They become different, but we've made into such a mysterious subject that we think there are 2 worlds, classical world, quantum world. No, it's only one world. And the reason why this paper is important is because what he says was that if you want to take the Hamiltonian, remember the Hamiltonian is the total energy of the system, if you want to make it covariant, relativistic covariant, or independent of the coordinate systems, you've got to add something to it. And you've got to add, does this work? You've got to add that h bar q over there. Normally you don't put that h bar q in. So, and that, notice he actually introduces it as the quantum potential energy in the paper. Okay, and then he says here the quantity h bar squared q may be regarded as a kind of quantum mechanical potential which goes to 0 as h bar goes to 0. Don't put h bar equal to 0. Everything blows up. And it is a quantity which must be added. Okay? Now, first of all, Heisenberg saw the Bohm theory. He saw the quantum potential, said it was ad hoc, and made criticisms like, what they are trying to prove is 2 + 2 = 5. Richard Feynman even sees the quantum potential in his lecture notes to students who we all use, the third volume. He's got it there and said, this is a mysterious quantity, and then nothing. So there's been nothing on this since, on this side of things, on the, Bryce DeWitt never mentions the quantum potential again. Extraordinary. Anyway, but the reason why I'm stressing this is because if we want to take active information seriously, the active information idea came from this potential, seeing what it did in the various situations in quantum mechanics. And then David and I had many discussions about it. I didn't like the idea of information, but he says, no, Basil, it's putting in active information in the sense that it's forming from within. It's not a list of timetables that you go and see, but even the information on the timetable, you take it and it changes your particular way of evolving in time. But then what this paper shows, look, it shows that you actually find that when you go through all the details, I'd love to go through all the details, but that'll really scare the pants off you. It's due to the scalar curvature. Curvature of what? Curvature of space-time. Because in general relativity, curvature of space-time is the way we discuss the gravitational force. And notice the historical note here, which for Bob Callaghan, one of my colleagues, found it in this book by Schulman. Feynman, Schwinger, and Wheeler, he thinks, this is not properly researched, but certainly 2 or 3 of those people discussed it, tried to measure the curvature, and decided it was too small, so they abandoned it. And that was the end of the subject. And one of the things we're trying to do, that if you believe it, then we're trying to measure it in the laboratory. So my emphasis is always at the moment, Harald, is on the physics, because I've been tied up with physicists on Zoom for the last 2.5, 3 years. So I've now become a physicist, unfortunately. Although I don't know whether physicists would actually like to say that's what I am. Okay, but then bring it up to date. 2013, we're almost up to date. And I find this paper by Michael Berry. And in it, he's talking about optics, and he's talking about classical waves. Is Ron here anywhere? Yeah. Oh, you're there, thank you. And you raised the question of what's quantum and what's classical, I think. Well, in fact, you're quite right. You can get the quantum potential in a classical wave. It's a property of the wave. In this sense, it's neutral. Okay, so the word quantum should not be put on there, I think, but I don't know what to call it. So a suggestion of what we should call the potential would be very welcome. But look, we've got the trajectories. I think Paavo fortunately put the slide of the Chris's that had the trajectories for the 2 slick experiments, so I don't have to introduce that. This is Berry's attempt, which looks like a drawing, and there's no mention of our paper in, which is extraordinary, never mind. And then what we find is that if you solve this equation, you find that these curves, sorry, you can't see what I'm pointing to, those curves, where the thing starts curving, you get the quantum potential appearing. So somehow, if you were sitting on this atom, because I play with atoms, not with photons. When I say I play with atoms, the students in the lab play with atoms and I watch them. And if you were sitting on the atom and then you had to deviate, you're accelerating, you're going to feel something. And that curvature essentially is that experience of going around a corner. Now, this is classical physics so far. But our calculations with a Schrödinger equation. So Schrödinger's equation was saying exactly the same thing mathematically as this optical system. Okay. So what is the problem? Well, the problem is, you see, we're seeing these individual flow lines. Let's just call them, be neutral and call them flow lines, energy flow lines of some sort. Are they particles or not? Most people say, oh, Bohn's wrong because you can't do that. Particles, uncertainty principle, we violate it, etc., etc. Suspend that argument. Really what it is the difference between the individual and the collective. And how do you discuss the individual and the collective? In the physical situation, we talk about the individual and the ensemble. The individual particle goes through the two slits and arrives at the screen. The ensemble of them gives us the interference pattern. How does the individual know about the ensemble? In classical physics, the individual and the ensemble are one and the same things. But in quantum physics, the individual is contingent, or appears to be contingent, on the collective. So how are we to understand that? Mathematically, the question, and here I'm sorry for the people who are not mathematicians, but this is the way we talk about it. You've got a two form, which is your metric. This is your general relativity idea. You've got a general metric here, which is going to stand for the energy. And it's got two terms in it, and those two terms, that's why it's a two form, because there's two D's in there, d mu, du mu, d mu nu. But you make the two form out of a one form. And the one form is where you talk about the individual, the momentum, the energy, and so on. In the two form, you're really talking about invariance principles, conservation laws. So we've got symmetry going in, and we've got two symmetries. The SO2 is just a rotational symmetry. It's everything you experience by rotating. The symplectic symmetry is everything you experience when you get in a car and drive. So they're all classical ideas. Now then, what you find is that if you have to introduce the quantum potential, where you're looking at the collective, it's the collective which is determining the individual behavior, but it's doing it in a hidden way. It's not doing it by pushing and pulling as we normally think about causality, as an efficient causality. And this is where we introduced the idea. I went back and had a look at Aristotle, and he had something like the formal cause. Well, we changed it into the formative cause. That is, there's the information about the invariance is fed into the system in a way which is what you were saying, Harald. It's the wholeness comes first, and then the individual responds to that whole, but not in a way which has forces between the particles. It's something much more subtle going on. Okay, now, this is the reason why the overarching mathematical structure of quantum mechanics is about non-commuting phase space. Phase space is ruled out by the uncertainty principle. Phase space is a space where you represent both the position and the momentum in one go. You can't do that in quantum mechanics. But the algebra is well defined. And that's why I've been trying to concentrate on looking at what is the algebra trying to tell us. Okay, now then, a little bit of background. I was doing some research to try and, because I had so much time on my hands being locked up in this wretched Zoom era we were just coming out of. I went back and had a look at a paper by von Neumann. It's one of the things I don't like, I think we can do without, is the wave function. Now you see wave function coming in when I'm doing this, so I've got to be very careful because otherwise I'll have an egg on my face. But I'm just using that to illustrate how if you come the other way, the wave function becomes a particular of a more general structure. So there's an ambiguity. You see, we all think, oh, the stone von Neumann, it tells us that the Schrödinger picture, that's when we use the wave function, found in all elementary textbooks. That is unique, but what they forget is it's unique up to a unitary representation or a unitary transformation. So there's an ambiguity there which they've they don't exploit. Oh, it is exploited, but beg your pardon. You've got the Heisenberg picture. The Heisenberg picture is where you consider only the energy. But what I've done with a colleague of mine, Glenn Dennis, is suggested that we have a Dirac bone picture. So the bone theory comes directly from quantum mechanics. It's not about another interpretation. The mathematical structure is quantum mechanics, but it's just done in a different way. I don't know how many people realize this, but in this Bible of physicists, Dirac actually starts the bone theory going. He gets the conservation of probability because he goes for order H bar. With H bar, you don't see the quantum potential. And then what he says is, but if you do put the H bar in, and that's when this Q, this quantum potential appears, you will violate the uncertainty principle, and therefore I'm not going to go any further with it. Bohm, I think, saw that paper, although he never admitted. Unfortunately, I didn't discover this paper till last year, and I'm afraid Dave was gone long before that. Okay. And that's why we've called it the Dirac-Bohm picture, because Dirac was going in that direction. In that book, 47 and beyond, and the latest one as well, but not in the earlier versions. But this is all relativistic, so, non-relativistic, I beg your pardon. But then the other side, you see, in physics, we've got these two. We've got the quantum physicist, and we've got the relativity, the general relativity. And they don't seem to cross over at this level. And I was reading Weil's book, and he published it in 1909. And he had this idea of gauges already there, because there was an ambiguity in relativity. And the ambiguity is that the gauge is not fixed. In relativity, there's no such thing as rigidity. So you can't take your rod to Paris and say, this is the standard that we're going to use, because there's no rigidity in relativity. Therefore, you've got to bring in a gauge. We can't all use different gauges, although we did successfully with railways, of course. And that's what caused a trouble tunnel under the English, because we had one gauge. The French had an entirely different gauge. So we've got to agree on the gauge, otherwise we won't get the invariance correctly. But if you combine the unitary equivalence with the gauge transformation, with the gauge invariance, you can make everything invariant. I want to show you in a slightly different way. I'm probably going too long, aren't I? Am I all right? Time-wise, Pavel? Keep an eye on me, because I'm wandering. Okay, so here is the change. The unitary transformation is, does this work? No, oh, there it is. Can you see it? So the unitary transformation is multiply the wave function by that. Now there's the wave function. If you multiply it by that, all you get is just the R. And then you use the transformation. It's all standard mathematics. It's all standard mathematics. And then what you find is, when you put it all in the equation, separate real and imaginary, and you get these two equations. This is the conservation of probability and the conservation of energy with the quantum potential there. Okay, so this is the ad hoc thing that Schrödinger was talking about. Where am I? Sorry, I'm a learner driver. Why won't it go back? Okay, there we are. Right. All right, now then, so the next thing I did was to say, all right, let's see how here are the two things. Sorry, they didn't come up when I pressed them. Let's go back to the way Heisenberg actually did it. Remember how Heisenberg said it was a load of foo-foo? So I took his Lagrangian that is in his book on Foundations of Quantum Mechanics, or some such name, or it's there, Physical Principles of Quantum Mechanics. Used the standard technique, Lagrange techniques, got the two Schrödinger equations, Then I said, oh, well, what? Oh, very naive, just let me put R equal to R e to the is in there and see what happens. Well, I get a Lagrangian, work out the Lagrange equations, and what do I get? The two Bohm equations. So what's ad hoc? I don't understand what is ad hoc. And then I went on and had a look at the energy, and what I found was something very interesting. Don't worry about the details, please. And that is that there's a new type of momentum seem to be coming in here. There's the standard momentum, which is taken as grad S, and then there's this amplitude, Ed Nelson called it the osmotic momentum. And when I was looking at the weak values ideas that Aronoff and Crowd were looking at, I found that it is a weak value. It's one of the weak values that you can find in that story. And therefore, the conclusion that I've come to is the Dirac-Bohm picture actually relates wave, and I've got the wave in scare quotes now, features to the kinematics. So there's a one-to-one correspondence. But if you do that, you've got to bring in this other momentum. The amplitude of the wave function becomes an active, dynamical part of the story. And these are the two pictures that Paavo put up. And now I just want to say one thing. If this is the individual, how dare I draw a line? Because what about the uncertainty principle? Well, what you find is that even in classical physics, there is a trace, a footprint of the uncertainty principle already there. And this is this Gromov no-squeezing theorem, which is not known to physicists. Harald is saying, I knew it. So anyway, the point is it's very rare. If most people just look at you as if you've got off the wrong train or something. And what it says is that, this is classical physics, not quantum physics, that if you prepare your system such that there's the two particles, position one, and take the square of its position, the square of its momentum, the other particle, square, and put it equal to 1, just so you can do that empirically. Then you try to put this little disk through into a cylinder. Symplectic egg is what Morris called it. It won't go. Because it's been stopped by, and this is classical physics. Now, everybody's taught that if I use this is the clever stuff, if I use a general diffeomorphism, I can do it. But if I'm relying on the dynamics, i.e. using Hamilton's equations of motion, a symplectomorphism, you can't do it. So, and this is classical physics. So there's already something fishy in classical physics. Oh, and then a good example of this actually is that when you solve the Bohm's equations for the ground state of the hydrogen atom, you find, because it's real, the Bohm momentum of it, whatever that is 0. And so you get the impression it's not moving. And Einstein objected to that violently, saying, no, it's got to be moving. But it's got to be moving without angular momentum, you realize. And if it's going around the nucleus, what's happened to the angular momentum? Well, you find all the energy is actually stored in the quantum potential energy. Okay, and then look at this. This is some beautiful work. And the complex number that Penrose really loves, I love the quaternions, and I'll show you in a minute. Complex number. This shows you, here's one set of momenta, and there's the other set of momenta. So they're sort of squeezing it so that it makes the particles move on top of those trajectories. The trajectories on top of the potential. It all fits very nicely, and this is marvelous. Same guy, it's Blioch, it's Constantin Blioch. I hope I'm pronouncing his name correctly. These are little little motes, think of them as just little particles, and he's floating them on a electromagnetic wave. So the electromagnetic wave coming up here, the particles floating on it, but the electromagnetic wave has got spin 1, and it's up, it's right-handed. So, and what you see is that the wave actually takes the particle around. So as soon as you've got something going around, you've got a Coriolis effect coming in, and if you draw the two momenta, they look like that. Coriolis force, but that's the Kitty's force, isn't it? And in fact, if you now go through the equations, you find that the equation of motion, which was done by Weil's analysis, 1909, it has the two distinct momenta present in it and the two distinct energies in it. And then to make sure that what you're doing is a Coriolis force, there's an exercise you can go through which tells you that ties up very nicely. And this is where I started my physics, by the way, with Miss crawling along on a turntable trying to measure rods. Okay. But something was missing from the Bohm approach, because there's no we couldn't see, in working out the current, we couldn't see how the amplitude came into it. And did you know it was Einstein who suggested that you should add to the linear momentum the angular momentum term? He had a paper on hidden variables in, well, way back. I haven't got it on there. Yes, I have. Oh no, it's a translation. No, that's a wrong reference. Anyway, so what we're looking at is this combination, translations and rotations. And so whenever we see a rotation or an acceleration, what have you, a quantum potential emerges. Okay, whatever. Oh, and I got this. No, we won't worry about this. We won't worry about this. So, if we've got linear momentum and we've got angular momentum, what about spin? So I'm looking for Pauli spin matrices somewhere. And then what you do is you just read what Dirac says. He says you take your quadratic form, which is full of squares, and linearize it. And the linearization is what I was calling one forms earlier on. So you see the content of the one form in the two forms. And then what you do is just by simple factorization. And then you put them back together again, but you now do them by writing them in terms of a matrix. And here's the matrix. And that you can, for those people who know what the Pauli spin matrices are, you can see the matrices there. This is the Pauli, that's the 1. Look at those two with the 3 is just 1 minus 1. Then you have the X is 1, 1, all the rest are noughts. And this is the wrong way round. And that's not a misprint. Usually it is a misprint, but in this case it's not a misprint because you actually, there are a pair of Pauli matrices there. That's technical, don't worry about that. And what you have is when you linearize, you're actually getting the quaternions, which was my earlier remark about the quaternions. And I've been sat in front of very eminent people saying, you know, I had an argument with Penrose. You can't do quantum mechanics with quaternions. You must have the complex numbers. No, I want 3 complex numbers, just to make life more interesting. And the multiplication table is non-commutative. Everything is non-commutative. And the quaternion is a specific example of a generalized idea of Clifford algebras. And Clifford discovered this in 1883, before quantum mechanics. But so I say, please, I was absolutely staggered to find that the robot engineers know more about it than I do. And that, if you know the Big Bang Theory, that's an insult. Okay, so let's have a look at the structure of the quaternions. Well, what happens is you've actually got two parts to it. You can either write it as a scalar and a free vector, or you can write it as two complex vectors. And the two complex vectors idea is Ernst Bins. He's the man who brought that point out to me. And if you just look at them, then you find that the Einstein suggestion of bringing the linear and the, here's a better one, the linear velocity, these should have dots on them. Oh, that is a mistake. No, that's all right. This is the linear velocity. That's the rotational velocity. That's the linear acceleration. That's the angular acceleration. That's the Coriolis term. And it's the Coriolis term which is the, gives rise to this quantum potential energy. So it's really kiddie stuff. You know, you take a child to the play park and there's a roundabout there. And it goes running on as if it's not going to experience any forces at all. Don't, hold on. And they don't. And they soon experience this. Okay, so this is the individual. I'm talking about the individual here. And you might be saying, well, what's this got to do with quantum mechanics? Well, let's see if what has it got to do. Oh, wait. Why does this not work every so often? Is it working? Oh, it did change. Oh, I think I bought, yeah, sorry, I didn't see. It's bought in that, it bought in this one, didn't it? This is a little sketch. Administrators want us always to communicate by Zoom. That little sketch was done waiting in a lobby with Ernst in Gothenburg. And because the bus was late, he gave me a little lecture on how you interpret these quaternions. And here you've got a light sphere. Think of the point in the middle there is where the light source is. The light comes out, so that's got somewhere along there. And then you look at the tangent plane, and that's where the electromagnetic field is, in the tangent plane. So it's very close to electromagnetism in this description. And you can describe electromagnetism in terms of the quaternions. Okay, now the reason why I want to do that, what am I doing this? Oh, yes. Now I was saying a bit about the ambiguity. This is technical, so just get the idea, not worry about the details. There's a bit of an ambiguity because when you're doing differential geometry, your ordinary partial differential is not a tensor, therefore that's a technical term, but it's not invariant. It depends upon the choice of your coordinate system. An invariant feature is this nabla, as we call it, and that has an ambiguity in it in the sense that, oh, let's go back. Oh, I've given the game away. That has an ambiguity in it in the sense that, no, I won't go back. Yeah, I'm back there now, yeah. It has an ambiguity in it in the sense that there is that extra term there, which I said, this is the source of the DeWitt extra term. And then what you find is you can actually translate that extra term into a gauge change and the metric again. And Penrose's twistors come out of this. Okay, you can see how the quantum mechanics comes in here very easily because if you want to, if the gauge it's changed, you've got to have some compensating field to get it invariant, and the compensating field is provided by the wave function in this case. And the particular way of doing it is by putting gauge principal to -1. The omega to -1 is the gauge change. And then if you go through the various, what you find is that the amplitude turns out to be this gauge factor. And then if you work through all the details, you find, in fact, the quantum potential is now equal to the scalar curvature. So this is another way of proving the DeWitt idea that the scalar curvature, so you're actually, the energy is coming from when, if you're sitting on an atom, it's coming from the acceleration, from the kiddies effect. And then that means that the Klein-Gordon equation, so this is where you see the wave functions coming in, 0 rest mass must be written like that, and that's the DeWitt. Okay, so there must be a, and that's all without quantum mechanics. Okay, now then, let me see, I've forgotten what I'm going to say next. Oh, yes. Oh, can I have a few more? Do you want your coffee? I mean, I'll stop now if you like, but this is the main point. Yeah? Okay, thank you, Pavel. I know you'll turn me out in the street if I... Oh, okay. So the idea is this, and this is the last page of Dirac's 4th volume of his Principles of Quantum Mechanics. I wonder how many people have read it. He says that because the analysis he's done gets him into a mess, he then says, no, what we should do is we should represent the state by a linear operator and not by the ket, not by the wave function. And then Einstein says, perhaps if the success of Heisenberg's methods, that's the matrix mechanics we should use. Yeah, an algebraic approach. Okay, but what one finds is that all the information in the wave function is already in the algebra without actually bringing it in. And Dirac had that by introducing this idea of the standard ket. If you introduce the standard ket, it gives you the idempotents which enable you to replace the wave function by elements of the minimal left ideal. So all the structure that's in the wave function is already in the algebra. You don't have to represent it in a Hilbert space. You can if you want to. Now, why is that important? Well, that's important because if you go to the Pauli equation, that's the equation, non-relativistic Dirac equation, I'm calling it the Pauli equation, you actually find that the wave function is just the quaternion. And the coefficients on that quaternion can be translated into the components of the wave function, should you want to. Okay, so this shows you that already in that structure there is this geometry lying around to be exploited. And then if you exploit the Bint's idea of splitting the quaternion into 2 by 2, that is CA, which is a complex plane, FA is another complex plane, then you get a beautiful structural approach to the Dirac equation even. And now what you find is, oh, and this is called conformal rescaling because I've changed the metric. And then go through all of this and you can see, because people, I've nearly finished, Pavel. People said, oh, the Bohm theory can't do relativistic quantum. You can't do Dirac equation. He did he already has done the Pauli equation. Oh, and he did apparently promise someone, whoever got the quantum potential in the Dirac model, he'd buy them a crate of champagne. Unfortunately, when I obtained this result with the help of Bob Callaghan, there it is, he'd gone. So I'm afraid I never got my crate of champagne. But here are the quantum potential expressions, should you want to look at them. They're there. So the quantum potential is there in the Schrödinger, it's in the Pauli, it's in the Dirac. It's also in the conformal Clifford, because all of this depends upon Clifford algebras. Now, thank you for listening, but I can show you now some pretty pictures. Is that all right, Pavel? Picture show. Picture show. I've been joined by Peter Van Reeth, who, unlike me, he is very good at computer. I wouldn't know what to do with a computer apart from switching it on and switching it off, because I'm of that generation. This is a Stern-Gerlach magnet. The spin is coming in. Oh, you can't see. The spin is coming in like this, right? And then you turn it, and this is called measuring the spin. Is it up or is it down? But look, it's slowly developing. It doesn't jump. Schrödinger was right. I was going to make a crack about basketball. That's what I call it, but I'm not going to. White people can't jump. It does. The spin doesn't jump into the other direction. It slowly moves. So you put another Stern-Gerlach magnet to try and bring it back down together again. And look what happens. Look what happens. And this is simulation, by the way. Sorry, this is simulation. You see what happens is the magnetic field finishes here. And yet, look, there's still dynamics going on there. But obviously, they've got it wrong. But that's just using these equations. We're not... Yeah. And the point being that there is a quantum potential out here. So there's this, as it were, hidden energy of some kind, because people won't recognize it as being, I was going to say real, but then I was just going to wonder if somebody's going to jump on me. And then if you, I don't know, doesn't this blooming thing work on it? Or is it, no, I'm not going to do that. I'm just going to do that. And there's the quantum potential, that incredibly shaped thing. Okay, thank you very much. I'm not going to summarize. I just thought I'd leave you with what we've actually achieved in our laboratory. We've actually constructed the interference fringes with argon. And that's a live picture taken in a laboratory showing you over how, as you put more and more in, the interference builds up to produce the fringes. Just to show you that it is real and not a load of nonsense. Okay, thank you. Sorry I've been over time.
Yes, thank you. Thank you very much for this detailed presentation. What I guess, do we have time for any questions?
No questions.
No questions.
Let's go and have a cup of coffee.
Time for coffee.
Let's go and have a cup of coffee, please.
And we can have a bit of a, so let's come back something like around 25 past. And we'll
Okay, let's continue again. We are 10 minutes, a bit like 10 minutes late, so let's try to keep the schedule to move forward. So our next speaker is Mirja Hartimo, newly appointed university lecturer in Helsinki. She's been working on philosophy of mathematics, language, and Husserl a lot, and today she will talk about phenomenological point of view.
Well, thank you very much, and thank you for the organizers for the invitation. It's a lovely event and lovely to be speaking here. As some people said before their presentations, they had no idea what kind of audience to expect, because there's so great a variety of people and backgrounds. For that reason, I decided to give a bit of a general talk, hoping that there is something interesting for everyone. And it's also a scholarly talk, so that at least you will learn something about Husserl. This talk is about phenomenology as founded by Edmund Husserl. The most important thing that I want to explain to you is that phenomenology is not a normative theory of anything, of experiences or anything. It does not give you a theory or framework or any views which should conform to the experiences, but it's a method with which to examine experiences. It's a method to examine different kinds of conscious experiences as well as their objects. These are sometimes called worlds. For example, it examines the world of mathematics, world of physics, and so forth. So it's primarily a method rather than a theory, and it combines natural attitude and a transcendental phenomenological attitude. And I'm going to be explaining these in more detail very shortly. Now, there's several ways into transcendental phenomenology. From natural attitude to transcendental phenomenological attitude. You may be aware of one famous way to it. It's the phenomenological reduction. That's called Cartesian way to transcendental phenomenology. That is not the way that I'm going to follow here. But I'm going to here follow the way from exact sciences to transcendental phenomenology, which is what Husserl himself used in his later works. So this method here aims to phenomenologically clarify scientific enterprises. And here the context is important. Notice that Husserl died in 1938, so he's talking about sciences before then, mainly in the 20s. So my aim is to talk about his approach in his mature view, mainly in 1929 in Formale und Transzendentale Logik. And that, as opposed to the earlier views that you may be well aware, this period includes an account of how the historical and social factors determine our experiences. So there's a focus on scientific practices and them as they are determined by certain goals and different kinds of epistemic values. Now, the really important concept here is the concept of natural attitude. So it's the straightforward, naive attitude in which we all are when before we do engage in any kind of philosophical reflection. So you all there are right now in a natural attitude. But if you start to think about how what I say is somehow meaningful and constituted in your minds, then you start to do phenomenology or philosophical reflection. Now, natural attitude includes all kinds of sub-attitudes. For example, personalistic attitude, natural scientific attitude, life scientific attitude, practical attitude, and so forth. And basically, you can distinguish them as many as you want. So, for example, in mathematics, you can distinguish between algebraic attitude, topological attitude, arithmetical attitude, and so forth. So, so here's about personalistic attitude. Husserl's explanation about it is that it's the attitude in which we are always, when we live with one another, talk to one another, or are related to one another in love or aversion, in disposition and action, in discourse and discussion. Likewise, we are in this attitude when we consider the things surrounding us precisely as our surroundings and not as objective nature, the way it is for natural sciences. So, natural scientific attitude, on the other hand, is one which constitutes its object as something objective. So here is the way physics constitutes the thing itself as a continuously or discretely filled space in states of motion, states which are called energy forms. That which fills space lends itself to certain groups of differential equations and corresponds to certain fundamental laws of physics. But there are no sense qualities here. So the idea of a natural scientific attitude is precisely to look at things so that you do not, you strip the sense qualities and everything that is in any way subjective away from it. Now, Husserl talks about switching between different attitudes. Usually, the kind of attitude you have to the object is determined by the domain of study. But sometimes you can sort of choose, and then it's a kind of as if a gestalt switch. For example, animals can be looked at as living organisms, and after a change of attitude as physico-chemical objects. And then what you do is that you just focus on one specific part or aspect of these living organisms. And so we are all the time talking about different kinds of natural attitudes. And these scientific attitudes, just to make sure, they are species of critical theoretical attitude where the attempt is to figure out how things truly are. This attempt is governed by epistemic norms of truth and coherence, and also with a spirit of critical self-justification. So it's not just that like everyday attempt to figure out whether it's raining or whether not, but it's, there's more involved in it. It's critical, and it's requires expertise on the part of the scientists, and the repeatability and some sort of permanence of the results. And and ultimately kind of critical social objectivity. So all these critical theoretical attitudes are something where that take place in a community of scientific investigators who criticize each other. There's a peer review at place. So Husserl's approach in that sense is involves this social criticism. So this is all natural attitude. Now, in order to move into transcendental attitude, what happens is, or what Husserl does, is that he, so to say, turns to the givenness, or how these attitudes are given to the subject. And this means examination of the different kinds of presuppositions and kinds of self-evidence that are at place in these different kinds of attitudes. So for example, previously, when looking at how different attitudes constitute their object of study, that is spelled out in transcendental clarification, and then how these different objects seen in different attitudes, how they relate to each other, that is one of the main tasks to figure out in transcendental phenomenology. Then the focus is on the constitutive activity of the scientist's judgments to clarify and fix the goals and kinds of evidence related to these. And the aim is to identify all kinds of possible internal shiftings of intentionalities, so kinds of confusions where you have started to do things in a certain way, but then unknowingly, in a way, get confused and do something else. And also correcting verbal equivocations in judgments. Husserl's original motivation here seems to have been the discussion of paradoxes in the foundations of mathematics around the turn of the century or after. So also the idea is to check that the concepts and principles are used in their proper sphere of application, so that you don't use the kinds of methods in the fields where you should really not use them. There are many examples of this, but for Husserl, perhaps the clearest case is using methods of natural sciences to issues related to consciousness. So, so the idea is to reveal all kinds of presuppositions about what the world is like in these different scientific attitudes. So, for example, on physics, we are talking about a method to approach any approach. Physics is an exact science, and what Husserl, what you can find in his texts is identification of different kinds of sets of epistemic values guiding different kinds of approaches. He talks a lot about calculability and the kind of generalization or homogeneity it requires, as opposed to, in a way, different kind of norm of rigor, which would involve different kind of notion of generality and kind of a bottom up kind of a generality and domain specificity. I would love to talk about this particular thing for like hours, but I am going to leave it here. Many phenomenologists are nowadays excited about Husserl's approach to physics and are trying to use phenomenology, especially to cubism. But my view is that with a phenomenological approach, you should be able to describe any interpretation of quantum theory. So just as an example, you may know Husserl's Crisis, which is written for general public, and Husserl claims that he's not using any technical vocabulary. Well, he uses a bit odd vocabulary instead. It shows that the kind of Galilean values have started to dominate all the other values, and this development then is kind of irrational simplification of the model of rationality. I'm not going to dwell on that, but we'll then go further to the question of consciousness. So the idea is to look at the presuppositions of what scientists are doing. So in the paragraphs of 102 to 105 in Formale und Transzendentale Logik, Husserl turns this investigation to the investigator itself. So in order to do this, the investigator has to be conscious. So there has to be certain things in place. For example, intersubjectivity. And all kinds of other structures, for example, embodiment and time. And here, ultimately, when coming from these socially conditioned practices to all the way to one's own consciousness, you get the task of phenomenology to describe the invariance of our conscious experiences from first personal point of view. Now, so this is, there you are describing something irreducibly first personal, but the idea is that you are describing the invariant structures, and the ideal would be that there are lots of phenomenologists who compare their results with each other so that they are sort of intersubjective. So these should be same to all, or at least to all with a so-called normal consciousness. All kinds of psychological disorders are a bit of a problem because they do not follow these structures. Now the relationship to different kinds of scientific approaches here is that in studying the structures of consciousness, they give you information that you know comes from different point of view, which you can take into account so that you can rethink your phenomenological description, knowing the results of different kinds of sciences. So you can you are not going to adopt these results, but you can use them. And of course, you are not supposed to do anything that contradicts the scientific data, or it's not rational to do so. So now I was thinking of giving as an example of one primitive structure, structure of time consciousness, which is that our time consciousness is analyzed in a threefold way to consist of potential, primal impression, and retention. So the idea is that we are able to experience melodies that are temporal objects. Now, these Husserl thinks cannot take place with a slice-like, point-like consciousness, but Husserl thinks that it shows that our consciousness is continuous. And it's analyzed so that we have the now, which is called primal impression, but that comes with a retention. So the awareness of what just took place, and that's something that sinks into past. And then we have a protension, so some kind of awareness or anticipation of what is going to take place. So for example, all of you, presumably, have this kind of time structure right now. You're looking at me. You have a primal impression, but with an understanding of having been listening to me already for a while, for almost a bit too long, and with an anticipation of what's going to happen soon. This kind of structure is needed in order to be able to experience, for example, a melody. But to give a quick response to Valtteri's earlier analysis, when we have a melody, do, re, mi, for example, the idea is that they are not all in the present, but only the one that is the primal impression, the now, is in the present, and then the what is expected to come in the melody next is in the protension, and what just happened is in the retention. So that's a kind of a flow of the time, and from that flow you unify the melody. So it's not that there's three separate contents at the same time, but there's just the primal impression, and then what happened and what is expected to come next, from which you unify the idea of melody. So that's just as a specification of how Husserl would see the time consciousness. So now, to conclude, I have tried to explain to you how Husserl offers a method for a specification of different natural theoretical attitudes with different goals and epistemic values. Now, Husserl wrote in the early 20th century, but now if we use this, we could think of different kinds of approaches: AI, quantum or not models, cognitive psychology, and so forth. All these different kinds of theoretical attitudes, and there are different ways of constituting sometimes the same phenomenon. And then looking at their presuppositions about what they project the world to be like. For example, the approach, artificial intelligent approach, has a different presuppositions about what the world should be like, or what the world is like. And now the idea is to attend that the concepts and principles are only applied in their proper domain. So the idea is that, okay, this is the information in that point of view, and that's it. We use that in a phenomenological point of view, but we do not want to reduce consciousness to them. So different points of view are not reduced to each other either, but they preferably inform each other. And ultimately, it's about description of consciousness from first personal point of view. And then much of this is context dependent. So when Husserl talks about the sciences, it's obviously not the science of today, but there are some results that are not bound to the historically changing context. And these are, for example, the results about time consciousness, intersubjectivity, numerosity perception, multi-sensory embodied perception. That the talk yesterday was a perfect example of this. And there are many more examples like that. So other points of view provide, from the phenomenological point of view, other points of view provide abstractive points of view, projections guided by certain epistemic and other values that may help in further understanding our lived experiences, conscious and embodied experiences. But our first personal point of view is always the irreducible starting point. So thank you.
Thank you very, very much. We have time for one quick question while Luigi is setting up. Yeah.
The question that I wanted to ask has to do with the maturity of sciences. It seems like when sciences become mature, they begin to explore their scope and limitations from the inside, not a philosopher that comes from the outside and determines the scope and limitation. Let me give you two quick examples. One has to do with the Gödel and the incompleteness theorem, where he actually determines the epistemic scope of mathematics, certain limits on it from the inside. Another example would be when classical mechanics matures into quantum mechanics. Again, Heisenberg uncertainty, some kind of an epistemic attitude or scope that actually emerges from the inside of the theory. And these are the most beautiful instances where the sciences actually reveal something about themselves, which is closer to the Heraclitean attitude where nature likes to reveal itself. It's more Heideggerian. And so I don't see how, I mean, it seems like these kinds of revelations are more deeper and more interesting than a philosopher that comes from the outside and tries to determine the scope and limitation of these sciences.
Nice question. Husserl is very much aware of that problem, and because of that, he developed a certain kind of method that he calls method of Besinnung, which means, and this is a almost direct quote, although from translation, it's an empathetic engagement in the community of scientists. So he wants to get involved with the scientists' goals. He was so the idea is to figure out what, for example, the mathematicians are aiming at, and so therefore he he very much wants to find out these goals and epistemic values from the scientific practices itself. So in that sense, it is not. It does not come from. It's not giving external standards or norms to the scientific activity, but it's trying to get into get them out of the practice itself.
Okay, let's thank Mirja. Sorry, not Mirja, but anyway, Mirja, once more. So while Luigi is setting up the microphone, let me tell you about one advertisement. So this conference is largely due to Paavo, Mind and Matter 2022, and of course the Profi Action, where Luigi is my colleague. I'm also part of that Profi Action. That's also due to Paavo, and we will organize a follow-up conference, Mind and Matter 2023. Still the program is quite open, but we will organize that next year around the same time, around mid-June. For those who are interested, you might want to know that already at this point.
Yes. Okay,
and then, well, as I said, next we have my colleague Luigi Acerbi, who is working at the department, associate professor.
Assistant.
In the department.
Still assistant.
Sorry, assistant. I'm sorry.
It's okay. Maybe one day.
I hope I'm right saying that you lead Human and Machine Intelligence Research Group, and you will talk about your research group's work.
Thanks for the invitation. Thanks for being. It's nice to be here. Can you hear me properly? Is this working? Yeah, it looks like. Thanks. All right. Yeah, so that's the title of the talk. And so just a brief overview. This is my group. I started relatively recently. I have some postdoc, PhD student, and some research assistants and master students. And so this is the title, as I said, Probabilistic Machine and Human Intelligence under Extreme Resource Constraints. And there are lots of words there, and maybe I can actually explain a bit what I mean by those words. And so first of all, yeah, I highlighted intelligence under extreme resource constraints. So I'm going to talk briefly about what I mean by resource constraint and their link to intelligent behavior. When I talk about extreme resource constraints, I will also make a concrete example, talk about limited information. And yeah, you might wonder what's probabilistic. So why do we need the probabilistic part? Well, because probability theory can be taken as a solution to the problem of limited information. And yeah, the machine and human intelligence part is because I will be talking very briefly about both biological and artificial systems. So first of all, okay, so what do we mean by resources? What's a resource? And well, you know, we'll be talking about time. So time is a resource, memory is a resource, processing power, and data. And well, you know, since it seems appropriate for this conference, you know, you can fancily connect them to some properties in physics, time, space, energy, information. I'm not going to talk about that, though. And why should we care about extreme resource constraints? And typically, when I present these to computer scientists, they say, well, you know, why should we care? And because, you know, you can always pick bigger computers, and if you work at a big company like Google, Facebook, you know, I mean, the amount of processing power you have is almost unlimited. But I say, well, first of all, I mean, if you're not unlimited, still things cost money. And also you might want to care about the environment, because even, you know, running big computers and for a long time, let's say it has a cost for the environment. If you're running things on a smaller device, like a small brain, like a biological brain, or, you know, like on a smaller device, let's say you might care about constraints. Yes, you know, neuroscience, as I mentioned, so let's say biological entities have constraints, say through evolution, or by, you know, let's say the shell we occupy. And again, I will going to link to AI in the sense that actually constraints are helpful for intelligence and possibly artificial intelligence. So let's look at one specific form of constraints, which is limited data. So the typical constraint that you can think of is, I know you want to build some big machine learning model, and first of all, you need to collect data. You collect data, whatever, from the internet, from some company that collects the data. So one limitation could be the amount of data that you have available. In some domains, it's easy to get a lot of data. You can just scrape the internet and get a lot of data. For other situations, let's say it's not that easy. But also it's very important, of course, let's say quality of data. So let's say you might have a lot of data, but let's say they're all very low quality. So essentially there is very high noise and low signal. And then, let's say, so this means that you don't have much, say, information in those data to work with. So how do you work with this problem of having limited data? So, well, this is kind of the textbook answer. And the textbook answer is, well, you come to the problem with some prior information. And by prior, let's say it's actually a keyword. And so you're coming to the problem not just using the data, but let's say with some additional information that comes from before. Also, you want to keep track of uncertainty because essentially, since you have limited, the kind of, let's say, conclusions you can draw, or let's say the kind of models you can train, will have a lot of uncertainty because, let's say, they're not being trained on a large amount of data, but only on a small amount of data. So you want to keep track how certain or uncertain you are about your solutions. And then when you make decisions later on, let's say, for example, again, imagine we are building some artificial intelligence system. You want to keep and use this uncertainty to keep track of your future predictions. And there's a name for this. Probably it's been mentioned many times already before. And Bayesian inference actually kind of addresses all these issues. And yes, this is say Thomas Bayes, we know him. And famously known for Bayes' rule, which you can see everywhere in every place nowadays. And this is called Bayesian inference, but let's say just essentially an application of probability theory. So let's say you can also call it probabilistic inference, and that's fine. By the way, so let's say I've been talking slightly, mostly about let's say artificial systems or machine learning system, very briefly. But what else receives limited data? This thing. This is not a human brain, but let's say it's a primate brain, and let's say we have one as well, probably. And so it's kind of natural to think that, well, if you have a system that receives noisy, limited data, that system, let's say, in some way, somehow, is going to follow some Bayesian approach. Then to which extent, we can discuss it, but let's say there's been a lot of work in the past now, let's say 30, 35 years, about seeing at least perception and then also cognition form of Bayesian inference or probabilistic inference. And again, let's say the rationale or starting point, let's say for having this belief, let's say this hypothesis, is that, well, so if you have noisy data, I mean, honestly, let's say probably the best thing you can do is to be Bayesian to a degree and apply the rules of probability, keep track of uncertainty, et cetera, et cetera. So let's say that's something that probably the brain should be doing in one way or another. And that's something I've been contributing as well, let's say in my research in the past. So as a very commonly used example that it's been used ad nauseum, but let's say I really like this sentence by Anil Seth, or at least is the person I know that he's been talking about this. So maybe you already presented this. Perception as controlled hallucination. So if you look at this picture, so how many of you can see what's in this picture? Yes, not everybody. Yes, that's good. So it still works because every time I present it, I'm burning it for the audience. Because so now I'm telling you there's actually a dog drinking from a paddle in this picture, and now your brain has been primed. Let's say synapses are being connected, and from now on, forever, for the rest of your life, you will see a dog here. So whenever someone shows you this picture, you know what's in the picture. And notice that nothing has changed in the sensory data. So you always see this kind of batch of blotches. But now let's say you have this kind of top-down, prior expectation about how to read this set of dots, and your brain now is going to do inference and say, okay, actually that's a dog. Okay. So the research in my group has been looking at Bayesian brains, or let's say Bayesian perception. But let's say once you start fiddling with Bayesian tools and say Bayesian theory, let's say you can actually use it just as a statistical tool to do analysis. And the point is, the kind of data we get from say these kind of experiments that we run on humans, for example, is limited. So let's say we end up using Bayesian tools to make sense of limited data. And the problem is that, running this analysis is expensive. So let's say often you can run them like on a limited number of times and getting, let's say, a limited amount of computation. And again, if you kind of generalize from this, you understand that you can also develop Bayesian algorithms to Bayesian analysis or Bayesian statistics of Bayesian brains. And this kind of, and you can keep applying, the Bayesian. So Bayesian, is this big hammer that, you can apply to everything, and then, you start, let's say, applying it repeatedly. And so what my group has been doing, essentially kind of working, say, being Bayesian all the way up or down. And in fact, let's say, to be honest, what we've been developing, say, doesn't need to be, say, constrained to Bayesian stuff. So we can actually apply to modeling any system that you care to study. Yeah, how am I doing with time? Because I don't have any reference.
Just give 20 minutes.
Okay, whoa, okay. Okay, yes, so actually, since I have time, then I have time for a short demo of what I mean, because I've been, incredibly abstract, and I know, let's say, there's no trouble being abstract with in this venue, but let's say I want to give you some more concrete example, if it works. It's always a bit, so what I mean by a Bayesian algorithm. So, yeah, what do I mean with it? Okay, this is a bit of a mathematical problem, imagine, but let's say let's make it more concrete. So let's say your job, you're a surveyor, you're going, you want to find essentially the place where to drill to maximize the oil that you can get, if you place some drilling machine on a certain landscape. And so let's say everything's simplified, so it's a one-dimensional landscape. So X essentially is your position in this landscape, and this function here tells you, in some sort of a logarithmic scale, how much oil you're going to find if you drill there. And of course, let's say, you can, so before, let's say, building and start mining or do whatever they do, let's say, you do some sort of, small surveys to kind of get an estimate of how much oil you can find if you drill at that location. That's kind of, imagine that's kind of toy problem. So how do you go about it? Because the point is, drilling is expensive. So let's say, so you don't want to, drill every single point, and say, so you have a limited number of, points that you can go and drill at. And so we're going to be Bayesian about it. So let's say what we start is with a prior about possible, let's say, functions that represent how much oil there is in a certain location. And this prior, it is a green function, which is flat. We start, everything is the same oil, and it's around, let's say, this amount, which is 0 is not 0, but let's say, it's an arbitrary number. It tells you, okay, there is some oil, maybe not much. Ideally, we want to kind of find some points which are very high, and drill there. So we start drilling here just because we need to start somewhere. So we choose a point right in the middle of the interval. We drill there, and we found, let's say, this value here. So what we do is, if it works, I'm not sure if it's going to work. Yes, it works. So we want an algorithm that essentially tells us where to drill next. Well, we already did the second drilling. So as you can think of, it's like, well, since we drill here, the next point would be maybe let's drill far away from where it was so that, we had some information about what was happening here. The green line kind of tells us, again, now it's not our prior anymore, but it's our posterior, so our belief about, let's say, this shape of this, oil density function or whatever. And as you can see, it's still fairly flat. So let's say, we don't have a much expectation about what's going on. But let's say, if you were to drill next, let's say, reasonably, let's say you can imagine that you might want to drill maybe here to get more information about what's going on here, or you might want to drill here because maybe there is a bit of extra uncertainty about where the oil is. So we want some algorithm that does that kind of automatically. I mean, of course, you can just ask expert to do that for you. But let's say this algorithm, the idea is that this algorithm is doing it automatically for us by telling us where we should expect to find maximum oil. Now it's suggesting this point. And we go and drill there. Oh, that wasn't a good point, so it's actually went low. And we keep updating. It says suggest to go there. Not a good choice. This one, not a great choice. This one maybe, flat. We keep going. Now essentially we go and explore this area here. And okay, that was even lower. So we're not doing particularly well. As you notice, say, this green area is a kind of expand. They represent our uncertainty about the oil. So the essential point here is that we are keeping track of what we believe this function or distribution of oil could be, and we keep track of this green area which represents our uncertainty. So now, for example, we have a lot of uncertainty here, so it's worth to go and check it out, essentially. and we go there, not great, and okay, now you actually found a point which was higher. We keep exploring. I mean, I think you understood how it works. Essentially, we go and explore where there's high uncertainty, and finally we found some decent. Okay, and in the end, the maximum dysfunction ended up being here. So now, of course, you can say, well, why did we need an algorithm to tell us that? These are one-dimensional functions. It's fairly easy. I could have picked, a grad student or a master student even, and done it with a master student. But the point is, once you start moving to, let's say, 2, 3, 5, 10 dimensions, this problem becomes actually hard. And humans are not that good anymore. I mean, they're still good, but let's say, it becomes tricky. And so let's say now we can automatize this kind of optimization problems to go and search for points essentially that maximize function. Then you might wonder, why do you care about maximize function? Well, if you do anything in engineering or machine learning, etc., it's about optimizing things. So let's say this is actually quite useful. That was kind of an example. All right. So yeah, by the way, for example, maybe you heard of this. Let's say an machine learning system that a few years ago now is old, say it's part of history. Beat humans at Go, which was believed to be a very hard task. You would need real intelligence, and and the machines did it. And part of that system was actually a method that would choose some of the parameters of these machines through Bayesian optimization. So that I mean, the alternative would have been to have some some researchers picking parameters by hand, and then of course, let's say if you're on Google, you want to automatize that, and they did automatize it. And and also from our group essentially has been working on algorithms of this kind applied to, let's say, various forms of modeling and let's say model fitting. Okay, so an interim conclusion. So let's say the Bayesian approach is probably, say, our best bet at getting as much as we can out of limited data. And we can use or develop Bayesian algorithms that combine uncertainty and active sampling. By active sampling, I mean this idea of checking out essentially regions where there is uncertainty and which are also promising for whatever task you're doing. In this case, your task was optimizing, but you might have other tasks, and you will use uncertainty accordingly depending on the task you care about. And well, I mean, this kind of this doesn't follow logically from what I said here, but let's say given the kind of tasks that brains need to solve, let's say we can actually see them or at least model them. Doesn't mean that they are, but I'm not going to talk about what it means to be, but let's say we can interpret them, or let's say have this framework in which we assume that brains work like Bayesian inference engines, and this gives us a way to at least interpret their behavior. Doesn't mean that I'm not saying that they are, but it's a useful lens to explain or try and understand their behavior. Another thing I want to mention is that the fact of being constrained is not necessarily a bad thing, but let's say actually that's where intelligent things happen. If you had infinite resources, you wouldn't need to be intelligent. So let's say so if you have infinite, so if you can drill the entire landscape, if you can sample all the points, you don't need to adapt any and to use any smart approach. You can just do everything, or find all solutions and then just pick the best. The point is we cannot. In general, you can't in the world. For any interesting problem, you can't try all solutions. So having these, say, constraints of some kind, actually, what makes intelligent behavior emerge. Okay, what about other resources? Do you have time? 10 minutes. Okay, so yeah, I'll just do 5 minutes and I keep the rest for questions. So another resource I want to talk about is, very briefly, is memory. And this is work I've been doing in collaboration with researchers at the University of Geneva, Nishit Patel, who is still a PhD student in Geneva, and Alex Pouget, who's a professor there. And well, you might have heard or seen of reinforcement learning is a framework for both, say, teaching artificial agent and also to explain the behavior of biological agents like mice and humans. And the idea is that you have an agent taking actions in some environment, and then essentially there is some sort of interpreter that gives reward based on the action that has been taken, and let's say, and the state of the agent environment gets updated. It's kind of it's a loop. So let's say if you imagine, say something moving around in the environment, doing some actions, and let's say, and if you're a mouse, you hit a lever, you get a reward, and say you get some water, you get a reward, you're happy, then that's changing your state. And you can model it in a very simple way in this kind of very much used grid world. It's literally you put your agent on a grid. It's like simulated environment, and this simulated mouse can just move around these squares. And the goal of the mouse is to reach the cheese. Very simple. So this kind of quote unquote maze is typical and the kind of grid world that you find. And what reinforcement learning tells you is that you run the algorithm many times. And eventually what the algorithm does is that assigns a score, let's say a value, to each one of the states, here the squares of this grid world. And let's say, and what the algorithm does essentially assigns the maximum value to the path that brings you to the cheese. And so that once you're in a state, now making choices is easy because let's say you only need to follow the local best value. So essentially, so once the agent has been trained, so say I'm hiding the training part, but after this training, once I'm here, okay, I know that I need to go here, then here, 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 and then you just have kind of this, this path that guides me to the cheese. So that's easy. So, and the goal is to maximize the reward. So essentially, once you train your agent, that's what they do. They maximize the reward, which is getting this cheese. So the point is, of course, this is not realistic because it's we assume, typically in reinforcement learning, it's assumed that the agent would know the value, say the reward, would encode the reward exactly. It's just, this is like a floating point number, which is you can imagine almost like a real number, which infinite precision that the agent is storing, and that's unlikely for a biological agent that they would actually encode everything with infinite precision or just even with high precision. And so we imagine that there is a resource cost for encoding with precision these values here. And what you can imagine is that now essentially when you have a low precision encoding, it means that instead of having, let's say, an exact 10, you have some sort of a random number, which is somewhere between, let's say, 9 plus minus 2. So say somewhere in between. So you can imagine essentially that if you want to be precise, you try to reduce the amount of error. So let's say it's kind of plus minus 2, plus minus 1. While higher error could be plus minus 5, plus minus 6. And the idea is that the cost is proportional to how tight this uncertainty is. So let's say the agent pays a cost, it's a virtual cost, for having more precise encoding of the information. And we can run these algorithms. Let's say I'm kind of, again, sweeping a lot under the rug. And let's say these agents learn, to go to the cheese, but also they learn to allocate more precise memories to, exactly as you would expect. So these somewhat unsurprising results. So they will remember, so the color here is proportional to the precision. So essentially, the darker the color, the higher the precision. So the agents here learn that they need to remember well this kind of corridor, and they don't really need to remember what's happening outside this corridor. So the corridor needs to bring them to the cheese. The rest, they don't really need to encode. And if you keep training them, they learn it a bit better, but same thing. But it's a dynamical algorithm in the sense that if we move around the cheese, after some quick retraining, they move around and they kind of forget about where the cheese was, and now they remember that they need to follow this corridor. And actually, after a while, they even learn that there is a better path going up, which is kind of this shortcut. Anyways, so we've developed this framework, which is kind of new in the sense that reinforcement learning is very much used. For example, reinforcement learning, in a bigger scale, was what trained the AlphaGo system I mentioned before to win against humans at Go. So that's also used reinforcement learning. So this, of course, is a much more toy version, but let's say we added this element of adding resources and some cost to, for example, memory. And the idea is that you can also add other resources like computation, but that's something we plan to work on. And this might lead to kind of connect to how memories and resources are allocated in actual mice tasks. And at the moment, we are running experiments on a human with a collaborator at Stanford. And so we hope to extend this framework to kind of work on how compression and limited memory can bring up generalization and abstraction, because the idea is that, as you probably know, if you remember everything, again, you don't need to generalize. You would need to, but you're unable to, because everything is a separate instance. But let's say if you're forced to compress, then actually that's a good thing because it allows you to generalize. Conclusion. So I like this lens of using extreme resource constraints as a way to as a lens, again, to understand and potentially build intelligent systems. So I made some examples. Limited data can bring up, let's say, the solution would be applying some form of probabilistic Bayesian inference. If you have limited processing, you might want to allocate and choose well where to allocate your resources by, say, actively choosing, for example, the points where to drill. And I haven't talked about that now, but let's say, I kind of briefly mention how maybe limited memory, we can see it as a way, again, to induce and say, provoke generalization. That's it. And I want to acknowledge, of course, my collaborators at the University of Geneva, and actually former collaborators at the New York University, my current group members, and let's say sponsors, FKI and HIT. And yeah, you can get in touch or also ask me a question now. Thank you.
Thank you very much. Questions from the audience? So no questions.
One quick question. Are you working on any applications on advanced air mobility or completely automated systems at Helsinki University or Aalto through this artificial intelligence probability work?
So the question is if I'm working on a system.
Are you working on any applied robotics for completely automated?
That's a good question, and the answer is no. This is purely theoretical work. Maybe one day we'll get in that direction, but at the moment we're still developing kind of the foundations. Sure. Yeah.
There is this paper from last year from DeepMind and Silver. Reward is everything. Any comments about that? Is it enough for artificial general intelligence?
Yes. So, yes, exactly. So if I'm not mistaken, that paper is essentially analyzing what the limitations are of the current ways of giving reward.
Or maybe I define more, but how many types of different skills can the agent learn on the way to the reward? How intelligent can it be on the way to the reward?
No, sorry, I understand the first part of the question. How many?
How proficient can the agent be navigating through the environment on its way to the reward in the end?
So I mean, once you train these methods, they get, they usually find good solutions, or possibly, let's say, the optimal solution to the task. These are incredibly inefficient algorithms in the sense that, let's say, I mean, in general, reinforcement learning is very inefficient in the sense that it takes very long training. So, for example, even in this toy setting, the numbers I had there were, 300 trials, so 300 repetitions. You get to thousands, but you need hundreds of repetitions to go through the environment to learn, even how to go from A to B in in a very, very simple scenario. So these methods work, and even the same, for say, even AlphaGo, which is, let's say, astonishing in what they did, still, requires a lot of training, a lot of computational power. So these methods are still, not efficient. So to my knowledge, I mean, let's say there's definitely been some work, but let's say, so ideally what you want is systems that, learn better, and they are more selective, what they learn, and they are more, let's say, sample efficient. It's called, let's say, the idea that, you learn with less data. The point is that, many of the systems at the moment are kind of tabula rasa. They start from, some sort of a randomized state, and then you just train them. So the idea is that, of course, let's say, we don't start tabula rasa, and so how to have broader systems that kind of have some innate, by innate, I mean, let's say, learned by other system knowledge of the world, so that then they can use it. Just to finish quickly, for example, if you train a RL system on video games, they need to learn everything from scratch, Well, if you take a kid playing a video game, well, they know, okay, if it's a skeleton, it's probably bad, it's an enemy. If it's an hamburger, it's probably going to give me extra life, etc. So there's kind of, some knowledge of the world. So it's like we need to find a way essentially to transfer knowledge of the world to these systems.
Okay, I guess, with that, let's thank you once more for his talk. So the final speaker on this session, before we have a very short break and then we have online talk, is Ben Cowley, who's an associate professor in Department of Education, and also CI on High Performance Cognition Group. And I guess you are set.
Great, thank you, Valtteri. So, and thank you to Luigi and Mirja for setting me up, warming up the crowd, as it were. We're almost there. Don't fall asleep on me. Anybody feel sleepy, just stand up and put your hands up. Don't move around, just stand up and sit down again. I want to talk today a little bit about some empirical work on flow. So yeah, I'm going to bring us right back down to less abstract stuff. This is not, flow is not my primary research interest, actually, in our group. Our group is called HyperCog, and that stands for High Performance Cognition. So I'm interested in something about how the cognitive operations generate flow, if you like. How people learn to perform cognitively demanding dynamic tasks under uncertainty. There's not a total dissimilarity with what Luigi's talking about, actually, although it's a kind of a latent similarity. We don't work together yet. But having this kind of idea of what we want to look at, this kind of high-performance cognition stuff, doesn't actually, and wanting to measure it in humans, doesn't immediately give me a way to access these states, because how do you know when they're happening? If I want to measure something, I must know when it's happening. So there are multiple ways around that. Performance would be one, but another one is to look at the phenomenology. I can't read minds, but I can ask people, when are you experiencing something that corresponds to a state of high-performance cognition? I would say that flow, as specified or as kind of written about by its founder, Mihai Csikszentmihalyi, RIP, is a very special and specific state. So it's not a kind of one-to-one mapping. The phenomenology of HPC might be broader than that of flow, but it would give me a marker wherein I could identify those cases where flow has happened and work backwards from there to look at the behavior and the physiology, so the neuroscience and the kind of activity of the individual, and try to reason from these measurements about what's theoretically happening in the cognition. Aside from flow, though, this framework of the phenomenology, I need another framework in order to tell me about what I can hypothesize about this cognitive operation. So, surprise, surprise, that would be predictive processing. And there are several potential frameworks. Perceptual control theory would be another one that might work, but predictive processing is maybe convenient framework at this point in time, given that it's receiving so much work and there's so many ideas around that. I think that most will know what it is, but just for the sake of it, so that's when you would have, when you suppose that the brain has a generative model of the world which creates predictions about what it expects to find, which then cascade to sensory input areas that generate prediction errors according to how correct the prediction was, and these would be massively parallel cascades. Applying that to the kind of flow idea as a very simple kind of schematic, if you have a prediction that the challenges will exceed your skills in a particular task, if you've done the task a bit, then you might think, oh, well, I'm this good at the task, but the task I'm about to try is harder. Then you might predict that you're going to end up with this kind of experience. And when you actually start doing the task, you might find that, hey, your skills have increased. Perhaps you had a good night's sleep. Thank you, Anu, Katrina. So then you might end up with a prediction error that tells you you're actually in the flow zone. This can go either way, of course. You might predict something and then it gets you out of the flow zone. But the recalibration of your expectations based on your prediction error will have some cost in your experience of the task. So we can take this as a guideline to make a hypothesis that perhaps flow will be proportionate to the prediction errors. If you had larger errors, you'd have a larger recalibration. Your experience of flow would take longer to realize, and vice versa. I think that we can make other predictions that are more related to performance than flow, but based on the same idea, that predictions and prediction errors will converge to stable patterns, and that generates this phenomenology of flow, which involves things like being in complete control, being at one with the activity, and so on. So that's the framework or the setup of this kind of work I'm going to talk about. It leads me to an immediate problem, though. That using phenomenology to probe mechanics of a cognitive operation is sort of backwards. It's difficult to extract the phenomenology, whereas it's kind of more, you get a lot more data from your measurements than you do from your phenomenological inquiry. So the design must allow you to probe the phenomenology often enough so that your dependent variable is not not so sparse. Self-reports are essentially all you have to probe flow, and if you just have somebody do a task once, then you'll only get one self-report because you can't ask a self-report during a task. You have to wait till it's over. So that implies some kind of a longitudinal design. Particular to the phenomenology of flow is the fact that it is conceived of as a very special state. Researchers in this kind of domain over the years have maybe strayed from that a bit, but if you ask the people that kind of trained with Csikszentmihalyi, they hold to the idea that it's a very special, specific state, so it might not happen very often. Therefore, you need to maximize the probability that this state will occur through the design of your task. So these kind of illustrate, the reasons or the logic for the task I'm about to, or the experiment I'm about to show. And the aim overall is that by using this identification of flow periods, we would look for behavioral or biomarkers that might indicate when somebody has been experiencing or has been going through some kind of high-performance cognition that would help to generate flow. So on the experiment, we use this kind of steering game designed under the auspices of a kind of psychophysics staircase model, wherein you have to steer this blue cube down a track and avoid the obstacles. And the staircase kind of idea comes into it, wherein if you don't hit anything, if you avoid the obstacles, you go faster and faster. If you hit something, then you go slower. So basically, the design of the task is titrating the difficulty, and it makes for a tight coupling between this kind of skills and challenges, such that it should kind of maximize, all other things being equal, it should maximize the opportunity to be in this flow zone. So then we conducted a longitudinal experiment, as I said, so we put people into this kind of 8-session design, where within every session would be separated by at least 1 day. Within every session, individuals would play 5 trials, which each trial corresponds to one run of this game, plus viewing this kind of score or outcome of the game, and then some flow self-reports, a flow short scale, which we translated into Finnish in this case and validated that psychometrically. Yeah, performance basically was as expected, that people learned to play this game quite uniformly. Everybody learned to perform the game. In fact, results were more or less converging. There were differences between individuals in terms of their background, in terms of gender, in terms of prior driving experience, in terms of prior gaming experience. These differences did tend to converge as well, although that may be also due to converging variance of the performance. Individuals all did experience flow to an elevated degree, so the mean or the midpoint of the scale would be 4, so they were all, the mean flow was all above that, and the median flow of the whole sample was about 5. So yeah, they did experience flow on average. And then I'm going to talk a bit about behavioral analysis of this data and what that tells us about the flow experiences. So here are the individual-wise performance values. We see that because they're visual motor skill learning data, then they're best fitted with a power law model. If we take that power law model and then transform the data to a log-log space, then we can get back a linear model, and also label each point, so label each run of the game with the associated flow value normalized. And if I zoom in on some of that data, you can sort of see something which is what tipped us off to this effect, was basically seeing it in the data, that these flow values or flow labels, they distribute more or less positively to negatively around these curves. So you have more positive values of flow below the curve, more negative values above the curve. You can analyze that by taking the deviation of the points, so the absolute values of the residuals, and the direct values, not the residuals, but the signed values. And then taking this sort of deviation measure and comparing that to flow, we get a very strong effect. So we see that on the right-hand side you have a set of panels for every individual, wherein the color shows you on the left side, the green area, the better than expected or better than predicted, and on the right side, the red area is worse than expected. And this is a strong relationship here between flow and deviation score. The direction of the relationship doesn't really matter. It's just a function of which way we made the subtraction. So here it's a negative relationship, but it's basically, for almost all the subjects, a very strong relationship, which shows that it's expectation of performance that drives the subsequent experience reported as flow. We might wonder if there are confounds there, because the scores going below the lines, below the models, are also lower scores, so they're shorter durations. But we just tested for this with a model that partialed out the effects of either deviation scores on the left or duration scores on the right. And as we see, the deviation score controlled values are quite random, whereas we retain most of the effect when we control for the value of duration. So it's not the overall duration. It's indeed the difference between this model fitted to the performance scores and the actual performance. We originally reported that in this paper, but we went further. The first time we did this, we took half of these people. We gathered half of these people, and then the next cohort, we pooled that data. You're looking at pooled data all the time, but just wanted to explain that when we went further, we were also able to look with this larger data set at task experience. Here we have an interaction model where we take the effect of the deviation score on the flow score at an earlier stage in the longitudinal run, or the longitudinal experiment, and at a later stage. So it's plus minus 1 standard deviation of the cumulative runs of during the experiment. The earlier, so the solid black line is uniformly with a less steep slope than the later. So as experience was gained, the effect of deviation on flow score strengthened. I can also show this numerically, basically by taking a sliding window instead of taking a power law model across 40 trials. We take a power law model across 10 trials and then slide that window 1 trial at a time across the entire 40, so that we end up with a series of estimates of this effect of 31 long, and we can see from this kind of series of estimates that it's increasing in strength. This relationship increases in strength across this set of sliding windows, with the right side picture showing the group average. And we reported that here. So both task expectation is predictive of flow, and also task experience is modulating that expectation and the strength of that prediction. I want to go on to also talk about that we measured physiology in these subjects and what that implies. So this was sort of lightweight physiology setup as far as it goes, so no major brain scanning or anything like that. We measured skin conductance and eye tracking. So the rationale for that, so Di Manzano has shown in 2013 that the predisposition to flow is positively correlated with striatal dopamine measured in PET, and the spontaneous eye blink rate has been shown to be a possible index of dopamine. So that may have the potential to tell us about the attention updating rate of the individuals, whereas skin conductance is an index of sympathetic nervous system arousal, which may tell us something about the energy or attention budget that they have available for immediate challenges or task actions. So looking at the spontaneous eye blink rate, this was estimated from baseline sessions before, baseline measures before each session. There's one, just a data plot where we algorithmically estimate the blinks and validate that with human raters. And then the EDA, the ectodermal activity, which gives us skin conductance responses, was measured from the foot sole in order to minimize motion artifacts, because the individuals were using their hands. And to get that skin conductance response data, we analyze with non-negative deconvolution to identify peaks and count those. Then an important aspect of this SCR that I'll talk about is the habituation rate, which comes from fitting a model to the SCR frequency data which, as you can see, sort of monotonically decreases within sessions across all subjects, although it does vary across sessions, or the frequency rate varies across sessions, but it monotonically decreases within a session. So that's habituation. And yeah, I'll talk about different levels that we have, sort of, because it's a longitudinal, thanks. It's a longitudinal data set, so we, by default, generate a sort of hierarchical data set with different levels. So at the participant level, the session level, and the trial or run level, we have some different results of interest. So at the participant level, so we see a sort of not too strong, but definite relationship between the blink rate and the learning curve, so how steep was the learning curve of the individuals. And there is an interesting aspect of this wherein the value of the mean flow for individuals across all data corresponds to the relationship between learning curve and blink rate. If you can't see that from the kind of colors here, then I can take the residuals and plot them against the flow, and you get that kind of picture. So it's quite a strong relationship. This is suggestive of the individual-wise information updating rate being indicative of kind of speed of learning, but more for individuals who have more of a tendency to experience flow in this task. As I don't have all day, so I won't go into too much detail, but it's essentially has to do with how the task gives information to the individual, if you like, in that there is a kind of constant balance between individual-wise information updating and information availability, given that the task balances itself based on performance. There is also some small relationship between the speed of habituation rate and the performance itself. So the slower habituators, i.e. those that maintain an arousal rate, a higher arousal rate for longer, or those that sustain arousal, have on average better performance. Session-wise, we see some relationship between the same variables and performance. Here again is this baseline blink rate, now against deviation, averaged across trials within a session. And at first in session 1 there's no relationship, but then it sort of monotonically increases across sessions. I've labeled this with flow scores as well, just to show that there is no sort of relationship here. It only exists at the individual-wise level. Then there is additionally a relationship between the session-wise habituation scores and the session-wise learning curves, which are derived by fitting a similar sort of performance model, as I showed before, to the session-wise data. In this case, it doesn't matter whether it's linear, power law, or what have you, they're quite similar. But here it's a strong relationship at the session 1 and monotonically decreasing across later sessions. And then in the trial-wise level, there is a relationship between this habituation rate, the SC or frequency difference score, and the deviation from the learning curve, such that the slower habituators have the sort of higher values of this deviation score in the better than predicted direction, and vice versa. And here we see that same relationship shown on an individual-wise level, indicating that it's quite uniform. Not strong, but quite uniform. So I can take these points of evidence and bring them together in relation to my hypotheses. So firstly, that flow is proportional to prediction error is supported by the results on the relationship between flow and expectation of performance. That it's not about absolute performance, it's about anticipation or expectation. And that low trial-wise habituation is correlated with better than expected trial-wise performance. And I can take my hypothesis about the stability of predictions and prediction errors to show that it's supported by this idea that the task experience modulates the relationship between expectation and flow. And also that, sorry, that, now it's gone. Also that at the session-wise level, habituation becomes less and blink rate becomes more predictive of performance, suggesting that the arousal level becomes less important and the information updating rate becomes more important. Some implications of this, with hat tip to my doctoral student. So as challenges grow, events become less predictable and require more attention. And this may be linked to exploratory behavior due to the higher uncertainty, which requires this effects of sustained arousal and higher baseline information updating rates, or require may be strong, but it's one way to put it. And that flow is facilitated by the coherence between physiology and performance, which implies that perhaps approaching coherence is a bio or behavioral marker that we can use to reason about HPC occurring. So this has been all very empirical and experimental work. It is, of course, interesting to bring in computational, theoretical perspectives, and that's one thing that we want to do soon in the future. There are, as I say, a number of frameworks available for doing this. One recent paper that I can, that I can say we would definitely want to test is something that just came out in Nature Communications by Melnikov, computational theory and the subjective experience of flow. I'm really excited about this because I don't think that they used a measure of flow at all. So it's going to be interesting to test that out. And it's based on mutual information between the probabilities of the ends occurring. So the probability of the outcome, which in this case would be performing faster or performing faster with respect to this prediction model. And then the probability of the means, which is steering to avoid the obstacles. And that's it from me. I have references if anybody wants to take a picture, and say thank you to the team and all the collaborators and funders.
Thank you very much. I guess we are waiting for whether Daniel Kolak is on the line, so we have time for a couple of questions. If there's any.
If you don't feel inspired, just stand up. So you'll have a rush of
Everybody
blood
stands
to the
up.
head, and everybody stand up. You're going to go stand up and go get coffee now anyway.
So I don't see any questions. So I have actually a very simple question.
Excellent.
So if I understood correctly, when things become more unpredictable, also the flow experience, well, then disappears or becomes short. Flow experience decreases if the prediction errors are, like if it's too unpredictable situation. I got that they are called prediction errors, so how well you can predict your performance correlates with the flow experience. Is that correct?
Yeah, essentially, yeah. I mean, we have to take account of the hierarchical level of the prediction. So in this case, we have only flow data at the end of a run, so it's that's the level of our rationale. So the prediction there, I think we can still talk about predictions at that level.
Connecting to Zoom?
No, I don't want any Zoom. Yeah, so the prediction at that level is a prediction about the trial-wise performance. And then at that level, which is admittedly quite coarse, but at that level, yeah, then it's about whether or not you're doing better or worse than that prediction.
Right. And at the end, you said that when things like one of the hypotheses that when things become more unpredictable, more difficult, well, there's more prediction errors, I guess. But at the same time, like then I guess at least if I would be a test subject in your study, I would not feel myself.
Prediction, like things become more uncertain at the trial-wise level. They're more uncertain when the variance is higher around the curve, and that does correspond to the flow.
Right.
What I was talking about had to do with sustained arousal, which is related to the uncertainty of performance within the trial, and the uncertainty of performance there has to do with, or the uncertainty of the within trial picture has to do with basically that as you go faster, it's harder to predict what's happening.
Okay, I guess
so when performance increases, it's harder
yeah,
to predict.
Right. I'll talk about that with you later on that issue. Let's thank Ben once more and let him move on.
Introduce the final speaker of the conference, Professor Daniel Kolak. He, of course, he has a strong connection to Finland through the late Jaakko Hintikka, and he's the author of really many very interesting books. But today I think we will hear something connected to his book, I Am You, and I think he will tell us about that. So please, Dan.
All right.
Take it away.
Is my screen share working there?
Yeah.
You can see my slides.
So if you try share screen.
I put on, you need to power my share screen. It shows at my end the screen sharing.
Now I think it's
good.
Working.
Okay.
Now we're seeing it. So and I'll let you know.
So now you're seeing both
when you have
my mug
Great.
and the screen mug. Wonderful. All right. So I'll in the interest of time, still provide a quick little background radiation for those of you who don't know me personally. That's a joke, son. So I going back to the dawn of time. My time, because from the early stage I can remember, Dyson says disturbing the universe disturbed me, its existence and my existence in it. So naturally, I entered engineering, College Park, Maryland, to study physics. Unfortunately, there were luminaries there, such as Misner, famous Misner strings, and Misner black holes, and Weber in search of gravity waves. I say unfortunately because I was also, the disturbance continued because I was disturbed by the physics department because I had these crazy ideas. So for instance, I was working on stuff trying to, the Big Bang. Yeah, well, it wasn't big and it didn't make a bang. Of course, there's no oxygen, but also there's no observer. And by my lights, if you have no observer, you have no universe. And I was working on this very un-Penrose-like, un-Hawking-like, un-Misner-like model of black holes, ultra-chaotic, with an ultra-singularity theorem that I was hoping would show that without an observer, you can't have anything at all. And then furthermore, it occurred to me, once I realized that what I was studying was not the universe, but my own mind, that this observer, the way to count it, no, there's one, crazy. Of course, to the faculty, but not, it's like the higher up you go, you get to the event horizon with the universe, beginning and end of time. The higher up you go, the more you find something, oh, that's interesting. People who find your questions interesting are dangerous because if they're, they spur you on. So spurred on, I was there. But I still bothered by the role of the observer and so on and so forth. Well, ended up being pushed to the philosophy department, which I knew nothing until this is my 5th year already, and then boom, go to philosophy. All right. So and there I completed my doctoral dissertation, showing that what everybody said was not possible, namely to imagine how it is possible that we're all the same person, that there's just one observer, was in fact possible. And I wasn't at some continental school. College Park is well known for a very hard-nosed analytic department, and within the auspices of formal analytic philosophy, I showed that it is in fact possible. Now, possibilities are facts, probabilities are interpretations. Anyway, I show how it's possible, and terrific. And I was trying to integrate still the mathematics and physics of it, but of course there I was again disturbed by faculty who mostly said, no, you keep that out, that has nothing to do with this, you have to do it like that. But of course there were some who spurred me on, and I'll never forget the day I took Freeman Dyson, who was visiting, to the physics department, to the Union train station, and he says, oh, Charlie tells me you left physics for philosophy. Why? Yeah, I was going to start, given a coherent reason why, you start with Lagrangian, the quantum of action. Well, it's a Lagrangian, it's got a time signature, it needs an observer. How do you get from that to the Hamiltonian? But I didn't do, de Sitter spaces of zero, all this stuff. Didn't do any of that because I figured, you know what? Let me just be honest. And I said, well, part of the problem is blah, blah, blah. But also I think there's only one person in this car and I'm driving myself to the train station here. And I've written about this in print, but I give it to here just by way of this introduction. Dyson turns to me and he says, oh, ever since I was a little kid, I've believed that. Like, what? So continued to correspond for years and helped spur me on until I completed my dissertation. Went to publish it with Oxford University Press. Got a reviews back. Again, it's the yin yang. It's kind of like torturing a dog. Give him steak in one hand, stick with the other. The story of my life. Oh, you're crazy. Well, yes, but you're not stupid. Okay, so I continue to work on it. But Nagel's review said, oh, page and a half. This is nonsense. No. But then I get a 40-page review back from Oxford from Derek Parfit, whose I criticized in that book. It was like, oh, best written work on the subject. This is great. So boom, okay. But no, I didn't publish it with Oxford because they wanted also just to include the completed stuff, not the stuff I was working. So based also 20 years later to bring out IMU, the Metaphysical Foundations for Global Ethics. My thesis is very contingent on a bifurcation. Basically, what I proved already in my dissertation, either you're no one or you're everyone. Like everything else in life, you either get too much or not enough. So anyway, I published it with Springer, part through Jaco's urging, because I wanted to bring both parts, and it's already at 626 pages there. And I was still working the third part, which is the ontology of it, which is now I'm bringing forth as this alternative one, and why it's named that we'll learn in this talk. Let me get right to it, all right, with a thought experiment. You enter the teletransporter, you've used it before to travel between Earth and Mars. The scanner records the states of your cells down to each atom and quantum particle. Converting the energy to information, it erases the original matter, beams information to Mars, speed of light. The teletransporter on Mars reconstitutes that information structure. You step out of the teletransporter on Mars, the trip feels instantaneous. Later that day on Mars, you get an urgent Zoom call from Earth with a message, Mars, we have a problem. You recognize the person at the other end, it's you. Turns out that an unusual solar flare caused a glitch. The scanner on Earth sent the information to Mars without wiping out the original on Earth. But I made it, you say. I am here, but I never left, says you on Earth. I'm still here. A slew of all sorts of, by now, familiar examples, not just about imaginary, but actual cases of psychological dissociation, MPD, DID, commiseratomy, splitting brains, so on, the so-called fission examples, have raised philosophical questions. As vexing as the EPR paradox, two-slit experiments, the Bell inequality, etc., in physics, resulting in classical revisions of the received view of space-time, matter, and identity from the Copenhagen interpretation to the many worlds interpretation. Imagining such thought experiments from the inside, that is, having described it subjectively as Einstein similarly imagined the physically impossible thought experiment of writing a beam of light from the subjective point of view, challenges our classical received views of consciousness, subjectivity, and identity. Are you on Mars and you on Earth the same person? Well, let me just move to the next slide. Okay. If yes, the classical received view intuition that a person can't exist more than one place at a time is violated. If no, the classical received view intuition that who you are can't depend on who else exists is violated. Either way, we need a better view. Okay, so let's call the pre-teletransporter person the one who got up that morning and drove to the teletransporter station, P1. The person who, after stepping into the teletransporter and being scanned, but due to the glitch, was not sent to Mars, is P2. The reconstituted person on Mars is P3. There are four mutually exhaustive and collectively exclusive possibilities. P2 and P1 P2 is P1 and P3 is not P1. 2, P3 is P1 and P2 is not P1. 3, P2 is not P1 and P3 is not P1. 4, P2 is P1 and P3 is P1. Which of the 4 possibilities best describe the situation? So I've already suggested possibilities are facts, actualities are interpretation. Now, in 20th century physics, the classical notion of crucial experiments that can resolve theoretical issues through the elucidation of critical facts has become moot. From the Einstein Bohr debate to the question of the collapse of the wave function, different interpretations ensue, each of which has bizarre and mind-boggling implications for classical intuitions of space-time, matter, and identity. This frustrates scientists, but not the progress of science, which at the most fundamental level of quantum mechanics now routinely engages with metaphysics. Having to give up classical intuitions may be mind-boggling to some, but of course not to those of us who have understood Berkeley, Kant, no less than their 19th century German idealist pioneers, Hegel, Fichte, Schelling, Schopenhauer, and their 20th century avatars, Husserl and Heidegger. The facts don't settle the question of identity. And that the question of identity is a metaphysical question is nowhere more evident than our fission thought experiment. Suppose, for instance, we had an oracle who knew everything about what happened in the teletransporter case, all the physical, neurological, psychological facts. The oracle would not be thereby able to unequivocally answer the pertinent question: how many persons are there conversing on that Zoom call? This in itself, meta-theoretical, metaphysical result is not trivial. What does it mean that this paucity of facts fails, as it were, to nail down the metaphysics of the situation? The conclusion Derek Parfit and other reductionists draw from the paucity of facts problem is that, in their view, the answer to the personal identity question is empty. Thus, in Parfit's classical version of the teletransporter thought experiment, in which you're told that because of the glitch, you, the one on Earth, will die in a few days, don't worry, because the one on Mars will go on living. The question of whether you should be worried or not about whether you will die is irrational, for there is no true or false answer. And here, the claim that I am about to die, says Parfit, would be neither true nor false. If I know the facts about both physical continuity and psychological connectedness, I know everything there is to know. I know everything, even though I do not know whether I'm about to die or shall go on living for many years. Now, Parfit sees clearly, but of course it's standard first order logic, right? But I'm not going to go into that now. Parfit sees clearly that physical and psychological facts can't answer the identity question. Why does he think they can't? Because there's no further fact of the matter. That's his reason, reasons and persons. Yet it is precisely here that the anti-metaphysical limitations imposed on classical thinking about personal identity binds the understanding. No less than quantum physicists boggled by the paradoxes are limited by a paucity of what the logical positivists banished from the 20th century philosophy, namely metaphysics. In his groundbreaking Reasons and Persons, containing hundreds of pages on personal identity, Parfit says only this about what a person is. To be a person, a being must be self-conscious, aware of its identity and its continued existence over time. But what is existence? Self-consciousness, consciousness, being awareness. And what does awareness of identity consist in, as well as the awareness of one's own continued existence over time? If you stick to ordinary language, you run out of philosophical fuel here fast as a physicist or mathematician would be stuck without the formal language of mathematics if you limited your thinking to ordinary words in ordinary language. You need technical and formal terms. With apologies to the good Ludwig, whereof one cannot speak, thereof construct a technical language. Now, the personal identity puzzle cases discussed in the contemporary mainstream philosophical literature in the analytic tradition by and large do so by focusing on how one should rationally answer the puzzle, given some particular theoretical ontological commitments: bodily continuity, psychological continuity, brain identity, animal identity, phenomenalism, materialism, and so on. As if the question of personal existence were something to be decided by lawyers analyzing previous legal precedents of word usage. Instead of theoreticians wrangling over conceptual issues about how we ought to decide the personal identity question, we start by noting how and why a person in that situation would think, regardless of any such ontological commitments, if that person lived as a conscious being in that situation. Let us therefore proceed by considering not the analyst's interpretation of the above well-known sort of fission thought experiments through his theory, but rather the subject's response. You are P3 on Mars. It would certainly not be unreasonable or irrational to believe that you are P1, congruent with interpretation 2 and 3 for several reasons. You know that you exist by virtue of the cogito, that you're you. You're not dead, you're alive. You might wonder on human grounds how old you were, perhaps only an hour old, but not whether or not you existed. The teletransporter might be able to fool the mass energy out of which you're constituted into thinking that you now are the same person who stepped into the teletransporter on Earth or just a replica. But it cannot fool you into thinking that you exist as such if you do not, that you are not you. Indeed, you may, by extension, naturally prefer your own privileged point of view. And though you might well be ready and willing to attribute consciousness to P2 on Earth, you twist on the problem of other minds because you do not have the same sort of direct first-person Cartesian certainty of access to P2's consciousness as you do to your own, on the basis of which you might prefer interpretation 2 to 3. But neither response would by itself be irrational. B, you have psychological continuity and or connectedness with P1. You remember everything that P1 remembered. You, P2, believe on the basis of your own testimony, based on what you remember, that you are P1. This might be only seeming memory rather than actual memory, which raises further familiar general sorts of philosophical conundrums, such as whether psychological entities, minds, are more like rocks, paintings, and statues, or more like symphonies, lithographs, and poems, adding still further to the uniquely privileged position that you are P1. But all else being equal, neither interpretation 2 nor 3 would, on the face of it, be irrational. C, you have physiological continuity and or connectedness with P1. You resemble P1 not the way a forgery of the Mona Lisa resembles the original, but the way an exact atom-for-atom duplication resembles it. One could even evoke Leibniz's principle of indistinguishability here. Consider, on the other hand, that you are P2 on Earth. Similar considerations, A through C, figure into our thinking about your thinking through the thought experiment from your P2's point of view on Earth. What about interpretation 3, that neither of you are P1? Some notable philosophers, Nozick, Shoemaker, others, argue that ties destroy identity. Nozick, the closest continuor view presents a necessary condition for identity. Something at T2 is not the same entity as X at T1 if it's not X's closest continuor. And closest means closer than all others. If two things at Tx tie in closest to X at T1, then neither is the same entity as X. So, oops. Let me go back to that slide. Likewise, Parfit. In the imagined case where I divide, personal identity cannot take a branching form. I and the two resulting people cannot be one and the same person. Since I cannot be identical with two different people and it would be arbitrary to call one of these people me, we can best describe the case by saying that neither will be me. Now, to his credit, Parfit realized there's something not just arbitrary, but downright weird about verbal maneuvers more suited for legal documents than philosophical analysis. Indeed, much of the personal identity debates over the past 40 years have the curious format of legal reasoning. Often one starts with a position one wants to defend: animalism, psychological continuity, bodily continuity, etc., and then argues for their preferred interpretation according to logical rules of reasoning, evoking notions such as transitivity, commutativity, etc. Parfit, however, steps further than most into the existential dimension. Some people would regard division as being as bad or nearly as bad as ordinary death. This reaction is irrational. We ought to regard division as being about as good as ordinary survival. Now, what about interpretation 4, that P3 and P2 are P1? The problem, of course, is that until the result of my doctoral dissertation provided, ordinarily we cannot coherently imagine how it is possible that one and the same person can exist in more than one place at the same time. Certainly, it was well nigh impossible to conceive coherently using language derived from ordinary experience, in which wherever my brain goes and body go, there I go, etc. Because this constant covariation, we naturally and critically assume not only causality, but also identity and necessity. That without my brain and body, I cannot survive may turn out to be as antiquated a notion as the idea that without vinyl or compact disc, a song cannot continue to exist with identity. As Parfit astutely points out, what is the difference in having your cells replaced one by one during, say, a 7-year spaceship voyage to Mars, our cells and constituent matter constantly being replaced, and having them replaced all at once? Likewise, even identifying my existence and personal identity with my memories, my personality, my psychology, and so on, in itself, a vestige of old 20th century thinking about a perennial philosophical problem, making metaphysical judgments without doing any metaphysics. Those of us, whether we are phenomenologists, phenomenalists, idealists, objective, subjective, transcendental, or neurologists, neuro-ophthalmologists, cognitive science, neurophilosophers, quantum physicists, who know that when you hold up your hand, what you're seeing is not made of atoms, but of mind, shades of Hegel. How does the mind appear to the mind, this non-mind, may be less resistant to the idea that matter is not what matters primarily in our continued survival over time. If you're the young, old version of Peter Unger, Why There Are No People, I Do Not Exist, titles of his articles, or the new old new version Peter Unger, We Do Not Exist, but only for a few years. I should explain that. I'm in the office, that quip, it's a joke, but it's true. I'm in his office, Derek Parfit's there, and I say, it's kind of disappointing, Peter. As a young man, you claim there are no people, that I don't exist. Now, your new book, Consciousness, Identity, and Value, you claim, well, we exist for short periods of time, a few years. He says, well, Dan, I was a young man. When you were, when you first started out, you said we're all the same person. By the time you get to my age, you're going to say that we're only a few more people. All right. That's why I say the old new version. All right. So unless you're a Luddite who insists that you can't truly be experiencing, for instance, Miles Davis on your iPhone, that you have to have the actual vinyl or CD, regardless of audiophile nostalgia, that values it, you might argue that P2 is P1 because P2 is the same physical body as P1. But first, P3 might well point out that P2 has been to Mars before several times. Second, and more on to the point, do we really care whether we are listening to Miles Davis on a CD or iPhone? One can imagine switching between the two forms every second, such that nobody would be able to tell the difference and would likely say, so what? I can't resist. I know we're short on time, but I gotta say it. So what? So what? I should have had it keyed in and played it. Best jazz album of all time. If it turned out that all the atoms in our bodies were replaced without our knowing it, down to each quantum particle, every time there was a solar flare, would it mean that we exist only in tiny Buddha instants? Physical substance views have gone the way of metaphysical substance views. Once it was realized that exchanging souls, that which makes you, was a meaningless concept. Now, what makes it natural for P3 to believe P3 is P1 and for P2 to believe that P2 is P1 is psychological connectedness and or continuity. For instance, it is your P3's memory of having stepped into a teletransporter, etc., that makes you identify yourself as P1. Likewise, it is P2's memory. Now, that makes P2 identify as P1. Now, first of all, if we varied the teletransport example, such that your current, as I do in my various publications, such that your current memories are snagged for a couple of hours in hyperspace and you stepped out of the teletransporter on Mars, dispositional memories intact, not knowing who you are, you would still exist, but with amnesia. You might exclaim, I don't know who I am, but this experience of finding yourself without knowing who you were would, cogito ergo qui es, would be nothing like that. Indeed, the awareness of your own existence might in such cases be existentially heightened. That ordinary amnesia arguably does not destroy identity, such that memory is neither necessary nor sufficient for personal identity, is reasonably supported by a slew of similar sorts of thought experiments. Secondly, and more importantly, the conundrum we are thrown in from the standpoint of the ordinary classical received view of personal identity, predicated on the notion of identity being a one-one relation and the presupposition of physical locality, already deeply questions as we've seen in quantum physics are in this example violated because psychologies like information structures, music, books, poems, can fission in ways that physical objects cannot, though there are already examples where they can. But once we realize that a person is not a localized physical object to begin with, we are freed from such classical received view constraints to ask what other than physical and or psychological connectedness and or continuity is there in which the person consists. In a word, consciousness. Now, to talk openly about consciousness raises thorny, unresolved metaphysical issues in any setting. What is the principium individuationis for consciousness? And what is consciousness? The entire stormy debate on personal identity over the past 40 years has been, if anything, a concerted effort to avoid having to ask the former and define the latter without doing any dreaded metaphysics. It is this I, the subject of personal identity, that, unlike the notion of material objects, exists in itself, not as a one-one, but a one-many relation, finding itself as P2 and identifying with P1, finding itself as P3, likewise identifying itself with P1, that in our thought experiment above makes it possible to conceive how one and the same numerically identical person, the subject in itself, can, contrary to our common sense received view intuitions, exist in different places realized in two distinct brain hemispheres, by the way, at each place at the same time. What fools and limits our ordinary reasoning is that ordinarily we mistakenly suppose that the contents of consciousness, e.g. memory or other some such psychological relations, are necessary or sufficient for personal identity. Or if we are materialists, that the physical realizer of consciousness, e.g. the brain or some such physiological relation, is necessary or sufficient for personal identity. Whereas these relata are neither necessary nor sufficient. The identity of the subject in itself is not defined by its content, but by the fact of its existence. The subject in itself, consciousness, is the invariant in the personal identity equation, the existential dimension of our existence, the there being that is in each case mine, Dasein. But what is that? Let us define the subject in relation to the subject in itself as follows. What the first person indexical I can be said commonly to denote and express can, from a logical linguistic model theoretical standpoint, be given an intended interpretation in terms of the collapse in the quantum mechanical sense, or compactification in the topological sense, e.g. Stone-Chech compactification is Marshall Stone, of the absolute in Schelling's or even Hegel's sense, or transcendental in Husserl's, or even better yet Brouwer's sense, subject into the immediate in Schopenhauer's sense, residual from the act of objectification, compactification, etc. Literally subject in itself in relation to which phenomena, e.g. perceived objects, objectifications of the subject, i.e. the mediated objectified identification of the subject qua objects of experience, i.e. object intuitions, are individuated and identified in perspectival, i.e. subjective space and time from the first person point of view, i.e. observed. Commonly denoted and expressed simultaneously to speaker and hearer, i.e. communicated, using the first person indexical I, the subject in itself is our refinement of what in many philosophical circles is traditionally regarded as a fundamental and essential, perhaps even primitive in the positive sense, desideratum of personhood, namely what generally goes under the rubric of consciousness. Now, I'm not going to go into the Stone-Chech compactification theorem and so on, I do so in my book, but the pivotal distinction between the subject and the subject in itself, in terms of which I have cashed out the distinction between consciousness and self-consciousness, is somewhat technically, again, spelled out in the following way. So consciousness is the subject in itself in relation to which objects are individuated and identified in perspectival space and time from the first person point of view, i.e. observed. Individuation and identification themselves being intuitions of objects in space and time, respectively, denoted and expressed simultaneously by the first person indexical I. Self-consciousness is the intuition of the subject in itself, resulting from the cross product of the space-like intuition of the subject, what we might think of with a slight variation on the theme by Husserl as internal space consciousness, and the time-like intuition of the subject, what we might think of again with Husserl as internal time consciousness, denoted and expressed simultaneously by I am I. So consciousness is not the same as self-consciousness, which is over and above that. So what then exactly is this that is over and above that? What is self-consciousness over and above the human Buddha non-existent self, a psychological entity structure, some such psychological, physiological bundle of relations analyzable into reductionist eliminative elements is defined by self-consciousness here. In other words, the subject in itself is what consciousness in itself is, and it is the subject's own intuition of itself that is what self-consciousness in itself is. And it is this metaphysical subject, not abstract but immanent, that makes it possible under the various transformations in the thought experiments, no less than in our ordinary waking states across various changes over time, physical and psychological, that makes it possible for me to identify myself as the same person over time. What are its boundaries? Is the metaphysical subject, the subject in itself, limited to existing at only one place at a time? As we've been suggesting, the answer to that question is a resounding no. And that is why the best answer to our fission thought experiment is I am both P3 on Mars and P2 on Earth. But here's the twist. Not because P2 and P3 have the same memories, the same psychology, the same physiology. It is because even without these, we are one and the same numerically identical conscious being. You and I are different human beings, different psychological and physiological entities, different selves even, insofar as our received view conceptual framework insists we format our thinking about physical and or psychological objects, e.g. that one and the same numerically identical object can't exist simultaneously at two different places at the same time. Not so for the subject. Indeed, moreover, still further over and above self-consciousness is what I call moral consciousness. Moral consciousness is defined as the intuition of the subject in the not itself, denoted and expressed simultaneously by I am you. Now you, referring not to the physiological, psychological realize of the contents of your experience, but to the subject in itself there, identified as that particular self-mind-body complex, are just me with different memories, a different psychological makeup, a different physiology, etc. In harming you in any way, I harm myself. In respecting you, I respect myself. For all the complexities of our technical language and metaphysical contortions some may find uncomfortable as yoga, the solution is frighteningly simple as it is existentially frightening. How one responds to puzzle cases, such as the fission thought experience, has split philosophers from the traditional received view, what I have called closed individualism, into two revolutionary camps as follows. Closed individualism is the standard traditional received view, which doesn't work. Personal identity is closed under our known individuating and identifying borders. We are each a separately existing person numerically identical to ourselves over time. As David Wiggins famously says, you know, we all think we know what a person is, then how can such a variegated multitude of apparently insoluble puzzles lead to so many implausible interpretations and so on and so forth. So empty individualism. This personal identity is not what matters in our continued survival over time. There are no continually existing self-identical persons that exist over time with identity in the sense of ordinarily understood. This is the view of the original Peter Unger, Derek Parfit, Nozick Shoemaker, and other what I now classify as empty individualists. And then there's open individualism. Personal identity is not closed under our known individuating and identifying borders. We are all one and the same numerically identical person. Now, your existence is a fact. It is a fact for you. Your identity is an interpretation even for you. The fact is that the imagined example does not seem to me at all like death. I can perfectly well understand and believe that what matters to me existing as me would still be there existing as me. How is this possible? What that is, one might formally been tempted to answer nothing, except we have the next least worst answer, consciousness, the subject in itself, the I of personal identity, almost but not quite nothing. Wittgenstein's famous, the I shrinks to an extensionless point, and there remains the reality coordinated with it. That word coordinated. Now, what makes it difficult to believe in our fission thought experiment that you, P2, are also there, and that I have survived across all the transformation, is that in your ordinary day-to-day conscious life, you've only been in one place at a time and have accepted without argument or thinking critically about it that you can exist at only one place at a time. But such are the intellectual constraints imposed upon thinking by the nature of our existence, derived from our pre-reflective thinking about the ideas of matter, body, object, identity, and so on. They're logical, conceptual, philosophical constraints imposed upon us by ordinary language that color our metaphysical presuppositions. But as the experience of teaching philosophy to our students repeatedly demonstrates, as laypersons, ordinary folk rarely distinguish between the sensation of their own existence, which they equate with self-knowledge, and the Cartesian certainty which such knowledge can actually be founded. What matters in epistemology is not what you believe, but so much as how you came to that belief. And the way Descartes gets us there is by doubt. It is by doubting our existence that we thereby learn, because although I may be fooled by many things, it is necessarily I who is thereby fooled, and therefore I'm at worst, as I like to put it, almost but not quite nothing, the existential epicenter of the phenomenal world in which I find myself. This, of course, raises a cosmological, ontological conundrum: how to integrate in general our various points of view on the universe in which we, or should I say I, live. What is this phenomenologically divided yet transcendentally identical being? I am, yes, but I who? I the self? No. This self is a phenomenologically border-bound psychological bundle that I am identified as, and in which I, qua the subject in itself, consciousness, the I in relation to which said phenomena, objects, are individuated and identified, localized, I observed, am in turn thereby reciprocally localized, i.e. situated in relation to said objects. So whereas the psychological qualitative identity, i.e. identification of the self, is necessarily phenomenologically border-bound, the personal numerical identity of the subject in itself is not phenomenologically border-bound. By the way, the mirror, Ramachandran mirror neurons, which studied in my cognitive science lab, fascinating. There's a physical realizer component to all this too. That plays itself out there. Also talk about already in my Springer book. The philosophical problem here from a purely phenomenological point of view is how to integrate our concept of the subject in itself with what from a phenomenological, conceptual, and even semantic point of view appears not as subject, but a manifold of objects that presents itself to itself in experience, not as a me, but as a world, the phenomenal world within which the subject in itself consciousness, the I of personal identity, is projected and situated through identification as a particular phenomenal self, which I define as follows. So there's the phenomenal world. It's the totality of the perceptual manifold that ordinarily I call my world or my experience of the world, in which I find myself located as an observer without a directly observable head, apparently watching and experiencing the unfolding events from the perspective afforded through identification as a phenomenal self, individuated from the perceptual events, etc. Then there's the phenomenal self, the exclusively conjoined locus of motion and intentionality within a phenomenal world, whose experiential and conceptual borders are drawn along the phenomenal body-mind, along physiological and psychological perceptibles, perceptibles being visibles and tangibles that the subject is identified as and individuated from the rest of the phenomenal world by phenomenological borders from whose first-person point of view I, the subject in itself, experience my phenomenal world. Now, my theory of the subject in itself, in terms of the non-locality of consciousness, provides three different metaphysical levels in terms of which the problem of the essential subjectivity of experience, which we are each the existential epicenters of our own phenomenal world, can be integrated into a Hegelian whole with varying degrees of topological connectedness or separateness as follows, and should be both more and less surprising that there are not one, but at least three semantically equivalent, mathematically askew modalities in which such a state or states require the person to be therein exclusively conjoined, subject of and to multiple perspectively askew modulo projective geometry sets of experiences simultaneously, wherein objects are individuated and identified, localized in multi-perspectival space and time from multiple independently dependent disjoint first-person points of view, namely in one multi-perspectival space-time manifold, two in multiple uni-perspectival space-time manifolds, or three in multiple multi-perspectival space-time manifolds. I call these weak, strong, and ultra-strong non-locality, respectively, as follows. Okay, all right, I'm good. I should be able to finish on time. So we closed world non-locality is the individuation and identification in one space-time manifold in relation to which the subject multiply exclusively conjoined to object within one closed space-time manifold. That's weak. Strong, many worlds non-locality is the individuation and identification, localization of phenomena, the objects of experience in many monoperspectival, i.e. subjective, ideal, imaginary, dream, etc., space-time manifolds, worlds, from the first-person point of view in relation to the reciprocally multiply localized, i.e. non-local, in relation to said objects in said worlds, subject, I, consciousness, multiply, exclusively conjoined to objects within multiple disjoint, e.g. Hausdorff separated, closed space-time manifolds. And three, ultra-strong, open-world non-locality, individuation and identification of phenomena in many multi-perspectival, objective, empirical, public, space and time manifolds, worlds, from multiple first-person points of view in relation to the reciprocally multiply localized, i.e. non-local in relation to said object, subject, I, consciousness, multiply exclusively conjoined therein to objects within multiple disjoint, Hausdorff separated open space-time manifolds. In one, what we have is one world, i.e. one closed multi-perspectival space-time manifold, and one non-local, mutually dependent, independent subject, multiply exclusively conjoined therein. In other words, you are an open individual living in a closed world. In two, what we have is many small subjective ideals, monad, etc. worlds, many disjoint, i.e. strongly separated, Hausdorff closed monoperspectival space-time manifolds, and one non-local, i.e. mutually dependent, independent subject, multiply exclusively conjoined therein. In other words, you are an open individual, in two, living in many closed worlds. In three, what we have is many disjoint, multi-perspectival, objective, empirical, real worlds, one non-local, i.e. mutually dependent, independent subject, multiply, exclusively conjoined therein. In other words, you are an open individual living in many worlds, all of which are themselves open. And of course, it was Jaak who pointed out to me that this disjoint, the dependence, independence can be cashed out in first order, in IF, which I've argued in print is first order logic. But in any case, in the first case, you are literally subjected to multiple simultaneously independent points of view on the one world in your experience, the multi-perspectival manifold of space and time within which objects are indexed as such in relation to the weakly non-local individuating identifying subjects, such that the necessity of the perceived phenomenological necessity of monophrenia would be falsified to the degree that multiphrenic states evidenced in that case what we might think of as insular or weak open individualism, where personal identity is not closed under such known individuating and identifying borders, would be vindicated insofar as such a state of affairs is actually evidenced, verified. In the second case, you are literally subjected to multiple independent points of view of the many worlds in your experience, the multiple monoperspectival manifolds of disjoint space and times, within which objects are indexed as such in relation to the strongly non-local individuating identifying subject. In that case, what we might think of as global or strong open individualism, where personal identity is not closed under such known individuating and identifying borders, would be vindicated, and insofar as such a state of affairs is actually evidenced, verified. You see what I'm getting to here? There's a verification possible here of my theory. In the third case, you are literally subjected to multiple independent points, manifolds of disjoint space and times within which objects are indexed as such in relation to the ultra non-local individuating identifying subject. In that case, what we might think of as cosmic or ultra open individualism, where personal identity is not closed under any and all possible individuating and identifying borders, would be vindicated, and insofar as such a state of affairs is actually evidenced, again, verified or ontologically grounded in our best scientific outlook on the world, quantum mechanics, which ironically is where I started, in physics, that the snake bites its own tail. Now, in his own doctoral dissertation, from which originated the various interpretations of quantum mechanics, generally known as the many worlds interpretation, Hugh Everett III sets up the subject of the conundrum that has so perplexed and puzzled not only Wheeler, who subsequently praised it as one of the most groundbreaking achievements in physics after initially making him cut out the weird stuff because of parts subject to mystical interpretations, but inspired generations of physicists and philosophers ever since. Misner told me that Everett felt like he was being tortured. Again, I find that's my dog analogy. I know the feeling. It is in its long version a protracted defense of the universal validity of the quantum description by completely abandoning the discontinuous change brought about by the observation of a quantity in which a state changes probabilistically, such that observation processes are to be described completely by the state function of the composite system, which includes the observer and his object system, and which at all times obeys the wave equation. It is this that leads to the famous many worlds interpretation, and indeed that is the section of Everett's dissertation that, under duress, having received his marching orders from Wheeler, Everett finally agreed in anger to cut, without which he couldn't have continued his job doing operations research at the newly former NSA. By the way, he had the highest security rating, Q, while he was developing the mutual assured destruction scenarios. Anyway, and why he never went back to academic physics. I here now provide, edited in Everett's own hand, a copy of Everett's typescript, which reads as follows. And before I read that, let me just show you, I got to see all this and was shocked, as I'll explain, when one of my former students, now executive editor, Princeton, was preparing all these for press. I saw this, and this is cut out. You can see on the screen on the right side. The essence of this theory is the abandonment. See how he crosses that out? I have seen actually even his original handwriting, which I have copies of.
Dan, can you hear me?
Let me go back to the other side so it's easier to read. This is the part he crossed out. The essence of this theory is the abandonment of the concept of the uniqueness of observers, i.e. that they are individual entities, machines, people, etc., which remain single, unique individuals throughout periods of time. In this theory, when measurements, or in general any observations, are made on systems by observers, by which we mean merely other systems, the observer itself splits into a number of observers, each of which sees a different, definite result for the state of the system. Now, all of this, which is seemingly quite far-fetched and contrary to our experience, is actually implied if one takes seriously the formalism of wave mechanics. This is again the part cut out. But what strikes me now with extraordinary interest, which when I first read Everett's papers that were prepared for publication by Princeton, absolutely shocked me, is that in his soul, I'm in 1 minute, 2 minutes to finish, is that in his so-called long version, he does not start out with that alternative. In fact, the source of the many worlds interpretation is labeled by Everett as alternative 5. He does not consider his own alternatives 4, 3, 2, and 1. He gives sound reasons in his formalism for rejection of his own number 4, number 3, and number 2 on the basis of inconsistency. And he's absolutely correct in his logical assessments. I've been through them, but nothing whatsoever as to why he does not consider his own alternative 1, which I'll give you in a moment at the end, just coming up to it. All he says is this view is quite consistent, is alternative 1. But one must feel uneasy when, for example, writing textbooks on quantum mechanics for the consumption of other persons to whom it does not apply. And why, pray tell, does it not apply? Here now is Hugh Everett III's alternative 1 from his doctoral dissertation. Alternative 1, to postulate the existence of only one observer in the universe. This is the solipsist position in which each of us must hold the view that he alone is the only valid observer with the rest of the universe and its inhabitants. So in the interest of time and sanity, I will stop here, except to end this, I like to say, well, there may be no God, except perhaps in Wheeler's sense, there is justice. In this case, apropos Wheeler's. In 1995, I received the facts from the High Energy Physics Group after a conference on self-containment, thanking me for, quote, your beautifully, clearly written book. When you next visit this little college town, please give me the pleasure of seeing you again, unquote. The little college town was Princeton. The author was John Wheeler. Thank you.
Thank you.
And before we turn to questions, which I hope there's a couple of minutes left, I want to always give the last word to someone else other than myself. My favorite quote from Kurt Gödel: if you understand yourself completely, you understand everything. Thank you.
Excellent. Thank you. I think we will discuss the talk we are moving now to dinner. It's a shame you can't be with us, but we'll do this another time. And because we have to empty the building. Yesterday we were very naughty and we stayed overtime. And in Finland, they can be a little bit strict sometimes. So anyway, but we thank you so much, Dan, and we will be in touch. And thanks so much for sharing with us. Excellent.
Thank you, and I thank you for the invitation, Pavel, with whom I've known for years. Privilege of working with you. We are both legatees of Hintika, and for this wonderful conference. Thank you. It's been wonderful. I've learned a lot. Thank you all.
Bye-bye. Bye-bye.
Bye-bye.
Ehkä jollain olisi ollut kysymys, mutta mä en olisi ehkä sitä vastausta ei ollut se enää kuunnella.